Hello, welcome everyone. My name is Payal Agarwal and I thank you all on behalf of the UNICOM team for joining us today. I want to start by welcoming and thanking all our speakers and panelists. We have a great lineup of presentations and panel. I also want to say a special thank you to our gold sponsor Mavel and our professional and community sponsor UK and Ireland Testing Board and Agnostic Agile, who have been sharing the conference with their communities. We invite and encourage you to put your questions and ideas to these speakers during the Q&A and the panel and make the event interactive. Please continue the discussion on social media via Twitter. The hashtags are in the event guide and also on the event website. We would hugely appreciate it if you could please complete the feedback form that has been shared with you by email along with the joining instructions. This feedback is valuable to us in shaping future conferences, and we thank you for taking the time to give feedback. I'll now hand it over to my colleagues who will start the proceedings. Enjoy the day. Thank you.
Hello and welcome to the conference. Thank you for joining us today. I'm going to give you a short demo of how to navigate the different tabs on the platform and how to join the session. On the top of your screen, you will see the different tabs of the event. The presentation session will be live streamed in the lobby. You can view the concurrent presentation here. Under the Sessions tab, all the presentation sessions are listed here. You can shortlist or bookmark the sessions which are of interest to you and it will show up in your itinerary. To visit the sponsor booth, please click on Expo tab and move your cursor up to the booth. You can also open the Maps tab to view the different booths. Once you are at the booth, please click on Enter Booth and wait for the booth representative to let you in. While you are waiting, you can view the handouts in the booth resources. In case you have any queries, feel free to hit us up in the main lobby chat and a UNICOM personnel will get in touch to help you out. We hope you have a valuable time at the conference. Thank you.
In the age of modern software development, shipping reliably and quickly to customers is essential to staying competitive. A key way that organizations are speeding up software delivery today is by implementing continuous integration and delivery pipelines and assembling DevOps teams to shorten the feedback loop between development and production. Because developers can ship code multiple times a day, the frequency of software releases outpaces QA tasks. How can you be equipped to test at the speed your customers demand? This solution is here for the modern software teams that dare to test in DevOps. Maple is an automated testing service that makes testing easy, reliable, and robust. Request a personalized demo today to see how Maple can help your team successfully achieve Dev Test Ops. Testing Nirvana.
Hi, my name is Jeff Thompson and I am the chairperson of the UK and Ireland Testing Board, the UK ITB. We are proud to be a sponsor of Test Expo and Agile and DevOps Expo. The UK ITB are the power behind the ISTQB exams across the UK, the Republic of Ireland, and wherever the English language is spoken around the world. We provide input to the ISTQB scheme itself in terms of syllabus content, etc., and we develop and manage the English language exams. If you have taken an English language exam, you will have taken an exam developed by the UK ITB. We are always looking for help and assistance in our role. If you are interested, please drop by our stand and let us know you are. Enjoy the expo.
My name is Alec McCutcheon. I'm going to be your MC, if you like, today, chairing the program. I'm absolutely delighted to introduce our first speaker, who's a good friend of UNICOM. I've heard Seb present a number of times. I'm very pleased to introduce Seb Rose from SmartBear. Seb is going to be presenting on microservice delivery without pitfalls? And there'll be some opportunity for Q&A at the end. So please have your questions for Seb. And I will now hand over to our first keynote. Thank you. Thanks, Seb.
Thanks, Alex. Unfortunately, I appear to be unable to share my screen despite our dry run a couple of days ago. So could someone in the UNICOM team please enable me for screen sharing? This session is going to be called, or is called, Microservice Delivery Without the Pitfalls. We are currently experiencing.
Please bear with us. It's okay, we're just getting it sorted now, Seb. So we'll just take a moment. Apologies. I'll just pop backstage and check.
So in the interim, my name's Seb Rose. I work for SmartBear. SmartBear is the company that acquired Cucumber Limited, which is the company that I used to work for. Along with Cucumber, SmartBear acquired all of the Cucumber founders: myself, Matt Wynn, Aslak Helisoy, Steve Took, and Julianne Biesman, as well as our other employees. So if you've got any Cucumber questions, head on over to cucumber.io, but Cucumber is being supported by SmartBear. So that should be okay. And there's a question, can we get the recording of the session?
Hi,
yes.
Seb. Sorry, this should be working now.
Okay, let's give that a try.
Could you let me share screen?
Let me just get that
Sorry
done.
again for that.
That's okay. Can you see my screen? Okay.
I can indeed. Perfect.
Thank you, Alex. Right, so the session's called Microservice Delivery Without the Pitfalls. Let's get started. I'm going to start by talking about software contracts. This is the agenda. I'll bring it up between each section, but software contracts is where to start. So in a typical application, I've labeled it X in this diagram, may have dependencies. Almost certainly it will have dependencies. So we have dependencies might be on database or some service in the cloud, or indeed dependencies on other components that we've developed as part of the application. And each of these dependencies has an implicit contract that allows the application X to rely on the services that are provided by these dependencies. The contract defines what the services expect from the application X, as in what input or what messages need to be passed, and also define what outputs X is entitled to expect in different situations. This can get very complicated in applications because we have many dependencies and we have dependency management tools to handle them. But for the purpose of this talk, I would like to stick with a much more simplistic view of this process, which is one component dependent on another. And I'm going to be talking about consumers and providers. I will label the consumer C. This is the component that consumes a service, that depends on a service, and the service that provides that functionality we call the provider. And again, there's an implicit contract between the consumer and the provider. The reason I'm talking about this will become clear as we go through the talk. This idea about having contracts between consumers and providers, or client and suppliers, as they used to be called, is not new. So Bertrand Meyer wrote about it and created a language called Eiffel, which had contracts as a first-class concept within it many years ago in the last century. When you have a contract, the reason for having a contract is because you as the consumer expect some benefits from that. You as the provider have your expectations of what the consumer is going to give you in return well defined. But contracts incur obligations. You've got to stick to them. So if you break a contract, then behavior can be undefined. So with these contracts, there are contracts between all dependent objects. There are some times when they're explicit, there are some times when they're implicit. So they might be explicit if you're using an open API specification. You have an implicit contract between a C# class and another C# class that you're calling, which is defined by the arguments that need to be passed to methods and so on. But there are lots of implicit dependent contracts as well within these dependencies. So let's think about how we manage these dependencies. So imagine that you, as a company or an organization, you have a consumer and you have a provider. So your one team is creating a service that's going to be used internally, perhaps to access customer accounts. And then you have a consumer, which is some application, which is going to display the value, the information about those customer accounts. And each of these components will be developed individually, possibly by different teams, maybe in different buildings, and you will build them, you will stick them into CI to make sure that they have implemented, or that they build and they work in the way that you expect them to. And then you'll promote them through to staging, where you might do some more integration testing. And then eventually, if everybody's happy and functionality is correct, they'll go into production. So this is a simplified CI pipeline, or at least CD, continuous delivery pipeline, but it's fairly typical. However, if you make a change to the contract at any point as you go through this, this process, how do you make sure that the version of the consumer that you have in production, for example, is expecting the same contract that is provided by the provider that's currently in production? Do we have to promote the consumer and the provider in lockstep? Well, when in CI, when in staging, when in prod, we might always expect that we can test that the consumer in any given environment, say staging, works with the provider in staging. But before we promote to the next level, if we wanted to promote consumers or providers independently, i.e. not in lockstep, we would also need to check that the consumer that we're about to promote would work with the provider that is currently in the next environment down the pipeline. And likewise, if we want to promote a provider, we need to make sure that the consumer that's currently in the next environment will work with the provider that we've just built. Otherwise, promoting that component on its own is going to break the build in that environment that we're promoting into. Beth Scurry, who has recently joined SmartBear with the Pact team, has a wonderful quote that she uses. And she says, if you can't deploy services independently, i.e. if you can't deploy your provider independently of the consumer, then you don't have microservices. What you have is a distributed monolith. And that's not just as bad as having a monolith, it's worse, because now not only do you have to do things in lockstep, but you have got them distributed around many different teams, many different organizations, and management becomes really hard. One of the typical ways of dealing with this sort of coupling is to use test doubles to decouple. Now, the term test double was introduced by a guy called Gerard Mézaros, at least I think he introduced it, in the last century again. And test doubles includes things like stubs, fakes, mocks, spies, all of the techniques that software developers use to decouple a component from the things which it's dependent on during early stage testing, such as unit testing. So let's just take a quick look at this to refresh our minds. So the common approach is that we write low-level tests, such as unit tests, that work against test double. For the purposes of this session, I'm going to call them collaboration tests, because they're essentially tests of a component where we are thinking about the collaboration it has with its dependencies. In the collaboration tests that we run on the developer desktop and in CI, we run these collaboration tests against the test double. We've decoupled our development of the component or the consumer C from the development of the provider P by using a test double. And the test double mirrors or mimics the behavior of the provider. By the time we get into production, of course, we can't use a test double. We must be using a provider. In fact, we typically start using the provider earlier on in the CI pipeline, probably in staging or someplace like that. And when we get there, we want to run our tests, and we expect them both to pass, as in the collaboration test on the developer desktop and in the CI stage of the build should pass because it's running against the test double which we've created ourselves. When we deliver that component into production, we expect it to continue working correctly because, of course, the test double is supposed to behave in exactly the same way as the provider behaves. However, what happens quite frequently is that when we using this approach, when the consumer gets promoted into production, we get issues, we get errors. And this is because there's some incorrect behavior encoded into the test double, or at least there's a misunderstanding between the consumer developers and the provider developers about what is required, about what the contract is. So at this point, let's bring in contract tests. Contract tests are there to try and ensure that the contract is explicit and can be automatically verified in the sense that we can check using automated tests that the consumer's understanding of the contract is in accord with the provider's implementation of the contract. I first came across this when reading the Growing Object-Oriented Software Guided by Tests mailing list. So the book Growing Object-Oriented Software Guided by Tests is quite dated now. It's written in Java by Steve Freeman and Nat Price, but it still remains a really good book. And associated with it was a mailing list on Google mail lists. And J.B. Rainsberger, who's a very deep thinker in this space, wrote some messages around contract testing. And what he said was that we need to implement contract testing systematically. So we're already writing unit tests, and unit tests which have mocks, stubs, fakes, test doubles are essentially collaboration tests, and they make assumptions about the contract, and those assumptions are encoded in the test doubles themselves. But how do we know that those test doubles accurately implement the behavior of the provider service, provider component that we are stubbing out? Well, we don't. What we have to do is create contract tests to try and justify those assumptions. And one way of doing this is to write a contract test. And that contract test essentially runs the same set of code against the test double and the live service and makes sure that the result is the same, or at least sufficiently the same to give us confidence that the test double implements the behavior of the provider, implements the contract correctly. And for many years, we had to hand roll our contract tests. We had to create an interface, implement our test double behind it, then connect to our external service as well behind the interface, and be able to switch between these two different implementations from the contract test and run this contract test in our build. And that's fine, but it's kind of labor intensive because you have to roll this interface for every service, and it's quite repetitive. It's boilerplate code to some extent, which is where Pact and its associated component Pact Broker come in. These are Pact and Pact Broker are both open source tools to help us with contract testing. It simplifies the contract testing for microservices, and specifically Pact is targeted at HTTP services rather than any generic components. But it provides a mechanism for creating that contract and then gives you tooling that automates the implementation of the contract test between the consumer and the provider. Now this then decouples the development process and also gives us some tools to ensure that when we want to promote either the consumer or the provider into the next stage in the CI pipeline, we can check to see whether the dependency the dependency in that environment is going to work with us before we promote. And I'm going to try to go into a little bit of detail. I don't have a huge amount of time, but there's lots of help online that describes how Pact and Pact Broker work. So what Pact does is it says, rather than you create a test double by hand, use the Pact domain-specific language. And this allows you to talk about what HTTP responses you're expecting from your provider when you call it with a certain payload. When those unit tests are run, Pact then creates a mock HTTP server that your consumer interacts with, and all of the interactions are captured in what's called a Pact file, which is a text file which contains JSON information. That Pact file is then shipped across to the provider team, and the provider team then use Pact to ensure that the provider has got the same understanding of the contract that the consumer has. So it essentially replays the Pact file, this time sending the payloads into the real provider service and making sure that the responses from the real provider service are what was expected by the consumer. You may have to have some sort of backdoor interface to set up the state of the provider. That's an advanced detail that I'm not going to be able to go into in this session. So this is a schematic of what Pact does. The consumer CI runs the Pact DSL unit test, create a Pact file, which gets published to a Pact broker. So that's a central component that holds all the Pacts generated by all the consumers in your organization, at which point the provider then pulls down that Pact file and invokes the Pact test to ensure that the provider has the same implementation or the same expectations on the contract as the consumer does. And this is a more detailed interaction. As you can see, there are webhooks involved to ensure that the running, the fetching and the running of the provider Pact is done automatically whenever there's a consumer build. And there's a webhook that gives notification to the consumer of any results of those provider tests running. You'll see that there's a YouTube video link at the bottom of the slide. I encourage you to watch that for more details. Pact Broker then records the result of that consumer and provider interaction. And every time it runs, it records the version number of the consumer, the version number of the provider, and whether the contract tests, the Pacts, succeeded or failed. And that means that at any point in the future, we can go and look up and see which versions of the consumer and the provider will work together, because they will be listed in this matrix that's being managed by the Pact broker. However, if you remember back to my first slide, there are many components potentially that the consumer will interact with. The consumer itself might also be a provider to other components. So having just one consumer and one provider is not sufficient. We quite often have multiple different components progressing through the different stages of delivery, and we need to ensure that we understand which components work with each other. And for that cross-environment check that I showed in a much earlier slide, we also need to know which version of each component is in which environment. So this is also data that Pact Broker stores in its matrix. So the key points around Pact Broker is that Pacts are published by the consumer or by consumers. Pacts are fetched by providers that the consumers depend on. All the results are stored in the matrix, and that matrix is indexed by the consumer ID and the consumer version, typically the SHA from a Git repo. And this then allows independent deployment of components, because you can always ask the matrix, will this version of my component work in this environment with the current components versions that are installed and deployed in that environment? And if the answer is yes, it's safe to deploy, or rather it's safe to promote your component up to the next environment. And if the answer is no, then you have to work out what needs to change to allow you to promote your environment. You've given early feedback. So the takeaways are that contract testing using Pact increases confidence reduces the need for integration tests because it allows you to decouple using these pacts, so therefore speeding up development. This gives you the ability to deploy microservices independently with confidence that you're not going to break the whole ecosystem and without the need for doing lockstep deployments or masses of end-to-end tests with all of the components deployed. Contract testing is not a substitute for communication. So a failed contract test doesn't mean that either side is particularly wrong. You have to get together and talk to each other and see whether the contract needs to be changed, whether the provider implementation is incorrect, or whether the consumer's expectations are incorrect. And finally, it doesn't replace other testing. More tests are needed. You will still need to do unit testing. You'll need to do exploratory testing. There'll be a need for some end-to-end automated tests to ensure that the full deployment goes correctly. So there's still loads of other testing. What this does is it allows you to do less coupled and complicated tests earlier on in the cycle, but with retaining the high level of confidence that you can deploy microservices independently in later stages of the development cycle. And at that point, I would like to open it up for questions. Over to you, Alex.
Thank you very much indeed, Seb. That was a great session. Just before we start on the question, just to let you know also, Seb is going to be presenting again later on today. He's going to be talking on a different topic later on no code, low code and machine code. What level of abstraction is just right? So looking forward to that later. So Seb, thank you. Great session. If you'd like to type your questions into the chat, and we'll try and answer as many as possible. So it looks like the first questions come in. How are Pact Flow and Pact Broker different?
So Pact and Pact Broker are open source tools that you're free to go and deploy yourself locally and manage within your organization. Pact Flow is a commercial tool that provides a managed service. So I guess the first reason you might want to use Pact Flow is that it takes a lot of the burden of management away from your team. It's one less thing that you have to do. But also Pact Flow has some added functionality that won't be released as open source. This is your freemium model, I guess. We've got the free services provided by the open source tool. Pact Flow adds some other things. The cool piece of tech that's been added to Pact Flow recently is something called Bi-Directional contract testing. And what that does is allow you as a consumer to check whether to essentially run your Pact DSLs against an open API specification, a Swagger specification. It doesn't give you the same level of confidence as the consumer-driven contract testing that is described in the flow diagrams that I showed in the session, but it does give you some confidence that your consumers are at least adhering to the information in the Swagger, in the Open API specification.
Thanks, Seb. Just waiting for some more questions to come in. I've got one question about, actually from Dan asking, would it be possible to have the slides, and could you share the link to the YouTube video you recommended in the presentation?
So the slides will be going up onto my SlideShare account later today. So that's for sure from my side. I can share also the slides with UNICOM, who possibly have a mechanism for distributing it to delegates as well.
Yes, and we also share the link to the recording of the conference afterwards, so you can watch it again. Thank you. I'll just see if there's any more questions coming in. Oh yes, there's one more question. How is a unit test different from the contract?
So the unit test is a collaboration test. So when you have a component that you're testing under unit test, and you have stubbed out its dependencies with a test double, and what you've got is a test that is testing your component, but based on your assumptions of how the dependency is going to behave. And that contract isn't being tested by the unit test. The unit test is just ensuring that if the contract is as you assume it to be, then your code will behave correctly. Whereas the contract test is essentially ensuring that your test double is behaving in the same way as your provider that you're dependent on. So they work well together, but they don't replace each other. I hope that makes it that clear.
Thank you. Just see if we've got any more questions coming in. We've got a few minutes. Also, if I could just ask a small favour of everybody attending at this point, just a reminder that we have a feedback form. So as you go through the day, please do fill out your feedback form. Let us know what you think. It's really helpful for us to put the future conferences together. So thank you. I think that seems to be all the questions for now, Seb. I'm just looking down to see. I'll give it one more minute in case there's any more questions.
Sure. Well, you see my Twitter handle and my email on this slide. Feel free to get in touch with me over Twitter or email me at sebrose@smartbear.com. There's a question.
One more question.
Yeah. What are consumer-driven contracts? So if you're working within an organization where you have teams that are writing applications that require some sort of service to provide the information for them or provide them functionality, then consumer-driven contract testing can be really valuable. What happens is that the consumer team write their unit tests using the packed DSL, and then that gets shipped by packed broker to the provider team, and the provider team then implement the service to satisfy those packs. So rather than before development starts trying to agree what the API is and come up with an open API specification and then work to that, what we do is we evolve that specification by having the packed files drive the development of the provider service. And that's why it's called consumer driven. The consumer is driving the development of the service, which can be very useful, because obviously what we're trying to do is deliver functionality to our customers, to our users. So rather than having the provider dictate what functionality is available, it can be valuable to have the consumer essentially drive the design and development of the provider in a just-in-time sort of framework.
Thank you. I think we got literally got 2 minutes for one more quick question, if that's okay, Seb. The next question that's come in, is Packed Flow open source?
So Packed and Packed Broker are open source. Packed Flow is not open source. Packed Flow is a commercial product, and it's not an open source product.
Thank you very much indeed, and thanks everyone for some great questions there. We're absolutely spot on for time, so thanks, Seb. That's much appreciated. We're going to go on to our next session starting at 9:52 BST, which is the first session on low code today. We've got alternative sessions looking at Agile DevOps testing and low code through the day. So if you'd like to join us in our next session with Maureen on 5 pitfalls of low code, we'll see you there in a couple of minutes. Thank you. Talking to us today about 5 pitfalls of low code. So I will now hand over to Maureen. Thank you.
Thank you, Alec. I will share my screen now.
Thanks, Maureen. We can't see your camera at the moment, but
you
can see your screen okay.
My video, I don't know if my video, yes, okay, thank you,
That's
Alec.
working good. I'll see you shortly. Thank you.
Thank you. So, hi everyone. I'm honored to be here as a keynote speaker on UNICOM on 5 pitfalls of low code. I did a bit of this presentation before, but this time I need you as an audience. I hope there are also a lot of test automation people in the crowd, because I think test automation can really help low-code provide more quality to low-code development. And but I am not a TA kind of girl, I'm a low-code kind of woman. So please help me. I have a bit of views about test automation and low-code, but I need more input on that. So I'm here to share, but also to gain knowledge. So first, who am I? Well, Alec already said a bit. Besides that, I'm a lead consultant for Squarist. I'm also chapter lead for low-code by Squarist. And it got me the nickname Lady Low-Code because I talk a lot about low-code. So what to expect? I will go into what is low-code, because not for everyone it's clear what it is. Also, what is so promising about low-code? What's the hype? Also the pitfalls, and then how can TA help with that? So let's start with what is low-code? Well, I also always used compare it with Disney, because when Disney started making movies, they reused drawings, because making the drawings were very expensive. So by reusing their drawings and just changing a bit of the scenery or make like a log to a bridge, they could save money, time, and effort. And the same they are doing now with low-code. They make building blocks and they can be reused. You can change layouts, you can change parameters, but still the code is the same. And you gain with that you do not have to know about coding. You can just reuse those blocks. Most people, I think, will know WordPress, where you can easily click your own websites together. Well, that also is a bit like low-code. So what is low-code? Low-code is choose the blocks you need that were already pre-coded by the platform, build your application, and use it. It's that easy. So what does low-code promise? They promise you simple development. You have no need for coding skills. You can just use their blocks, drag and drop. It's fast and it gives value. You have a quick time to market and you save money. Well, it sounds like magic, but it isn't, because, well, people always want bigger and more. So I will show you 5 pitfalls that I see in my experience in my job. I will go into the icons later, but just for now, the subjects will be standards of low-code. Another pitfall is citizen developers, vendor locking, load in low-code, and performance in low-code. So standards of low-code, how to boil an egg. I do it always with a pan, hot water, and boil an egg and just decide if it's soft or hard boiled. Well, you can also put it in a microwave, but ouch, ooh, don't try this at home. I didn't try this at home. This is from YouTube because my partner wouldn't let me. But this is also what happens in low-code. If you try to lose sight of the manual and do not like build an application as is meant by the low-code platform, your platform might explode. And as we can see, it only explodes when there's 33 seconds on the clock, but it started with 5 minutes. So considering that, it takes 4.5 minutes into the process for it to explode. It can also take 4.5 years in building your low-code system before it explodes. You won't know when it will explode, but it will explode. So what you need to do is keep to the standards to boil an egg safely or to build an app safely with good quality. You still can customize, like you can have a hard-boiled egg or a soft-boiled egg. You can also have customization in your application, but you still need to work with the standards of low-code. So what can test automation mean for the standards of low-code? They can give you warnings, explosion warnings, by a dashboard. Most platforms nowadays have a dashboard where you can see, hey, we see this happen in your code. it's not how we would do it, or even this is dangerous if you do it like this. Change it, fix this. You do need to monitor that dashboard and act upon it. So that's very important. And a test automation engineer could really help with that. And you need unit testing. And as we have, and I will go deeper into what a citizen developer is, we work with citizen developers. Unit testing is not a best practice they know about. So a test automation engineer can help to give them insight in what is unit testing, how we can unit test, and also the platform gives options for that. So test automation really can help here. Then citizen developers. Well, let's talk about citizen developers as clothespins. As we can see, we can use clothespins for various uses. But in the end, the main thing is hanging your clothes to dry. That is what clothespins are for. And if we look at citizen developers, the real citizen developers are business users, product owners, business analysts, and by making them already knowing the business developers is what low-code was meant for in the first place. So you use their business knowledge to develop, but they get now multiple roles because they still need to think about how the business needs to work, to innovate on that. They still need to write their user stories, but they're also developer. So, oops, well, their core business might be in danger because if my clothespin also needs to cut cables or make cables rolled up and less easy to get in knots, then we might lose sight on the business. So how can we help the citizen developer? What can test automation do? Well, a test automation engineer can be a clothes hanger. He can help hang the clothes for the citizen developer. And how? It's a different way. He can provide assistance in unit testing or provide assistance in maybe even helping with development. So the citizen developer has more time on his hands for the core business. Well, then one of my favorites, the third pitfall, vendor locking. Because, well, a dad was listening to his two sons and they were saying, well, I want to build with Lego and K'NEX. I want to combine those two. But Lego wants you to buy only Lego, guarantees only quality when using Lego with Lego. It's the same with platforms. So this father was listening to his sons and said, well, you know what? I have a 3D printer at work. I'm just going to try and invent something, being the universal construction kit, as we can see in the image. And we also see this with platforms. Platforms do not want you to build with other platforms. They don't want you to use integrations, but companies want it. And so it is being done. And well, as we can see, the results with the universal construction kit, I don't think it's stable and I don't think it looks user-friendly. They got what they want, but is it what they need? It's compliant, but is it really good? Well, the same we see with platforms. Systems need to get bigger, more complex, things need to be added on, and it is all risky. But if people want it, if companies want it, you cannot prevent them from doing it. So what do you need? You need a builder advisor, a supervisor. Someone who can do your API testing, your integration testing, and make sure that everything works as it should be, that everything is tested and the risks are taken in account. Then load, the fourth one. Because it's important to start with whole systems being on one server. And that's happening a lot in low-code. One example, like with the Champions League final, where a lot of people came at once, a company in the Netherlands was sponsor of a big TV show. And in the commercial break, a lot of the viewers went to the website to buy the products that were also in the TV show. And the website shut down because there were too many people on. Well, no problem, you would think, because it's just a website. No, also the cash register system was on the same server, and the server was down, so also the cash register system was down, and the shops were still open because it was shopping evening. And there it went wrong because no one could buy anything because the cash register was out. So what we can see is everything is done in one place. And of course, people are already anticipating on that, but still it's a high risk to put everything in one server. The traffic in one moment can be then your downfall, and your complete system can crash. So what can test automation do? Well, it can make you sure that you have a risk analysis, you have a fallback by a load balancer. So if I have the possibility of 40,000 viewers of my website and number 40,001 enters, then I say you can go to the next server till there are 40,000 there, and then we can go to the next server. Or we can tell those who are plus 40,000, well, it's very busy right now. I'm sorry, try again in a few minutes. And that can all be automated. Then the last one, performance. We have bigger and more complex apps, bigger user groups, and also business critical apps and processes. So if I look at my work, we have applications that are really the core. So sales are in there, and pre-sales, and inventory, everything is in there. And you really need to make sure that if one bit is falling down, not the whole system crashes. So performance is really an important part of your risk analysis, because if you full system will crash down, you'll have like hop on, hop off, and you don't want that. If you want to buy something on a website, you want it to go there quickly. So you really need to know where the performance is leaking, what is going well in your performance and what isn't. So what can test automation do to monitor your performance, to know where the risks are? Well, they can check your source code. It can happen by the platforms themselves. They have automated source code analysis in them, but you can also ask an independent partner to check your source code. And they will check if you have made things different than the standard of the platform, or if you have like recurrent loops somewhere. They really will check if your code is okay. Besides that, you have after deploy performance degradation monitoring. And that was also very nice because you can do it on every environment. You can do it really like shift left on already development or the test environment, so that after every deployment, you can see, am I losing 1% of my performance, or do I not lose any performance, or maybe even 10%? Then you really need to do something. And if you do know that after a deployment, that's way better than if you know it in the end when you go to a production environment. And make sure you have a dashboard that will monitor it easily. Because if you have a dashboard, anyone can use it. You can use the information. You can have a quick overview of what is happening. So what I see now and what I hear from others in the field is, like a few years ago with regular testing on traditional coding, test automation is again, let's see, there's no time for it because it's getting bigger and more complex, but low code needs to be fast. It needs to be quick. So when companies think quality is already assured, and it isn't, because I always say, like Excel, I've got a license for Excel. It's working fine for me, but it doesn't say anything about my calculations. If I make a wrong calculation or use a wrong formula, Excel is not responsible for that. You are, or in this case, I am. So when companies use a platform, they really need to know what they're doing. And quality is not already assured, and not everything will be solved for them. And with test automation, you can very easily see where do I go wrong? Where are my risks? What can I do for myself to improve my quality? But still little to no time and resources are invested because like a few years ago in regular testing, we see, no, it's too expensive, it takes too much time. Yes, maybe in the beginning to make sure that everything is set up right. But if everything is set up right, it will work. And you will have, when your system is really big and really complex, a good dashboard, a good monitoring and what's happening. So
we just got 5 minutes. Just to
okay, thank you, Alex.
remind you,
I'm already, yes, I'm already rounding up, so that's fine.
that's okay. Don't worry, we got time.
So low code needs you guys. I know a bit about test automation. I've got really good coworkers that can help me, but I know that the real knowledge is to share knowledge with people in the field. And I hope you can help me because I know a bit about performance and a bit about test automation, but what could be real tools or languages or best practices that we already use in test automation that we can also use on low code? And I really hope you can help me. If you want to contact me and we do not have enough time in the Q&A or I don't know the answer yet, then I will definitely try to find things and come back to you. So reach out to me on LinkedIn, email, website, Insta, Twitter, YouTube. I'll be here. So this was it for me. Well, like I said, I hope we can help each other.
Well, thank you very much, Marilyn. Great session. It's certainly an eye-opener and very thought-provoking. We'll just see what questions are coming in. I can see one's coming already. So shall I read the questions out, Marilyn? And then hopefully we'll try and answer as many as possible. And I think also you're around for the panel later as well. Is that right?
Yes, that's right.
12:40. Brilliant. So, really topical at the moment. So there's quite a few questions coming. So the first one is, if I love developing and coding, should I still use low-code platforms? Good question. Yeah,
developing definitely, because you can use it like Disney uses their drawings. You can say, well, why invent the wheel if someone else already did it? And it's a good block of code. It's guaranteed block of code. Let's use that. But I really got some inventive, creative ideas for another part of the system where I think I can be unique and I can think I can make a real difference. Then I can use time and effort for that, and less time and effort on something that we use like on 600 places in systems, and that's been done for all the companies in the world. So you can really start using it for the easy parts of the systems. And I think that's the beauty about low code, and it's already happening. Quite a lot of developers say, I'm using it to make my work easier and have time and energy to put in the more complex parts of my job.
Thank you. Next question. Can we build complex enterprise level applications without coding?
Well, no. If I see what happens with core applications and important business applications, always there is a part of coding necessary, because the general blocks are really that general. And when you have your core business, some things are just very specific for your company, and that you will have to customize with coding. So citizen development is good for the easy parts, but for the more complex parts, you really need a developer who knows the platform, who knows coding, and who knows best practices in that. So building a full complex application, I don't think it's possible with low code or no code.
Thank you. I think actually it's interesting. The next question kind of almost follows on from that. And I'm guessing I might know the answer, or we might know the answer, but will no code replace software engineers and developers?
No, I don't think so. We do hear Gartner and Forrester say that like 75% of the applications will be built in low code. Yes, but still that will be the easy parts, and we'll see that it will get more complex. So low code will be also with algorithms and AI and machine learning evolve, but I don't think that they will ever lose. We still also need the developers making those blocks. We should not forget that. It's beautiful that we have those building blocks, but someone made them still, and he needed or she needed to code for that. So even if this will get bigger and more complex, those blocks need to be built by developers, and those developers are really high skilled because they need to make general blocks, so they have to have a lot of knowledge. So I don't think that we'll ever see the developers lose their jobs.
Thanks. Next question is low code here to stay, or will it hype out? How is its future? An interesting question.
Yes, I think it's a hard one, because at the moment I think it's hot and happening, and it will grow for a while. But we also thought that of blockchain and of crypto, and that's also a bit more rocky now. So I honestly, I don't know. I think it will stay in at least for a part, but if it will stay this big as it is now, I don't know.
Thanks. Okay, next question is, how customizable are the low-code platforms?
Also an interesting question. It's limited. So you can have your own layout and color schemes and things like that. Fonts you can change, but if you really want to customize building blocks or make differences on the system, you need coding, and that's also very risky and no longer low code. So customization is very limited. You must, I think, see it like changing from dark mode to regular mode. Things like that are very easily, but the harder customizations need coding, and therefore is not exactly low code anymore.
Thanks. Got another good question. Would you recommend low code as a starting point to beginning a developer journey? And are there any alternatives?
Well, to be honest, I wasn't much into coding, and then low code came in my life. And now I am working on some courses on how to develop a small application in several platforms. I'm also getting interested in test automation. So yes, with low code, it's easy to do some small steps. Further, I can advise Python. It's a fairly easy programming language. It's also used for Selenium. And is also known in the market as the low-code programming language, and not so much that it's used by low-code, but it's like low-code, a very easy point to start with. So it got me exciting on coding when I definitely thought that never gonna happen. So for me, definitely low-code was a good starting point.
Excellent. Thank you. I think I'll just see if we've got any more questions. Actually, I had a question of my own, if that's okay.
Yes.
Do you feel with low code, particularly in large organizations, are there cultural barriers? I mean, it is a big culture shift required, and different way of thinking in organizations to be successful with low code.
Yes, what we see is that a lot of companies that choose low code have legacy. So they use COBOL systems or Axapta systems, and they want to change it. But they worked with those systems for 35 years, maybe more. And we're also working a lot of waterfall, but low code is quick. So all of a sudden they choose a different way of development that needs to go quick, and usually turn to Agile. And that's a total way of different way of working. The developers that are already in-house need to learn to work on the platform, but they are much more restricted than that they would if they could build something in COBOL or in Accepta. So definitely culture changes and differences is a huge problem for projects, because they need to change their way of thinking. Like we said, I don't think that developers will lose their job, but that is for some people that they say, well, I had all this freedom, I could do everything, and now I need to do it in a platform and click a bit, and it's so much more restricted. I don't feel comfortable with this. So yeah, those kind of issues do raise in projects that I'm on, and I also hear it from coworkers.
Are you finding it works better in organizations that maybe already have an agile culture, that have agile teams and are kind of comfortable with that way of working?
Definitely, that definitely help, because they already have the flow of deploying quickly, and have also most of the time a different mindset to quality. Because if you have more the waterfall mindset, and you also say performance or load, well, we'll do that in the end. And when you have an agile environment, they say, no, after sprint, we need to know that everything is working. So they also want to do a scan on performance or security, or and that's good, because I see it now also with the big projects. They work agile, but still we're going live with the full system in like 2 years. And then you're really not working agile. There's not the urgency of, I need to be done in 2 weeks because it's going live and my customer is waiting for it. The real customer is only going to work it in 2 years. So to work agile, you also need the urgency, you need to drive, you need to hear from the customer, oh, I was waiting for this so long and now I'm working with it. And the next sprint you think, well, I'm going to make it even better. So yeah, I really think that it's better if there's already an agile mindset and an agile way of working.
Oh, thank you. That's really interesting to know. Marilyn, thank you. I think, and thanks everybody for some great questions there. I think you were pretty well spot on again for time. So thanks everyone for that. We are going to welcome Marilyn back later for the panel session. And in the meantime, we have our next presentation, which I really recommend you joining, is by Keith Watson. The subject's going to be the unreasonable man being a change agent for continuous delivery. That's starting in about 3 minutes time. So Marilyn, again, thank you for a great session, and look forward to joining you on the panel later. Thank you.
Thank you, Alec.
Thanks
Bye,
very
everyone.
much.
Thanks for seeing
See
me.
you later.
Bye.
Welcome back, everybody, and thank you for joining our next session. I'm very pleased indeed to welcome Keith Watson. Keith is Director of DevOps IHCM at ADP. Keith is an absolutely brilliant presenter. I think you're really going to enjoy this session. We've had the pleasure of Keith presenting at our conferences for a number of years, and they've always generated a lot of interest, a lot of feedback, and even had articles in the press following his talks. So they really are valuable. Keith's topic today is, I mentioned earlier, the unreasonable man or person being a change agent for continuous delivery. So without further ado, I will hand over to Keith. Keith, your camera isn't showing at the moment, but we can see your
I noticed
screen,
that.
okay?
I did check, and it said it was on, so I'll try stopping it and starting it again if you want. So let's start the video. Oh, I know why, probably.
Oh, perfect.
Yeah, can you hear me now? Good, great.
You can
good,
indeed.
Fine. Okay.
Thank you very much. I'll hand over to you.
Well, thanks very much, Alex. After
Thanks.
hearing your introduction, I can't wait to hear myself speak. But thanks for that introduction. I hope I don't let anybody down. Okay, so the topic for today is the unreasonable man, bracket person, because obviously it's politically correct, being a change agent for continuous delivery. I'm the Director of DevOps in ADP UK, responsible for rolling out a continuous delivery strategy for one of our products. And I'll give you some examples about how that's happened during the talk. But I'm trying to be a bit controversial here, in the sense that DevOps is all about collaboration between dev and ops, but when is it right to be reasonable and unreasonable? So a playwright called George Bernard Shaw, an Irish playwright from the late 19th century, said these words: the reasonable man adapts himself to the world. The unreasonable one persists in trying to adapt the world to himself. Therefore, all progress depends on the unreasonable man. And I think what he's trying to say here is if we just accept things happening, we just accept the way things work at the moment, and we don't challenge that, then nothing will change. And I showed this to my vice president once, and he said, so does that mean you think I'm unreasonable? Which had got a few laughs from the assembled crowd. But let's just have a little look about what that means. So interestingly, Bernard Shaw was around about at the time of the Second Industrial Revolution in the UK, and there was a loss of sort of resistance to the new tools and techniques, manufacturing techniques that were there at the time. But tools are only are a necessary condition for the change in DevOps, but not a sufficient condition. If any of you come across mathematics, you'll know about necessary and sufficient conditions. And often we see these diagrams in conferences like this about the tools, but DevOps is also about the processes and the people involved in using those tools. And like I said, things like automation will change the way people's jobs are and change their roles and change the skill sets. And it'll impact on people, and there's real people involved in using these tools. It's not just like a nebulous sort of set of tools that are used. It impacts the people who are using those tools, and people can react to these tools in different ways. Some of them can be very distressed about the change of tools or the change of their rules. Some people can be very neutral about it and say, well, what does it mean to me? And other people will be really happy about using a whole new skill set and growing their CV and growing their careers in the use of it. And it's important to recognize that when using these tools. And what I'll try and talk about in this talk is just how that impacts on the whole change process itself. So one example of another diagram that's often put forward is a move to managed services, where you're moving from on-prem to off-prem, and you might be using Amazon's infrastructure as a service, or you might be using their platform as a service, or whatever. And what that means is that the whole management of the way that you use tooling changes. For example, with infrastructure as a service, Amazon will do all the stuff to do with networking and storage and servers and virtualization, operating systems as well. But that calls into question the people who are employed by your organization who are doing all of that on-prem and how their role changes. And when I was in Ordnance Survey, we were trying to implement a sort of infrastructure as code model, and that impacted on the people in my team who were used to doing all of this work manually, and I was trying to encourage them to learn automation skills. And some of that people can feel, well, what's going to happen to my job? Am I going to be required by the organization going forward? On the flip side of that, it could actually encourage people to stay because maybe their roles they see are boring, or they don't see their skills growing. And in fact, I've talked to other people in organizations outside ADP and also people in my organization where we have a retention issue with people who have to continue to use what you might call the old style tooling. And they see all this Docker and this Kubernetes and Lambdas coming along. And some people have left because they can't gain those skills. So it's important for us to realize there's a flip side. You know, some people might react against it and some people be very much pro it, for example. So the next thing is how do you recognize the need to change? So I always like to use this in my slides because it's one of my favorite authors, Emil. And it says, you know, here's Edward Bear coming down the stairs, bump, bump, bump on the back of his head. He sees, as far as he knows, the only way of coming downstairs, but sometimes he feels there really is another way if only he could stop bumping for a moment and think of it. So when we're making change, people are quite already filled up with work during the day. How do we give them the time to automate their roles and all that? And again, this comes down to sort of, you know, whether they've got the energy and the time to do that as well. So how do we make that happen? When I was in Ordnance Survey, I joined a team which I came from a software development background. and I joined a team that was doing infrastructure provisioning for the software development team. So on the right-hand side of this screen, I was the Agile delivery manager for infrastructure, and on the left-hand side of the screen, there were the 3 or 4 teams that had Agile delivery managers producing software that's the Ordnance Survey government department were using to deliver applications to do the mapping data. And there was a big disagreement or wall of confusion between the various teams, because the image of the team I joined was very, very poor. A lot of the work was done manually. It took days or weeks to get anything out of the team. The team itself were quite demoralized. They felt the development teams didn't understand how difficult it was to provision machines. We could never provision some machines twice the same because it was manually driven. So initially, I engaged with the management team there in the first week I joined to say, what are the problems with the team? How is it not working? And I got a lot of interesting feedback from that. And then I asked some of my infrastructure architects to engage with the architects who were developing these applications to see how best we could architect solutions better. And one of them particularly, I got to start working on DevOps, because I'd come across infrastructure as code when I joined the team, and this seemed the ideal way of automating the way we provision systems. So we started looking at how to use Puppet to automate the provisioning of our infrastructure. And then this is where I started to be a bit unreasonable. I actually started moving some of my infrastructure engineers into the software development teams. Some of them were saying, well, why do I want to go work with the software development teams? I've got, they don't like us. They don't think we do a good job. And my team leader was saying, we've got problem tickets, volume of problem tickets we can't cope with. We've got a backlog we can't handle. Why are you taking people out of my team to put them into these software development teams? And I said, well, one of the things I want to try and get is we're going to use DevOps. We need to work more closely together. And I think it's a risk worth taking. And strangely enough, it took a few months, but we started to get less tickets coming in, and the tickets we were getting coming in were being a lot more cleaner in terms of the requirements gathering, because my infrastructure engineers were sitting in the daily stand-ups with the software engineers, and they were listening to what was required, and they were able to help them, advise them, for example, on sizes of RAM or the type of VM they needed, and able to sort of get work done a lot quicker. So in fact, me being unreasonable in a sense actually made the process a lot better. There's a lot more to tell about that, which I've spoken about in other presentations, but basically it worked. And strangely enough, it had a side effect that we started to do a lot of infrastructure automation. And some of the team were not software developers in my team. They were just operations team. They were used to running a process on paper or in a conference page and using Jira tickets. But I then was starting to put them on courses on how to do software development. And I started recruiting software development people into my team who understood infrastructure as code and started to want to do it. But also some of the developers were so interested in all this DevOps work that they actually applied for jobs in my team. And so therefore I was able to backfill some of the people who left because they didn't like the automation with people who were real software developers who understood where the software teams were going. So that was just one example from Ordnance Survey where being unreasonable actually worked out quite nicely. And my screens, there we are, right, sorry, my screen, right. The other thing was that this is like a value stream diagram. The horizontal sort of swim lanes are different departments having to do different work, provision infrastructure in Ordnance Survey. And as you can see, it's a very complicated process, being lots of handoffs between different departments, lots of people working manually. That poor guy at the bottom installing Oracle or installing Linux manually from his systems. Like I said, I had to start training people with Puppet skills and this, or put them on Puppet courses. And some of the people couldn't get a handle on this at all. I gave them enough time to try and do that, but some of them ended up being blockers to progress. And I'm afraid I then had to be a bit unreasonable. I had to give them performance management and I had to move them out of teams, and some of them left the organization. They couldn't cope. And this goes back to something I remember CEO of Xerox once saying to me at a conference. He said, Keith, you've got to give people time, but in the end, if you can't change the person, change the person. And so I literally changed the team structure, the team role and skills. And I initially started off with 15 people who were mainly operations teams handling JIRA tickets, doing manual work. And by the end of the 3-year program, we only had 6 people, 5 of which were just software engineers. And it seems hard to do that. I'm sure if I told them at the beginning that was a program I was going to do, some of them would have reacted against that. But that, in a sense, I had to be unreasonable to make the team more efficient. But in the end, I had an extremely happy team of 6 people who thought their CVs were growing and their skills they could use internally and externally in Ordnance Survey. So then the other thing, then managing the politics. So as I said, because you're working with people when you're doing a change program, you need to manage the politics. And Kurt Lewin came up with a very good model about 40 years ago called the unfreezing freezing model, where you're trying to change a culture or change a set of way of working, and you unfreeze it, you do the transition and you refreeze it. And one of the techniques he suggested when you do that is to use something called force field analysis, where you have in the center what you're trying to achieve. And in an ADP, I'm trying to achieve a continuous delivery strategy. And on the left, you've got the forces that enable change, and on the right, you've got the forces that resist change. And here's some of the examples of things I've experienced in ADP. So when I first joined, there was certainly executive support to move towards a continuous delivery strategy because they wanted to drive more faster delivery production. I personally had experience in DevOps before, so that was a very positive thing. And there were early indications from the development teams that there was support for moving to a more automated build cycle for delivering their application code. And also there are opportunities for microservice containerization, which obviously helps in a DevOps model. Whereas the forces resisting change, certainly in ADP, when I first joined, we had an R&D department that did DevOps, and we had an operations department that did DevOps. And the operations teams were quite resistant to any of the new tooling. And I'll come to how that impacted us later. The governance process is designed for monoliths. So there's a CAB, a change approval board. The infrastructure teams themselves, because I wasn't then running them in ADP, they were all in silos as well, a bit like Ordnance Survey was when I first joined. There's certainly a perceived loss of power by some stakeholders. So, you know, all the automation tooling that R&D were using was perceived as by some of the operations teams as them losing power on what they could do. And then actually the product itself had a monolithic product architecture. So some of the time it might be difficult to create those microservice containers anyway. So when you're doing a strategy of moving things out, you're trying to move forward, it's very useful to use force field analysis, well, I certainly did, to try and look at the strategy and the sort of programs you put in place, and also the unreasonableness of what you might want to do with certain things. Another model that I've actually developed myself is what I've called the Detractor enabler matrix. And this sort of tries on the horizontal bar to show what influence and power people have in terms of moving change programs forward. On the sort of vertical axis, you've got whether they believe in the change or not, whether they're committed to the change. And what you're trying to do is get as many people in the top right-hand corner, or at least the top half of the chart as possible. And then you have to have strategies to deal with people in the bottom half of the chart. So one of the examples I want to give you is what I mentioned about the operations team. So when we developed the new pipelines, we had a lot of support from the development teams in R&D, and that worked really well. We got to pipelines where we could deliver pre-production very quickly. But the operations teams were quite resistant to it, and they were the ones who controlled the production systems. So their influence and power was very high, but their belief in the change was low. So they became blockers to change within moving things forward. Fortunately, I had a VP who was in the top right, an enabler. And he was our R&D VP, and he actually took over the operations teams. And he effectively changed the people. He moved the operations responsibility for deployment to production into my team, or the DevOps team. And that meant that we were then the enablers. We were then able to, we had the belief in the change, and we had the power to make that change happen. So again, it was an unreasonable thing for him to do, in a sense, but it made a big difference. And not only that, we were able to absorb all that work into our team without an increase in resources, and it made us far more efficient getting the items from what you might call Bitbucket into production and operations. So that's another example of where, in a sense, being unreasonable and making a change, changing, if you can't change the person, made a big difference to us. And now we have a very, very smooth operation. The problem tickets are practically negligible. We get things into production regularly every week. And we have a common process right from R&D right the way through to the operations and production. So the other thing that I like to use when I'm developing change programs, again, is what's called the Cotter change cycle. And it has the following, as you can see in the cycle, sort of stages. They're not all in serial. Some of them can be in parallel as well. But the key thing about moving change forward, and you can find this model in the book references I put at the bottom of the chart, is that you need to create some sense of urgency. And when I joined ADP, the urgency was we needed to speed up the deployment of function into production because we wanted to get that innovation that was already in the product out as quickly as possible, rather than just sort of sitting in repos or being tested for months. And that was the urgency that we needed to have. The next stage is to build a powerful guiding coalition, which means bringing as many people together to support your change. Now, initially that was the DevOps leaders, but I knew myself I needed to get more and more people involved. So I had to reach out to architecture, I had to reach out to development. Again, at the time, I reached out to the operations teams as well to try and build a coalition of people who wanted to make change happen. And then I also created a vision for change as well. Now, because of going back to the matrix before, because I was in a position of I had high belief in change, but I had low power. So I needed to be more of an evangelist and an agent in that. So what I did was have one of the strategies was to do adoption by attraction, okay? Which means that we wanted to put the options to the development teams to say, look, these are new ways of building and deploying tools. But what we want you to do, we know we can't force you to do it, but what we want to do is show you how easy it is to do, and then hopefully you'll take those on board. So it's adoption by attraction. And some of you may have more power than that. Maybe you can do adoption by edict, I don't know. But for us, it was more of adoption by attraction. And that model worked very well, because what we were able to show to get the adoption by attractions, we took a few non-critical components that we could build and deploy separately. And we demonstrated through the pipelines that we developed that we could deliver features into production and demonstrate what's called the art of the possible. And that built that belief up. So again, going back to here, we were able to change some of the doubters in the middle of the matrix to become evangelists and enablers within their teams to be able to do the DevOps model. And then to sort of make that stick, what we were able to do with those pipelines is we were able to hand those over to the development teams so they could then build it, own it, and run it themselves, certainly up to pre-production. We still have to do the deployments into production. But again, that meant people could see, oh, wow, not only are these pipelines faster and quicker and easier to develop for these microservices, but what, you mean we can run them ourselves? We don't have to submit a ticket to you, so you have to build it and deploy it for us. So again, that helped meant the change could engage with it. Now, it didn't mean there weren't, some things that didn't go wrong during that. I had to be occasionally unreasonable and trying to sort of get some of the changes to happen. But building that sort of cycle of reinforcement is really important. And again, we kept having to do that time after time. You can't let up with the reinforcement because most people won't believe you. They won't turn from doubters into evangelists unless you show them the reality. The interesting thing was, once we'd done that, I was in a meeting literally last week where we were talking about a slightly different deployment pipeline. And one of the development managers said, look, if you're going to make a new deployment pipeline, you've got to make it better or easier than the one we've already got, because the one we've got from Keith's team is brilliant. So I didn't even have to do that. They were evangelizing that message. They were in that top left-hand side of that matrix. And they could see that we were delivering infrastructure and containers better, with better specs, better contracts, as somebody mentioned earlier on, quicker. That we were doing it faster. We were saving costs because, like I said, in Ordnance Survey, I went down from 15 people to 6. In ADP, we were able to absorb the operations work into the team without any increase in resources. The customers are happy. They were evangelizing the pipelines. We were working a lot more closely as teams with them, and they were starting to gossip about the pipelines. They trickle down to the other teams. We're getting a lot more teams coming in saying, can we start using your pipelines? So this is where it was being a bit more reasonable. We'd sort of approached it. We began to gain momentum and started seeing a lot more people adopt the tools and techniques. And we were using Ansible, we were using Jenkins Blue Ocean, we were using Docker, we were using Kubernetes. So it also reinforced people wanting to stay in the team because they could see that they were developing all those new skills. So they were the happy phase, if you remember the diagram from earlier on in the slide. They were the happy people who were saying, I'd like to stay. And the people who weren't involved in that, they wanted to join the team because they could see we were using all these new techniques. And I'm actually going to get a new graduate joining the team who originally he wanted to go and work in the development team, but he's liked working in DevOps so much that he now wants to join the DevOps team. So it's a real a retention and attraction thing for people joining your team once you move more towards automated deliveries. So what about the future? How else are you going to be reasonable or unreasonable here? So at the moment, I've talked very much about Dev and Ops, so the development team and the operations team, but it means we also need to start working with the test teams as well. And the test teams are going to see this as a sort of, if you look at the force field diagram, people are going to see that perhaps if we've left all the testing at the pipeline, what's going to happen to their testing roles, okay? Also the business, if we're going to start doing earlier testing, it means that I'm going to have to go to the business and say, can you slow down your development a bit because you really need to write unit tests tied into the soda cube in the pipeline so we can get to 100% complete. Architecture, we need to work with them because they're very keen to move to a cloud, and we want to make sure that we move in a controlled way so we have lots of a good operational model, a good supporting ecosystem in the cloud. Security, they're going to want to, at the moment, you know, they're obviously very keen for us to keep our products secure. So we have to work with them to say, how can we work with you? At the moment, we've started to include an application security workbench into our pipeline so we can show to the security team that we're being responsible citizens with the customer data and the applications that we're doing. Procurement and finance, you've heard of FinOps. We need to make sure that they understand what expense we've got, whether we need to have new tools or whether we start to use the cloud. Are they prepared to pay for our use of the cloud when we're still using the data center? Monitoring, you know, we've got to, if the development teams that build it, run it, own it, and they move into production, they've got to learn a whole set of new skills. So is it unreasonable to sort of start training them up in how to do operations? The cultural change that I've already mentioned, you know, that people will need to adopt different tools and techniques. They'll need to take on more responsibility. You know, if they're going to do build it, run it, own it, you know, Spider-Man says, you know, with great power comes great responsibility. It's not just a matter of shipping things into test. They've got to be on call, which is a change for their culture, possibly. Hold the phone, get into the production systems if things go wrong and resolve issues. And then governance as well. As I mentioned, there's the CAB that we have that is a change approval board. That is really about monolithic ticket-based approvals, whereas what we need to work with the governance team is how we can get to more automated approvals. So, you know, there's it's everything else really. When you're being reasonable and unreasonable, you need to sort of reach out with that force field diagram and look to see what else might prevent you moving your change program forward. And I'd like to finish with a quote from one of my heroes, Catherine Booth, who with William Booth helped set up the Salvation Army, if any of you are familiar with that in the UK. And she said, if we are to better the future, we must disturb the present. So when you're changing the world in your organizations, you know, and you're going to be reasonable or unreasonable, you need to disturb the present. And you obviously need to be sensitive about that, but at some point it may mean being unreasonable. So hopefully that's been an interesting talk for you. Hopefully that sort of sparks some ideas for you about how you might manage change. If you're interested, I'm on LinkedIn. I've written a few articles which have been published, which you might be interested in reading about. But I'm going to finish now, and Alex, I'm open for questions. Hopefully I've stuck to time.
Perfect. Keith, thank you. Great presentation as always. And I really enjoyed it. It's actually, I noticed this morning, it's actually ironic. It's very topical about changing the person, looking at the politics going on in the UK and news headlines earlier this morning. So,
Indeed.
I don't know whether that's planned or
yeah, we're all watching Twitter when he comes out with his out number 10. Yeah.
Excellent. So it's quite a few questions. First one is, coming. If you were to lead a DevOps transformation initiative, where would you start?
Okay, so it's a very good question. So I've now done it twice, once in Ordnance Survey, once in ADP. I think the first place I would start is engaging with the customers of your process. So for example, you probably saw in the diagram I put about engaging with the development managers in Ordnance Survey. the first thing to find out is where are the main problems. And if you're delivering infrastructure of development teams or you're deploying applications on behalf of development teams, in a sense, those are the clients, those are the customers, the operations teams, the customers as well. So I would start at the place to find out where the most pain is, because it may be that the most pain is in the relationship side. And that's why I put some of my infrastructure engineers into the development teams, just to sort of get them to understand a bit more of the pain that the development teams were suffering from the infrastructure team. In terms of ADP, I reached out very closely to the architects and the development teams to say, you know, what is their pain in the sense of delivering the software? So I would start with the relationship side. You do need to look at the tools. So the other side I would look at is what tools are available that have been purchased by your company to use. So we were very fortunate in Ordnance Server. I couldn't buy any tools, but we actually used open source Puppet to do our infrastructure provisioning. Within ADP, we had a really good selection of tools that were already available. And there was also some inner source tooling that was available from another team that we found was ideal for what we wanted to use. So you might find by looking internally at your internal teams, whether it be development teams or operations teams, there's already tooling there that you can make use of. So it's a combination of the relationships, finding out where the pain is and finding out what tools are available.
Thank you. I've got a few questions coming in. Another question that's come in, how can a tester contribute in DevOps-based culture to add value from their side?
Yeah, a very good question.
So to learn all these DevOps tools, please suggest.
Yeah. So you can see on the right-hand side of the screen, I wrote an article or contribute to an article about shifting left. So one of the things that I very was keen on is that development teams very often relied on the test teams to test their code. And to be quite honest, some of the developers didn't write unit tests. So when you're going towards a microservice-based architecture, it's a lot easier to develop unit tests and API tests and contract tests, like one of the speakers mentioned earlier, API tests in your pipeline for delivering that microservice. So I think a tester is absolutely vital for that. If you can become part of that team, you know, about the shifting left, you can be part of that team or an advisor of that team to help the development teams realize the importance of the testing, right, and bring your skills to that team. So for example, in our Scrums team, we do already have some QA engineers in those teams, but also to tell them what tests that you're running, which are finding the defects later on in the cycle. So if you can give them some root cause analysis on the tests that you're running and go and tell them about that, then they can be writing more defensive code, or they can write code that's self-healing, or they can write tests so that those sorts of bugs don't slip out, as it were, to the right of the cycle and get to you if you're in a UAT team, a user acceptance test team, or maybe whatever. So I think you're absolutely vital to that. Certainly you could be part of a Scrum team. At a minimum, you could at least advise them what defects are going through and how you feel they could test those earlier and discover those defects.
Thanks, Keith. Lots of questions coming in. I do apologize because we're not going to have time to answer all the questions. So I think, Keith, you're joining us later for the panel, I believe. And
yeah, I'm happy to go into it. If somebody wants to go into a lobby afterwards, you know, when you're in between talks, if somebody would like to do that, I'm happy to engage that. Or like I said, I'm on LinkedIn. My email address is keith.watson@adp.com. If you'd like to contact me afterwards and ask some questions, that'd be fine. It's a really interesting topic. I've always been really interested in people's side of DevOps. I mean, obviously I'm a technical person as well, but I'm really keen to sort of help. And I learned so much from talking to people as well about what their experience is. So it should be that's the thing about not being in person. You tend to get a more two-way conversation going and learn what's happening in other people's organizations as well. But yeah, very happy to link up in a chat or in one of the lobbies later if anybody wants to.
Thanks, Keith. That's great. If anybody would like to meet up in person, as it were, I know this is a virtual event, but we do have that facility. The best way to do it is if you go into the expo, you'll see the tab on the screen when you go back to lobby and then go into expo. If you go into either the Mabel exhibition booth or UNICOM booth, you can meet in there and see people and talk to them. I think you can also do that on camera. So it'd just be like at a physical conference. So thank you. Thanks again, Keith. We've got another great session lined up. We're now welcoming Nanda Kumar Ramakrishnan. Nanda's from ING bank in Belgium, and he's going to be talking on break the testing limits with containers, empowerment by test container platform. So we'll now switch over to the next session. And again, Keith, thank you very much indeed.
It's great.
See you in a bit.
Thank you. Take
Bye.
care. Bye.
Hi, Nanda. Hi, Saravanan. Good to see you again. Welcome back, first of all. Thank you again for joining us. Again, two fantastic presenters joining us today from ING Bank in Belgium. And the topic of this session is break the testing limits with container, empowerment by test container platform. And again, we'll have some time for Q&A. I think the screen's just coming up. We can't actually see you both on camera at the moment, but we can see the screen. Yes, I can see Saravanan now.
There is something trick to be done.
Yes, Nanda, you can switch off the video and switch on again.
Okay.
We can see the screen fine. So. You're welcome to. I can see Saravanan still. Yes, I can see you both now. That's perfect. Excellent. I'll let you carry on. Thank you very much.
Sure. So we start?
Yes, please. That would be great.
Okay. Hi, everyone. So today we will be looking into the topic called break the testing limit with containers. And of course, we empower this by test container platforms. So today's agenda will be something like this, starting with an introduction. Then we will go through what are my major testing challenges or limits. Then we will take our journey in container journeys, specifically in test container platforms, and looking at how test container platform and continuous testing helps us to hit the challenges or break the challenges. And then we go ahead with a specific rectifications on each challenges. And then we conclude the talk with a few highlights and a few pyramid informations which will help you. So without further delay, let me start with introductions. So today, what we are seeing in today's world is Agile is under the super speed and a heavy velocity. What does it mean? Today, there are development cycles which are happening very rapidly, and we want to put them into production, get the customer feedbacks, and then meet the expectations. And whenever we are doing that, the expectations in quality is topmost, and that is what we are looking forward. And this is irrespective of any industry, any sectors, this is exactly what we are looking at. And this speed and the velocity is never going to end and never going to slow down. And this is, very clear, patterns which we have seen it from last decades, and we are still going to see in a high velocities in the coming out decades. So that means for this current trends, we have to set our quality. The other important part is we are also trying to, get more and more complex and more technology savvy systems into the place. One of the thing is like people not only looking at cloud today, we are also looking at multi-cloud structures, multi-cloud solutions. So more and more multi-cloud, more and more cloud solutions are going to come. That means testing is also plays very important role. Quality, making the quality as a benchmark plays very, very important role. Now, not only in terms of multi-cloud, we also have, a good amount of challenges, good amount of trend analysis and changes in bringing artificial intelligence and artificial intelligence engineering, which is all your, your counters on machine learnings or your counters of deep learnings and so on. Wherever you see a machine learning, wherever you see, on the, robotic boxes and so on, all the bots, all the, AI behind the scenes are all going to be, new trending technologies. That means for all these new trending technologies, for a spectrum of testings, we need quality. We not only look at the quality in that age, we also look at the quality in other dimensions, that is UX and total experience. Yes, today we are not only, looking only as an user experience on web, only as an user experience in the mobile, we also look at a total experience beyond the web and mobiles, including wearables and so on. For a very simple, landscapes, many of you today using the multi-factor authentications to log in to get a secured things. That means on a laptop, you try to do something, you go to your mobile, get your authentication done, get your second factor, a green signal to the second factor, move forward, and then complete your flow. That means we are talking about a total experience across the device, across the ones. There again, quality plays very important role. What if something goes wrong? How you're going to ensure that every change release, every velocity of the agile speech, you are able to maintain that. And apart from that, the container and microservices world, that's again a new dimensions where it is rapid and heavily growing on. Now, whenever we talk about today, most of the cloud always comes with a cloud native solutions and so on, and people are driving towards the trend of cloud native solutions. And in a cloud native solutions, we are not only in the era where we talk about microservices, where we throw out our one and enterprise services and make it small and small and small microservices which are coming in. We are also talking in a trending world of micro front ends, and all micro front ends which might be deployed in various containers and so on is also a new trending technologies. Now, most of your companies might be using one among this or multiple among this at which you are trying to test it. And in the testing era, we are looking at a very long spectrum of testings, starting from a normal functional testing and automation testings, and security testings from playing a predominant role and so on. And this was a market studies to see that how a trend of testings and the cost of testings is increasing. And this testing markets and trend of testings from 2007 to 2020s, which is again $1 billion markets, very clearly says there is a predominant testing efforts and testing needs across functional, security, performance, and so on, which are basics and foundations of testings in order to keep up the new technologic speeds, what we are talking about, agile speed, multi-cloud, and so on. Now, for all these kinds of testings, for all this methodologies of testings, to cover all the trends and technologies of the world, please remember manual testing will never surface. That means we are looking only on automation approach. Automation approach is the only solutions at which we can surface the problem. And then automations on the task also brings in various other limits and so on. So in overall, if you look at it, in the new trending technologies of an agile speeds with the new trending technology of the technology called multi-cloud and containers, we are looking at a huge amount of challenges in front of us. Now, to note them, some of the top challenges, here we come with top of the challenges. So we pulled out some of the top challenges after studying various documents, various research analysis and so on. We felt that top of the challenges on testing is nothing but the cost on qualities. And again, a cost on a quality can be classified in a various forms in terms of resources, in terms of in the resources, we can classify in the various forms. We see that predominantly it is also sitting on hardware costs. And apart from that, the second most challenges, which we also see, is a test environment as a constraint. And then the third major challenges is, as an agile deliverable, are we able to hit the quality, bring the quality up to the marks in the speed and velocity? Now, looking at the cost and qualities, the cost and qualities of qualities is very, very important, because there we are looking at a capital investments in a significant amount. And when we are looking at a capital investment in a significant amount, we are not only talking with testing aspects in a cloud, testing aspects in a container, and so on. We are trying to see that how hardware resources for testing can be reduced and such that the cost of the quality can be reduced. Because we have already seen in the last slides saying that huge amount of testing needs to be invested on functional performance and so on, beyond special order testings like accessibilities and other usabilities and user specialized testings. So that means we are talking about a huge amount of testings including the hardware resources to what needs to be tested and how it needs to be tested and how and which tools can run it on. Now, apart from that, the testing environment and constraints also takes the predominant role, which is on a topmost notch on challenges and limits. That means test executions for each and every time is always a challenge and not always ready for to use. And it's always a backseat where when we ask for test environment, it is under the cooking table. We also see that time wasted for the teams getting blocked with the various environmental challenges is also incredibly increasing. There was a study done in Berlin almost in March 2021, where they said, hey, okay, let's look at a 40 hours work package and see how much time is wasted, specifically in environmental setups, in debugging and so on, not a constructive productions. The number came out as 39%. This is a very huge percent. What we are talking about is 39% of that 40 hours was specifically wasted in environmental setup and in most of the debugging cases. Please also remember in that 39% testing also plays very, very important role because development is one piece, testing is a multi-category piece, which we have already seen it in paragraph of a last slide. This also is the a clear trend analysis that we are having a huge amount of investment cost on the same. This also proportionality comes to the point number one of a cost and quality. So now what is that we want to solve this problem? How we are going to solve this problem? That is where we bring container journey to our testing. So to understand what is container journey or what is the basis of containers, let me deep dive with the basics. So what is basics? So to know the basics, let's focus to learn what is test container all about. It's just a container or it is something relevant to the test. To understand this, let's understand few years ago how the trend of technology was. Few years ago, the trend of technology was starting with a monolithic applications where we had everything on monolithics and then everything has to be tested. So in order to test it, we also had many monolithic servers which are kept for performance testing, which are kept for functional testing and so on. And that used to be used for testing. And never it was able to get scaled up very easily and so on. And we had huge amount of challenges. Similarly, when a trend changed to virtual machines solved some of the problems, but not everything. That means still in a virtual machine, each virtual machine to spin up and park for performance testing or for a functional testing or with a specific testings, it's been parked and the total cost has always been, enormous. And that is where the trend of technology of microservices as container comes in. And today we are in a trend in technologies where most of the companies develop and deploy more than thousands of services. We are talking about thousands of microservices trying to achieve, a base functionality talking each other's. So that means we want the testing to be more effective and for the cutting edge technologies and also use the same power for the testing purpose to increase your quality. So if you do the simple maths in any applications, let's say a Node.js application or a Java-based applications or a PHP-based applications, you name it any applications, we wrap that in a container, it becomes a test application container. Now, if you look at it in testing point of view, any testing frameworks, you call a testing framework written in Maven for functional testing, you call a testing framework written in JMeter for performance testing, or you call it from, testing frameworks which is written for Gatling for performance testing, or a testing framework which is written in Cypress for functional testing, or anything on any varieties of each kind. Okay, if you wrap that and put it in a container and you try to execute that in a container, that is what we call on test container. Now, if you want to understand how this journey of test container moves, you come to the very interesting points, which is nothing but test container platform. Now, I'd like to hand over this section to my expert, Saravanan, who will be able to take you to the journey of test container platform and see how we can solve the problems which we called it as our testing limits. Over to you, Saravanan.
Yeah, thank you so much, Nanda. Hi, everyone. Yes, now Nanda explained you about the container and how it is going to change. But now I'm going to give an approach like one step above the container, like how we can solve the test container issue itself. Say, for example, this test container platform is not a plugin, or it is not a kind of a tool promoting thing. It is an approach to use your container more than 100%. That is very, very important here. So now, how are we going to use more than 100% is, now we know that, okay, having a test container means we are going to put our test into the Docker image and going to spin it up whenever we want. We are going to use, no. But this test container platform approach is separating your tools as an image and making our test suites or test data or whatever the moving part is going to be always a movable. So we can call it as an asset kind of. So this test container platform, whenever it triggers or whenever it starts to execute, it will move your entire test scripts into the image or into the Docker container. Then the test will happen. So meaning your test features always be, it will always upgrade, or sometimes it will happen in the sprint also. Every sprint we will update our test scripts, test data and everything. So you don't need to stick with one Docker image or one Docker test suite to verify your confidence things. So moving on to the next, like how this test container platform we can implement. So I've just taken the continuous testing approach. So here in the left hand side, you can see a local machine or Azure DevOps. So in our case, we can consider this our local. So locally now we want to do a testing part. Now, how are we going to do is, here the platform, the execution platform, already we said we are going to onboard to the Docker containers. So we can take a Kubernetes cluster here. This Kubernetes cluster can sit in a cloud, or you can also spin it up in your local premises. And whatever pods or whatever containers we are going to get it, everything will be in a Kubernetes cluster part itself. And similarly, the AUT, the application which we are going to do a test, that can be in anywhere. That can be still in a monolithic, or that can be still in some pods or container is executing. But that is not point. But the point is, whatever we are going to test it, okay, those test containers will be in the cloud, which actually gives a lot of advantage. Now we will see how this test container approach will going to give a lot of benefits. So it actually has 5 steps. So what that 5 steps is all about. First, whenever we start execute our test container platform, it will do a spin. So it will create a pod for you. The pod means, say for example, we can take a Java framework. We have a Java test suite. Selenium also you can take it here. So when you want to spin or when you want to execute your test suite, so when at that time you need to run this test container platform approach, so that will create a pod for you. That pod contains Java, Maven, or whatever tools you required. So here you can see that still the test suites are still in with us. So it is here we are just going to spin a pod. Next step is we are going to upload whatever scripts or whatever test scripts we have, that will be uploaded to the pod. So here the connection between pod and local machine will be maintained by our test container approach itself. Okay, yeah. And the third thing is the execution part. That is the one actually will happen. What after the uploading of your files to the framework, so we are going to do the execution. Here the execution commands, or what kind of execution you want to do within the pod, you can give it from the local itself. It is like a controlling your entire execution within the pod. Next, once the application test and everything is done, we are going to get our test results back to where we are executing. That is the key thing here, because we are not going to store our entire data or our entire test results in the pod itself or in somewhere to store just a log. So it is not like that. So we are going to get whatever logs or whatever the container logs, and we can talk about the container log. We can say a framework log or the test results. Whatever we are going to get it from the framework, that will be pass it to the local or your pipeline itself. And the last part is a very important one, is whatever we spin, whatever we executed or whatever we have done within the Kubernetes cluster, everything will be destroyed. Meaning we are exiting, not only exiting the run, we are entirely killing the pod there. So meaning we are going to give the same space to the other containers to run. So here the approach is test container. Yes, using the test container, we can achieve our thing, but using this test container platform approach, we can save a lot of cost. Now we will see one by one, like how we are going to rectify all the challenges highlighted by Nanda. First, the cost of quality. So as I said, the pod containers will be created during the execution, meaning whenever you want, at the time only we are going to create a pod here. So once a pod creation is done, as I said, the test container platform approach will kill the run or will kill the pod at the end, right? So it will give you, or it will give or free up your lot of spaces for the others to run their test suite. So that is by freeing up this freeing up this particular space, you will get a lot of resources. You can take it in a CPU or memory wise, or say for example, to run your 5 test suites in 5 different machines, and those machines will be a fixed one, right? So once the execution is done, but those machines will be still with the team only. So it will give you, or the entire budget will be allocated to those systems will be very, very high, because that is a fixed one. And you might use those machines for testing like 1 or 2 hours only. So now you can think about in a cost wise, for 1 hour or 2 hours execution only, we are using those machines, but the remaining 23 hours or 22 hours, the system will be very idle, or else at least we need to do some kind of schedule to run other kind of test cases. Okay, so here, whenever we need, we are going to create a pod, we are going to test it. Once the execution is done, we are just going to kill those pods from, in the Kubernetes cluster, and then freeing up our space. That is very, very important. Next one is CPU and memory, because mostly we need to talk about this. Getting or allocating the machines is not important, but after we got some 5 machines or 6 machines, again we will mostly talk about how much CPU and memory we require. But here this test container platform approach will help you to control those pods. Say for example, for Java execution, you might require only 2 core and 2 core CPU, and then memory is something like 500 MB to complete your text execution. But if you take for the performance, you might require some 8 cores or 6 cores with 2 or 3 GB to do the performance testing. Okay, so by controlling these kind of pod parameters, we can get a specific container. So that's what we can call it as a customized one. And for that purpose is done, as I said, it will be destroyed, and those free phases, those resources, you will get as a benefit. Next thing is, as our approach is going to be a containers one, once you are having a lot of confidence with open source parts, because in the open source, I can say Google's Kubernetes cluster part, but when you got a lot of confidence on using this, you can move on to the open container platform also. That is the OpenShift container platform we have. So you can go with a license tool, but here moving from one platform to another platform is not a big deal here, because everything is already containerized. And as I said, the test container platform is an approach to segregate your test suites. So your test suite is not going to affect. And by having this, we will have a lot of benefits, because mostly the teams are spending a lot of money in the migration part only. But in our case, the migrations cost will be very, very less. So I can give a guarantee on that. And next one is considering the open source tool. Nowadays, the market is almost moving to the open source. We can say, like, if you take some 2018 or before 2016, we mostly believe that only the license tools will produce a good result. Say, for example, the UFTs or the other task code tools, but the same result now you will get it in the open source tools also. And the now entire market is actually moving into the open source only. And for the open source already, those teams are already started working on the images part. So we can directly consume their image, and we can put our test suites into that container, and we can do the test. So in the cost wise, there is no license cost, you will get it. And the last important part is storage part, because we can run n number of 100, say you can run 1,000 test cases, or 1,000, not 1,000, we can take 10,000 also. But here the logging part, it will increase, because the log storage is the important one. Because if you take audit, or if you take like in verification, like where the issue caused or what kind of verifications we want to do, those things we will verify, and we will store it in some separate DB or for that. So in our cases, we don't need to worry about that, because whatever we are going to execute, that will be stored back to our local. So whoever is executing, they will have their test results. And if we are going with the continuous testing, the pipeline itself now providing that feature. So you can publish your own test results in the pipeline itself. We don't need to procure a new storage platform for you. Yes, Alok. Yeah.
Just getting slightly over time, so just reminding you, we've got a few moments for questions at the end. I'll let you carry on for now anyway. Thanks.
Sure. Yes, I will speed up and moving on to next challenge, because we have seen like how much we are going to get back our entire significant investment. Second thing is test environment. As the research, Gordon research said, most people are worrying about environment issues and the configuration, most importantly, the configuration part. So here, artifacts and the tools which we need, right? Everything is already containerized. So we don't need to invest our time to do those containerization part. And readily it is available for us. Whenever it is required, we can just spin it and we can do our test. We don't need to worry about that. And next is the custom-made containers. The custom-made containers here, what I want to highlight here is, your test suites might run on Java like 1.8. Some test suites might run in the Java latest version. Or we can take another example also. Latest, we have a lot of Cypress, Detractor and all, right? So those things will work based on the versions only. So you can't say like, if you want to run your test suites or JavaScripts using Detractor framework, the Node.js 12 version only support. It won't support the latest one, right? So like that, you can have n number of containers here. You don't need to wait, or you don't need to go to any physical machine to do install or uninstall there. So directly you can spin that. Next thing is the easy track, has everything is in the Kubernetes cluster. We can get the health of your pods, and next is what kind of software we are using and logs. Everything we can get it easily. So we don't need to invest more time in setting up the environment. That is a key point here. And the last one is the pod scale up part. So here, when we can scale up whenever we want, and if the usage is very less, then we can scale it down. So we don't need to have a fixed number of pods, kind of like having a fixed number of machines. Yeah, the last challenge what we have is, yes, Agile deliverable. So here, as I said, that the segregation is different. So we have the containers, we have the Kubernetes things. So whatever test suites we are going to design based on our change requirements or based on our functional testing, it will be easily ported to the container and we can test it very easily. So more importantly, we can still stick with our reliability and stability of our application. And this test container platform is going to be one-stop solution for us. So by implementing this, we not only going to achieve a faster time to market, where we can also have a continuous testing. That is very, very important, because here at the end, the quality is very important. So even we have a speed or velocity, the quality we need to maintain and we need to get a confidence before the end product goes to the market. Yeah. And these are some highlights we have in the ING. So this kind of platform approach actually we implemented in the ING Belgium. So more than 300 plus team is already registered and they started using. And we are actually using 75K of container. Here the container run, I will specify it in the next slide, what are different containers we have. And moreover, this is ING Belgium, right? So we have a lot of security compliance things. So when we have taken this test container platform approach, we also added to the ING security compliance. And also whatever images we are pulling from outside, right? We actually have a container scanning also. Yeah. Yes, so this is just to give an overview, like in each stages, what kind of different test container approach we have taken. If you take the unit test, we started using a test container platform of mock. And when we go with the API testing part, we used Newman to do the test, meaning the Newman image will be there. The test suite is not a fixed one here. So we will keep on update our test suites and we will do the test. Similarly for performance, E2E and the canary and all, we started using the same container approach, as well as we still stick with what kind of tools we want. Yeah, next.
So we've literally got 1 minute left. We're just coming up to the next session.
Yeah, so I will end with what kind of major takeaways we can take. See, for web application testing, we still have a Selenium grid, right? Those things are already containerized. So we can go with a containerized one. That is a better solution. But having this test container platform approach, it will make you, as I said, right, it will make you use 110% of container usage. And next thing is our test suites and everything is going to be changeable. So still we can achieve this container and continuous testing by reducing a lot of cost, and the efficiency will be very, very more. Yeah, I think I could see one question.
Thank you. We've actually, apologies, I think we've actually run out of time. What we can do is, thank you again, fantastic presentation. What I could suggest maybe is, will you be around for the panel later? Perhaps we can take some of the questions in a panel, and also we have the networking session now. If you go to click on the Expo tab on the screen when you go back to the lobby, you can either go into the Mabel or Unicom booth, and you'll find there'll be other participants and speakers in there. So it's a great opportunity to ask one-to-one questions and have a discussion. So if you visit the Expo tab and just drag yourself into the booth using the mouse, and then you can have a chat and ask questions. So Sarvan and Nandakuma, thank you very much indeed. And apologies, I didn't like to stop you early. It was such a great session and a lot of information in there. So,
yep, sure. People can ask questions in panels, as well as we will be available on a network as well. We should be easily able to reach it.
Brilliant. Thank you.
Yeah, thank you.
Thanks. Excellent. So we'll go to the networking. Thank you very much. And we'll go to the networking session now. So you just click on the Expo tab, and then we'll be back. Our next session will start at 11:36, next presentation, which is Automation Made Simple by Manju Jananathan from Tropic Pty in Australia. So we'll see you back shortly, and we'll see you now in the Expo. Thank you. Presenter, again, a fantastic presenter. We now welcome Manju Janathanan, automation tester at Tropic Pty, and I believe you're based actually in Australia, so it's a truly international program today. And Manju's going to be talking on the topic of automation made simple, something I know is really topical at the moment. So Manju, I will hand over to you.
Thank you, Alec. Hope you are able to see my screen. Yeah. Hello, everybody. Perfect. Yeah, thank you. Hello, everybody. I'm very happy to be here. And I'm going to talk about low code or no code test automation tools, and particularly for Salesforce domain. Yeah, so about me, I have 13 plus years of software testing experience. I have been a tester, test lead, and a test manager. I have handled both automation as well as manual test teams. I have implemented automation from the scratch, both tool and the framework-based automation. And I have transformed many manual test teams into automation test teams successfully. So this is all about me, and we'll go to the agenda for today. So first, I'll be taking you through some of the state of current Salesforce testing report, and then I'll give you a brief overview on platform, like Salesforce platform, and then I'll just take you through the challenges that are faced in the automation and some tools. Okay, we are going to see what all the tools who are providing this low code, no code, and I'll be showing you a very short demo, just to give a feel of how it looks, how simple is that automation is, right? And we take up the questions. Yeah, I move on to the next one, which is the current state of Salesforce testing report. So you can see that the lack of testing is the #1 risk, okay, when you want to take your product to the live, right? You see a lot of production issues there. And you can see as the time increases, or when you go towards the release, there are a lot of your cost to repair for the defect really increases, and percentage of defects found, you can see that 85% is in the coding stage, right? And the defect injection as well. So this definitely shows that testing is very important for a successful release, right? Then compared to traditional manual testing, and how about an automation testing? We'll see in terms of cost. So definitely there is a lot of cost saving involved when you look into manual testing and the automated testing. And by 2024, Gartner predicts that 75% of the companies will be using an AI-enabled test automation tools, right? Then we move on some important and interesting survey questions about how are companies testing today. Okay, so here are the answers that we have got. 64% of the team, they say that they still chiefly rely on manual testing, and 84% they partly rely on manual testing. And can you believe it's only 10% of the teams who have automated all of their testing, right? So this is what the current testing status looks. And who would do who would do the testing in their companies? Okay, so this is another questions asked. And we got the reply like 49% of the companies say that they have a full in-house testing team, and 26% say that they outsource their testing to other consulting companies, and 23% they say that the testing is done by developers. Right? Can you believe that? The testing is done by developers. That really sounds funny to me as a tester. Next, also we have asked do companies find enough time to test all the changes before each release? 52% say yes, they really have all the time and they do all the testing. 41% says no, there is a lot of time constraint, so they have to reduce the scope of the testing. Right. So this is what is exactly, you can see that 41% is really very risky thing. So what are the key findings from this survey, right? So 41% of the team don't really have time to test everything before release. And 92% experience production issues, which means that there is some less customer satisfaction and they're not really happy with the product. 84% they still rely on manual testing. And 95% of the higher cost increases when you compare your manual testing versus commercial test automation, right? So having spoken about so much about an automation testing and the cost and the other things, let us just go through what is the advantages when you shift from manual to automation, right? 58% there is a fewer production failures per year, which is definitely very good. You have a quality product. 50% more frequent releases, which means you can definitely include a lot of features to your customer and there will be a higher customer using your product and your features. 50% more likely to complete testing for each release, right? That really ensures your a quality product. And 50% on the total cost of ownership, right? So who wouldn't definitely like to have a less cost, right? It's always a boon. For testers, right? For testers like me, what is an advantage of shifting from manual to automation? It will ease the pressure for testers for not to do an incomplete testing, right? See, I have been there many times where we me and my team have been there at many times where we are not able to complete a testing on time. So we had to reduce. So there are so many things happen and the testing in the last minute. Avoid manual errors during testing. We all are humans at the end of the day. We do mistakes and obviously that reflects in the quality product, not having a quality product. And there is a, for testers, it will give a reliable test results, right? Because the tool definitely, it cannot tweak or change any expected results. So definitely it will show you the reliable test results and avoid dependencies. I feel this is the best feature, best thing as an advantage because we have faced many times, right, where you need to depend on a person to give you a test result. For example, that particular person is on leave. So who would give me the test results? In automation, just go to the tool, open it, and you yourself can check the result. There is no need for anybody to give or to send the results. I think this is very good, advantages that we have from shifting from manual to automation. Now, having spoken about the automation so much, now what is the next wave in the automation? I would definitely say it's a low code or no code, or you can also call it as a codeless test automation. I'd give you an an idea like this. Okay, earlier a change is the only thing that never changes, right? We all agree to that. Earlier we have been using so many ways to clean the house. For example, now you have a robo which is doing everything. Same way, earlier the test automation, there has been a framework based, from the scratch, you need to set up the framework, do things, but now you have everything, a tool is doing it for you. So a tool is doing all the engineering and the hard work, and we are doing a smart work of operating the tool and getting the test automation results out of it. I think this is definitely going to be next, wave in the test automation industry. Now, having said that, what is a key difference between a traditional and the tool-based automation, right? So here, traditional, I mean, which is a framework-based automation. It can be a BDD, TDD, all the other keyword-driven framework, right? Hybrid automation framework, all those things comes under this traditional test automation. So who would do what in each of the thing, right? So you can see that in the test authoring, in a traditional test automation, you have automation engineer or an SDET who will define a manual flows, who will be writing a code in Java or JavaScript, who would define objects, page object model, use object spy. Basically, they would be doing all the visual validation and assertion, and it definitely takes a longer time to develop, and it is complex, right? If you come on this side, right, on a like what do you say, like a codeless test automation, who would be doing the test authoring? It would be the tool. Mostly we have to just record it and automatically all the scripts get generated. Then objects are generated on the fly. It can be a flow-based scenarios. It's very shorter time and it really has very advanced capabilities. And test maintenance. In traditional test automation, it would be like a tester who would go and check all the changes proactively, and version control as is CM supported. In this codeless test automation, you have something called as a self-healing or correction method, which, for example, some text has changed in a web page, right? I'm automating that, and so this tool will tell me now, telling like, see, earlier in this place, like a new keyword is found, your keyword is failing, you can apply this fix. I just need to click on apply fix, and the maintenance is handled. Like, how cool is it? Yeah. Then coming to test execution, you can either execute in locally or CI cloud, but you need to configure a lot of environment in the traditional test automation. Here, everything is an inbuilt feature, right? In the mission-based automation. So, like same way, you can execute either local or in CI or cloud, right? And then coming to maturity level, see, there are certain shortcomings in the tool-based automation as well, because there, if you see, the maturity level is high, you have guidelines, you have all the documents, but here I would say it is an emerging technology. Definitely this will also reach where the maturity is high, but it will take some time, right? And integrations in traditional, you can do with the defect management and other things. Here, most of the capabilities are built in and some exist, right? And then a skill set, this is very important point, medium to high in the traditional test automation. Here you have a low to medium skill is enough. Like, it's like, that is what my topic says. It's like anybody can automate, an automation made simple. And then the testing environment, which is IDE, right? Like Eclipse or IntelliJ. Here you have their own built-in machine learning UI. And you can do API load or functional testing. Here also you can do almost everything. And app types, mostly all the app types are supported. And here it depends on the tool, right? Which one? There are some tools which I know they even support all the types. So this is what I would say is overall a difference between the traditional and the next tool-based automation or the codeless automation. Now, having spoken about an automation, we have talked about, we have discussed about low code or no code advantages. Coming to Salesforce platform overview, this is definitely I'd like to give a one-liner on each on what the Salesforce is totally comprised of. They are a leader in the CRM industry, and these are all an integrated platform services they provide. So you see a customer 360, which gives an integrated view of all the aspects of a customer, and Salesforce Einstein AI, which is an AI technology integrated with the Salesforce. It gives you a predictive analysis. And then a Lightning, which is a component-based framework for Salesforce app development. And Heroku platform is mainly used in the deployments. And Anypoint platform is a complete solution for an API-led connectivity, right? And then Quip, which is a collaboration tool, which is built in with an Office suite functionality. Paradot, which is a B2B marketing automation lead generation tool from Salesforce. App Exchange, which is a marketplace for all of their cloud computing apps. Tableau is their data visualization. They mainly use that. So this Salesforce is comprised of all these things. It's not a standalone system. Now, what are all the challenges that we face when we do a Salesforce automation testing? As I told you first, it's not a standalone system. It is highly configurable. The configuration itself is a separate automation project, I would say. And there are a lot of frames. You need to navigate through a lot of iframes. And dynamic content is there, which is when you refresh a page, your XPath will change, your ID will change. So you cannot locate, you cannot take it as a constant. And you have to recreate all your classic test. So classic is an older form of UI that they have. So you have to recreate all your tests to Lightning UI. And you have to handle a database driven tables. And there are a lot of issues in the IDs between organization. For example, a test organization IDs will differ from the production organization. And the dynamic nature of the pages, they do not load simultaneously. So you have to maintain an appropriate wait time or a sleep time so that the pages are loading. And some GUI tests don't work when you switch the environment. Right. I think these are all like heavily an automation challenges that we could face while doing automation in Salesforce. Now, who are all the tools? Okay, all these, like I would not say all the automation challenges are addressed by the tools, but majority of them are addressed. And if you see the players, major players who are offering the low-code automation tool are these: Copado robotic testing, like Tricentis Tosca, Catalan, Axelk, Leapwork, Ranorex, Testcraft, Cloud QA, UseMango, Perfecto, Mabel, and Sikuli. Right? Or they are just limited. There are a huge list. I have just taken a top 10. So these products, they really offer truly codeless automation tools. We can try. Definitely, I would recommend everybody to take any of the freeware. Some are free version. Some should have license, but I think they give a trial period of around 2 weeks or something where you can try and then you can purchase a license if needed. So they are all the thing. Now I'd like to show you a quick demo of a Salesforce use case using a low-code automation tool. Right? I want to give you a feel of how it looks. Hope you're still able to see my screen. And I'll give you a case submission here. Yeah, you can see that this is how a simple Salesforce use case automation looks like. Right, you log into Salesforce, so you can see that a Chrome is being controlled by an automated software. It logs in, and then it fills a form in the Contact Us page where a case is created. Yeah, so you can see that all the input text is given, and when it submits, a case number will get created. And it'll go to cases and it'll check an all open and it'll find this particular case number. Yeah. And it'll click that and it'll create a task. Okay. Now it verifies. These are all blue drawings are all like verifications given. And you create a new task and you set the status as completed. You give a subject, comments, and you click on save. So this is like ideally a simple use case for case creation. And yeah, at the end of the day, I delete my case so that I clean up the data. Yeah, so this is how simple automation for a Salesforce use case looks like. So I think so the references for my testing, for this presentation, it was taken from a Copado robotic testing, and the tool that I have used for automation for showing the Salesforce use case is using a Copado robotic testing. And this report is all the survey results and everything I've taken from their report, and some of the tools from the G2. Yeah, and thanks. And let's connect. Any questions? We can take it now. Can you please show us the list of tools once again we can use for Salesforce testing? Sure, definitely. I'd be happy to do that. Yeah, I hope you're able to see this. Okay, Tosca, again, I repeat, CRT, Tosca, Catalan. Some are cloud-based. Okay, Axelk, Leapwork, Ranorex, Testcraft, UseMango. See, they're all very, I found it very interesting. Okay, I've tried few of them. I would say this UseMango is very small and company, which really they are trying to give very good features for the codeless automation. Definitely, I urge you to try that. Yeah. Can there be an end-to-end automation possible using low code? End-to-end automation, it depends on the systems that you connect, I would say. Definitely, I have navigated through different systems in the same suite. I verify and I come back. Or mostly what I do, I complete the automation in one system, all the steps, and I verify all the verifications, I keep it on the other system. Yes, there are end-to-end testing possible. Do you feel there should be different teams for manual and automation? See, it basically depends on time and whether like how many features you're committing for a sprint. I would say if it is agile project, a person doing both manual and automation, yes, they know the functionality well, and if time permits, they can really do. I mean, what, for example, in our case, I do is I do the functional first, and some days I keep it. Okay, it's a 2-week sprint that we work on. So 1 week or 1.5 weeks, I would do most of the functional verification and stuff. And then the last 3 to 4 days, I would keep it for automation. So I think if that works, definitely it can be practiced. Are there any open source tool which one can be used for our practice purposes? See, this CRT, okay, Copado robotic testing, it's an open source. Open source is cloud. Okay, you just need to create an account. Okay, that I think you can use your Google account. You create an ID, and they have some limited features that they give in their free version. Okay, for example, what will be the differences when you can create a single project. You will be able to create a single suite. But if you have a license, you can create multiple projects. But I think for practice purpose, definitely the free version should be good. Okay, you can try, even I have tried Axel and I have tried Copado robotic testing. So definitely you can try that as well. And there are constraints of automation testing, how to handle them as per your experience. Yes, there are constraints for automation testing. Okay, see, not not 100% everything can be automated. There are certain features or scenario which you should go and check. Right. So it depends on what is the domain that you're working on and what is the use case it is for. Mostly we try to do any repeated manual regression work, right? I think that should go for automation majorly, and other things, all the new sprint functionalities and everything. So whichever you feel like, okay, this will definitely break if they're going to deploy something in the next sprint. I think that all those cases should be automated. And does low-code automation provide the same kinds of benefit, results, framework, model, reusability on comparison to existing automation tool like Selenium? Yes, if you see the results are even, I would say they are more very good, or they have really a lot of graphs for management showing how many tests failed, how many things. And now I have seen a lot of defect management integration with it, where a failed test case, you can directly integrate with Jira and you can raise a bug on it, right? So all these details will go through API. And also you can connect it with the CI/CD pipeline, okay, where your developers commit some code. If any PR is merged, an automated suite would run and it will show them the results telling like these are all failed. Okay, I think there are a lot of capabilities that these tools have brought in. Okay, I think we covered almost all the questions.
Thanks, Manju. That great session. I think we're actually slightly ahead of time, so we do have time for a couple more questions. I think there are quite a lot there already, so obviously very thought-provoking. So thank you again for that.
Thank you.
Thanks. Yeah, so I think that's all the questions. So we're slightly ahead of schedule. We're about 6 minutes ahead of time. So I've got there's one more question coming.
Yeah, one more question. Yeah. Is automated testing essential for CI/CD? It would be good to have, I would say, because continuous, if you see, right, what I have done, in our project was I developed a separate test suite for developers, right, which covers the basic functionalities. So once they merge any PR, this suite would run. Okay, the moment they have put it in such a way that when the PR is merged, it will automatically do an API call and my suite will trigger and the results will go back. It will also show them the result path, right? So in this way we can ensure that, okay, they are confident, and when they give it to testing team for any testing, it will not be like a complete mess, right? At least some basic checks are done and then it comes to us. So I think definitely it's a good practice to do that.
Thanks, Manju. I think that seems to be all the questions. We're just a few minutes ahead of schedule. So What I'd like to do is just, again, my usual reminder, if you can please, as you go through the day, fill out the feedback form. Let us know what you think of the sessions. We really appreciate this because it helps us in creating new events. Oh, got a question from Mukta. Will you be sharing this PowerPoint?
Yeah, sure, I can share it to your team, Alec. Yeah, probably if they want, they
Thank
can
you.
contact them. Yeah.
Brilliant. We can forward. I mean, also, as I mentioned earlier, we'll be forwarding the link to the recording in a few days as well, so you can watch the program again and share with colleagues. So, Andrew, fantastic session. Thank you. We've got next session coming up is going to be by Stuart Clark of Cisco Systems. Stuart's going to be talking on instant and automatic network configuration, as easy as ABCICD. Sounds intriguing. So that session starts in a few minutes at 8 minutes past 12. So we've got a few minutes now. If you'd like to go back to the expo, it's a great place to meet people because we have a couple of booths there. We've got Mabel and Unicom, and you can go into the booths and meet with any of our team, the other delegates, speakers. There'll be lots of people hanging around in there. So it's a great place to network between the sessions. So Manju, fantastic session. Thank you as always. It's always a pleasure to have you presenting at our events, and we'll see you later. I think you're around for the panel, are you, later on as well, which will be after Stuart's talk.
Well, thanks,
Thank
Alec.
you.
Thank you so much.
Thanks, everyone. We'll see you back shortly. Thank you. Hi, everyone. Welcome back. Thanks again for joining us. It's my pleasure to welcome our next speaker, Stuart Clark. Stuart is Senior Technical Leader and Senior Developer Advocate at Cisco Systems. And today he's going to be discussing instant and automatic network configuration, as easy as ABCICD. So, Stuart, I will hand over to you. Enjoy the talk, everyone. Thank you.
Thank you. Thank you so much, Alex. Can you hear me okay and see my slides?
Yep, perfect.
Fantastic. Thank you.
Thanks.
Thank you. Thank you so much again for having me here today. I believe this is my third or fourth time talking at Agile DevOps. So this is a real treat for me. So hello. If we haven't met before, my name is Stuart Clark. Before we kick off the slides today and the presentation, I'd just like to give you a quick overview of who I am and what I do. So I wasn't always a developer advocate. Many years ago, I actually left when I finished school. I started my career as a hairdresser and did 15 years as a hairstylist, which surprises most people, having a 2-foot beard. When I got into my kind of mid-30s, I decided I wanted a bit of a change of career, and I took up the position of network engineering. I didn't know at that stage how far this wonderful industry and this career would actually take me. And now, as I've progressed through sort of senior engineer and then through automation, network engineer, I now reside as a developer advocate for Cisco DevNet, which is the developer advocacy program at Cisco, where we talk about and have all the content around Cisco APIs and documentation and how to get started using Cisco APIs and best practices around things like net DevOps and DevOps. I've also contributed to a number of books for Cisco Press, and I'm also one of the 5 in the world to be a Cisco certified DevNet expert. So I also enjoy sitting in boats as well, just in part-time. So today what we're going to look at is how we've developed CI/CD pipelines, and we've built these into SD-WAN controllers, or software-defined network controllers, and what that actually looks like within the industry, and what that looks like within an entire ecosystem, and why we go into this methodology. So first of all, we want to look at net DevOps and what is net DevOps. Now, net DevOps is a principle or a philosophy, much like DevOps is a cultural discipline, and it has this holistic set of methodologies. It's not one tool, it's multiple tools, and it's not one process either, it's multiple processes. But all of those things wrap into a particular set of a CI/CD pipeline, a continuous integration, a continuous deployment pipeline. And the true agility here is being able to have this pipeline with multiple tools and being able to swap these tools out as well as our journey grows and as our use cases grow. And as we onboard new infrastructure and we embrace new technologies and things like cloud and shift left security as well. What I like to do is I really like to think about a CI/CD pipeline like these two cameras which I'm sharing on the screen. And this is a kind of a common thing which I tend to talk about when I talk about CI/CD and automation within networks, because it shows a really, really good example of the way that we used to do it and the way that we are now doing it and how we've transitioned into that with this great example. So you'll see here with the camera on the left-hand side, and the camera on the left-hand side takes just a standard piece of film. Now, the disadvantages of these cameras compared to the camera which you see on the right-hand side, the more modern sort of camera which has a flash memory installed into it, is when you're taking pictures, you really don't know what your result is going to look like. And so if you've ever taken one of these cameras away with you on a vacation or on a day outing, you've taken a number of pictures and you've kind of almost hoped for the best. You've not really known what the pictures is or whether it's really captured that moment in time that you wanted to have fond memories of with, say friends or your family. And not only do the pictures, you have no guarantee of them coming out, they could be blurry, or they could be somebody in the background, or the picture could be overexposed, or you could have taken the film out and the entire 36 pictures could be completely ruined. And this was very much the way that we used to do network engineering, where we're making a lot of changes for new services for things like customers and for internal teams, whether that's standing up new sites or just adding new switches or devices or new routing or new security parameters within our network. And often we wouldn't see the impact of adding those things into the network, and sometimes days, weeks or months later. It's not uncommon within our industry to provision something and then for that not to go into service. And then a couple of weeks or months later, when that does go into service and there's customer traffic or an increase of customer traffic, you start to see all of these kind of problems happen. And so troubleshooting things like this becomes monumental, especially within the face of an outage. And recently there was a number of outages which have happened at Cloudflare or at Facebook, which really showed, of doing something in a manual process, the actual outcomes of this. So this is where the new camera, or using a pipeline with automation, gives us a lot more visibility and a lot more metadata actually into our network, into our services, and into what our customers are experiencing. So this is what we did for years. This is the manual configuration that I spoke of. And this, if you've seen BGP or you've read about it in the news, and it does make the main news quite often now, you'll see that BGP is pretty much responsible for a lot of outages which we see on the internet or the World Wide Web today. This is a very, very manual configuration, and adding each of these lines, you're doing this in a real-time fashion. And as you're adding these lines, an impact is being seen or a change is being seen. And this is why it's critical when you're adding like lines in this manual process, is that you have to add them in within the right order as well. There is a sequence of what these can be added in at. And a lot of people, when they're adding these configurations into devices, kind of tread very lightly, almost on eggshells, because it's when you get to adding some of the configuration and start, say, advertising routes or prefixes, that's when you start to impact traffic and impact any form of sort of, routing or your global infrastructure. But this did as well for a vast number of years. This is the way that we did it. But we needed to change this. And so how did we change this? How did we change this? What were the challenges that we faced? And how did we come about making these changes? Well, doing things in a very, very manual way is very, very repetitive. There's a lot of configuration tasks, often hopping from box to box around certain devices usually in a particular order as well. And network administrators and administrators spend a lot of time doing these configuration changes. This puts a huge amount of dependency and also constraints across multiple teams, and it poses a serious challenge. A lot of what we spoke about at the start, where we have delayed in accountable actions, these are a lot of the challenges that we have to overcome when doing things in a manual sort of in a manual way. The other part of that is the scope of the changes, and we're not able to keep track of those configuration changes, especially within a big global infrastructure. There's multiple teams and multiple persons making changes all the way across different devices at different points and different times of days and different time zones. And there isn't by doing this manually, there is no way to provision or monitor any form of unauthorized changes, which leaves a big gaping hole in our security and compliances. This has that trickle-down effect that we often see, where we have a lack of ownership of who owns what part of the configuration or who owns what part of the device. As you successfully build something, who then goes on to maintain it? And this is a classic problem within the old way that we did infrastructure, where most of the things were thrown over the fence and they didn't have any form of ownership. And sometimes you could spend a number of hours or even days trying to track down who made that change and why they made that change as well. So how do we embrace this change? We've talking about a way of the way that we used to do things within our infrastructure. How do we modernize this and bring this into 2022, where we're using machine readable code and CI/CD pipelines? How do we do that? Well, the idea is strengthening the team. The whole team needs to be on the same page of this methodology, and the whole team needs to work towards the same goal. The only thing that we ever see within network infrastructure and infrastructure as a whole is that the change is going to be consistent. And so we have to strengthen our team, and we have to provide the right tooling and infrastructure to be able to support that growth of both the team on a personal level and from a technical perspective as well. So this is when we start talking about SD-WAN architecture and software-defined network controllers. There is a place within network automation where you would still be going almost box by box. And what would happen is you would run things like Ansible or Python scripts. And these would either run individually at box by box level, or you would do this as asynchronous, and you're sending changes to multiple boxes at multiple times. And that is a great advantage from doing things in a manual way and just kind of brute forcing configurations, just typing or copying and pasting commands in. But when you move to use on as a software network defined control here, what you're actually doing is you're actually separating the control plane and the data plane. Now that might sound a little more complex, and I promised you that we were going to make this a lot simpler, and now I'm talking about dividing the two control planes up. But by separating the two control planes, this gives us a great more deal of visibility into the network and into our configurations, because it adds a certain amount of validation and testing when we're pushing changes out into our network. As a lot of now people are more embracing a work from home or working from coffee shops or different locations, remote offices, we need to also secure our entire network down as well and provide that secure access into our infrastructure, whether they are a remote worker or they're working from one of the many office locations that we have. And you'll see from the image on the right hand side that this applies to not only remote workers, this applies to things like data centers, campus, branches, and it also contains using different methods of transport, because often you have different methods of transport no matter where you're coming in from. You might be working over a cellular connection or tethering your laptop to your phone, while enjoying a coffee in your favorite coffee shop, or you might be working from a friend's house on their broadband or internet, or you might be in one of the locations such as a data center or a campus. So we have to account for all of the different locations that people are working in and make this secure as well. And by securing the control plane and securing the data plane, this gives us this great deal now of visibility into our network. So this is our new architecture, an SD WAN or SDN controller looking after and managing all of our sites, which means that when we make changes, we just make changes to our SDN controller, and that takes care of all of the policies, no matter where our workers are now working from. So how does that fit into the pipeline? Well, we looked at the architecture, so now let's look at the architecture of the pipeline and see how that sits. Starting from the left-hand side, we can have an operator. And what this operator has been asked to do might just be a simple change, or it might be to turn up a new site or enable access for a remote worker into some resources into a data center. And so what we do is, instead of manually configuring this or going into the UI of our SD-WAN controller, we can actually codify all of this and push all of these new features via a branch. What will happen here within our pipeline is this will trigger a pipeline using a platform called Drone. And within there, this will check all the validation and do linting of our machine readable code. And in this example, I'm using Ansible as the machine readable code, which is typically done via a YAML file. By having this input validation and linting done on the YAML file at such an early stage, it validates that the YAML file or the configuration change is actually going to be valid. And this is valid information. This isn't like copy and pasting the things back into the terminal again, where you would get errors and then incorrect syntax problems, and it would affect that ordering that we spoke about earlier. This will check the validation and do automatic linting. So we're performing our testing at a very, very early stage, which is very critical. That configuration then is actually rendered. And once that has been rendered, we will get a notification to say that that has actually passed, and the YAML file, which we've pushed into the validation, has come back as being complete and is actually valid YAML file or valid change. What would happen here? This will then get merged into our main branch, and once it's been merged into that main branch, it would then trigger a secondary pipeline here. The drone here would trigger the pipeline, and this would push this into our infrastructure and deployment. And this is when it would use an API call to our SD-WAN fabric, to our SD-WAN controller, and it would push the changes into the SD-WAN. Now, once it gets into that part, this is where SD-WAN, or our software-defined network, actually performs its own testing as well. So this actually tests whether the template or the configuration is valid for the devices as well. What this prevents is, this prevents mistakes and errors being pushed out to devices and then these having to be manually rolled back. We would then store and test all of these reports as artifacts. Now, this is really important. By storing them here as artifacts, we're able to see what the changes were made and what the impact was to both the customer and the network. This goes through a further analysis where we're doing further testing, and this can be run by using tools like PyAts, or things like Cucumber, or you can use any kind of validation tool that you wish to put in there to analyze the change. And often these changes are done using some kind of traffic and an analysis tool as well, to make sure that the traffic is actually now valid and the policies that we've put in place are secure. Once all of that has been completed and everything has passed, we get a secondary notification to say that all of these changes have been passed. And this gives us that full change log and accountability that we spoke of earlier as well. So what does this look like when we actually push this through our entire simulation and CD pipeline? You'll see on the left-hand side there the YAML files, which I spoke of. And just as an example here, we're just adding an interface to a YAML file. And then what we're doing is we're pushing this out to a subset or a certain type of device as well. And we're pushing out this in a template, which in this case we're using Ginger to have the template and for that to render the template that we saw before. And what devices do we push this out to? Well, all of these devices are stored simply in an inventory file. You can store them in an inventory file or something like a source of truth like Netbox to have them. But when you're using an SD-WAN fabric, you'll find within the fabric itself that that keeps a valid inventory file of all the devices that you have listed as well, and the types of devices. When we're testing this, we're storing this actually in an XML file as well, which holds the entire sort of topology for the testing. So when it goes through that validation process within the CI/CD pipeline, it goes through the simulation testing that we spoke of, where the configuration is rendered and tested before it's pushed into our production environment. So what does this look like? How do we measure the success? The success to net DevOps is through agility and to be able to design, develop, integrate, test and deploy at a lightning pace. What we want characteristics and our desired state of all of our network at once. We need to know the software and the versions which are installed, system attributes like ownership and addresses, and feature-specific configurations that we spoke of throughout this entire presentation. So what do those outcomes finally look like once you've put that pipeline into there? There's a wonderful quote which I always like, which is, everything will be okay in the end. If it's not okay, it's not the end. And so building a pipeline like this in for the infrastructure, there's a number of challenges to overcome when building this, but what the overall outcome looks like is actually having our network configuration stored as code. But this enables our network team to treat configuration just like you would software. And all the configurations therefore get developed and deployed with this modern technique using APIs and machine readable code that not only allows version control system, it allows also automated testing as we saw, and simulation testing as well, and builds in that entire peer review process, which allows us for accountability and ownership. By doing this, what we're building is a self-service monitoring, where network automation now continually monitors all of our pre-selected key performances or KPI indicators relating to our customer services, and also notifies our network team of any breach to the change of our service and our pipeline as well. This enables us to look at cases for events based on past things, and also glue all of these things together as well and correlate current events with also similar events. Now these could be global events taking place which see increase of traffic, or even things like DDoS attacks or any form of security breaches that customers are perhaps seeing across their entire network at all. So this has been a great presentation to demonstrate to you today. I hope you've enjoyed this. Building a CI/CD profile pipeline across an infrastructure using an SD-WAN controller or software-defined network controller is a great way to move a network forward and to bring all of the network into one ginormous pipeline where you have complete visibility across your entire infrastructure and services. If you've got any more questions, please stay in touch. My email is on the left-hand side. You can follow me at Twitter at Big Evil Beard. And a lot of the examples and code that I spoke about today are on my GitHub repo, which is GitHub at Big Evil Beard. We have a lot of this content also on Cisco DevNet, where you could try a learning lab out for free, and you can use a sandbox and go through this entire pipeline, which I've mentioned before, using both SD-WAN or DNA Center, or even NSO, depending on what your requirements are for your file, and that'll give you that hands-on experience if you want to experiment with this in a safe environment. I'm going to hand over to Alex now just to see if there's any questions as we begin to close this out. Thank you, Alex.
Brilliant. Thanks, Stuart. Great session as always. I can see there's some questions already coming in. First of all, a nice comment from Keith. Thanks, Keith. Very good. This is very much support this approach. So, it's gone down well. Okay, a couple of questions. First, from my colleague Sid. What is the current challenge you are still working on the journey of DevOps?
A lot of this revolves for the current challenges that I'm working on is embracing the tooling. and which tools to use. My father was a carpenter for many years before he retired, and I always think about the way that he did his work with his various different tools. And you know, so putting, say, like a screw into a wall, you perhaps wouldn't use a hammer. So one of the things that I, you know, or I have tried it once or twice. One of the things is always evaluating the tools and working on throughout that journey and which actually tools are going to work out best. It isn't uncommon to start working with one tool and then to begin to swap them out. And that might be something simple, just as like a tool like, you know, swapping out drone for Jenkins, for example, or swapping out an entire Python library as well.
Thanks, Stuart. Got another question from Gargi. Does an automated CI/CD pipeline reduce the opportunity for testers to validate quality?
That's a great question. In my experience, no. One of the reasons for that is a lot of the pipelines that I've worked on have always had people doing the validation as well, so that when you're making changes, you don't merge your own branches or your own changes. They still go through a peer review process with another team member, and those are merged within there as well. By the time usually it gets to that other team member as well, you've ran a lot of things like linter testing and automated tools, so that person can generally not only look at the change, but they can also look to make sure that a lot of the testing has actually passed. That's a great question.
Thank you. Thanks, Gargi, for the question. Next one from Devavana Sarkar. Any secrets you can share with us for managing CI and CD?
Secrets. That's a great question. Really, some of the things we've been doing with our CI/CD pipeline is really embracing shift left security, and that's securing the pipelines down. So we're not sharing things like tokens or user keys or anything like that within our pipeline. We're not sharing any critical information. Usually security is one of the kind of the last things you think of within the chain, but security is everybody's responsibility. And so what we're starting to look at now is actually building in security testing and validation right at the earliest stages, right when we're doing our kind of linting and testing within there as well. So, you know, security is everybody's responsibility. So I think that's a kind of a big thing that I'm looking into now to make sure that our pipelines are as secure as they can possibly be. Great question. Thank you.
Actually, the next question kind of ties into what you last said, and that's how do you handle security and compliance in your pipeline?
You can use a lot of security tools which are built in there, which will actually recognize whether things like keys are being shared or any information is being shared which shouldn't be pushed into the pipeline. We do a lot of these things when we're pushing our code up. Again, as it goes through the linting process, it checks and scans for things like vulnerabilities as well, and sends out pre-warnings around and that, you know, within there's some great tools which are available to be able to do security monitoring within the pipeline tools now. That's a great question, Sid. A really great question.
Thank you. Thanks, Stuart. I think one more question from Sudha Naik. Can you name a few?
Oh, he's talking about CI/CD security tools or security. Yeah, there's one. It's just my favorite now, and the name has just slipped me of what that tool is called, and I only started using it within the sort of last week. So I'm just going to look at just see the tools which I just put into this pipeline now. So I'm just looking into my pipeline to see what that tool was called. I only started experimenting with it within the sort of the last week, Alex, as well. Let me just pull the name of it. If I can't find the name of it, I will put it in there. One of the things that we was using before we migrated to drone was Circle CI as well. So we've used Circle CI as well as drone within the pipeline. That was the tool I was thinking of to be able to do that, and that enables us to do things like routine scanning, security testing, and also monitoring as well. So yeah, CI There you go. No. Circle CI was the tool I was thinking of.
Thank you.
You know when your mind
Excellent
just
session.
goes blank and you just go, what was that tool called?
Like forgetting a PIN number.
Oh, that happens to me quite a lot. That's why it's always 1, 2, 3, 4.
Thanks, Stuart. I think that's all the questions for now. So thank you everyone. Some really good questions there, and I've really enjoyed that session. So thank you. We've got we're great for time again. So thanks for keeping it to time. We've got the next session. One of the highlights. I mean, there will be highlights today so far, but we've got the panel session, which is on methods and tools for business value. And I know this is a really popular topic because we've had whole conferences on this subject, which I know Stuart can attest to, having spoken at them. So it's always a good subject. The panel starts in about 3 minutes at 12:40, and it's going to be moderated by Richard Self from University of Derby. So I would like again just to thank Stuart for a fantastic session, and enjoy the rest of the day. We'll see you very shortly in a panel. Thank you.
Thank you so much, Alex.
Thanks, Stuart. Cheers. Okay, so welcome back, everybody. I'm very pleased to introduce our next session. As I mentioned, one of the highlights of the day, as always, is our interactive panel session. And you'll recognize some familiar faces here from our speaker lineup earlier and later on in the day. The panel's on the session of methods and tools for business value. And it's hosted by Richard Self from University of Derby. So I will hand over to Richard.
Who's not here yet.
Ah.
Lovely, thanks.
I think Richard, I can see Richard appearing. Hi, Richard, can you hear us? We just can't see
I
you.
can. How odd. Has it picked up it may have picked up the wrong camera for this one.
I had a problem earlier, Richard. I just had to switch off my camera and switch it back on again.
You have to switch off and switch on.
The camera's on now. There's sometimes a problem. It picks. I've got theoretically two different cameras here. One is my let's see. Now, how do I change my camera? Sorry.
The little up arrow next to stop video. If you click that.
Oh, it's using the right one. So there's something odd going on here.
Is it possible you have like one of those camera protectors?
No, it doesn't have one. It's the camera is actually on. And let's look at the video settings. Yeah. So it was working a minute ago. So I don't know quite why.
Yeah, working fine backstage.
Yeah, how odd. Right, what should we do? We'll just stop the video pro tem and then restart it. There we are.
Oh, now it's working. Perfect. Excellent. I'll lurk in the background and let you carry on. So thank you.
Okay. Thank you. Okay, ladies and gentlemen of the audience, welcome to this discussion panel. We're looking at the question of methods and tools for business value. And I think it's really, really important that we concentrate on those last two words, business value. You see, if we go back over history, go back to 1994, there was a report produced by a research organization called the Standish Group, and they looked at success factors of IT projects, a big selection, and they were anonymous. And their first definition, which lasted until 2013, was a successful project was on time to budget and delivering the contracted for functionality. Because we don't build systems for functionality, theoretically, we build them to deliver business value. And so eventually they succumb to the pressures from CIOs and IT directors and so on. And then now their definition of success is an on-time to budget project which delivers business value. So I want us to be thinking about business value solidly for the next 25 minutes or so. So let's start, and hopefully Zoom's not going to move your photos around too much so that I don't call on you more than once in this first round. So we'll start at the top with Seb. What's your most important point we want to be thinking about in terms of methods and tools in this sort of overall context of the conference for delivering business value?
Yeah, so for me, business value always starts with having a well-aligned business vision with the delivery team. So communication is the area that I see the most challenges in software development teams delivering value, and specifically the communication between customer/business representatives and the technical delivery team. So the tool that I have used most over the past 10 years to help teams deliver value is called example mapping, which was invented by Matt Wynn and uses 4 different colored index cards and gets people around a table. Of course, over the past 2 or 3 years, we haven't been able to get around a table, so we've used other online tools, specifically often Miro. But it's basically, it's shift left taken all the way left. We're actually testing our understanding of what we're being asked to do. And while we do that, it enables the delivery team, who typically have a lot of domain knowledge, to challenge the product owner or a business representative to really define what they think, what the business value is going to be. And so that comes out of that initial conversation before any code or designs or test plans are written.
So you're really putting this sort of verification validation, which we know about as part of software testing, you bring that right forward to validating and verifying the specification.
Even generating the specification, yeah.
Oh, that's a really interesting development, because that's something I've been talking about at these sort of conferences now for about 3 or 4 years, since I got involved with another group who do the same sort of work in the same sort of field. And that has always been the question, because I've been involved in this field now for about 50 years, and very rarely do we properly verify or validate the spec. We only really do things like that at the last moment, just before we release it to production. So that's a really interesting shifting leftwards as far as you possibly can go. Thank you, Seb. Okay, Florian, what's your specifically important point here for value?
Yeah, sure. So hi, everybody. So I think from my perspective is definitely the method. How can you measure the business value? So usually you have like a classic revenue stream from this perspective, but talking now technically about it, like how when it comes to the DevOps principles there, how do they change when you basically implement a DevOps principle into your organization or into your field? So there are some KPIs what is good to measure. So for example, the mean time between failures there, like when is the problem found and when is it fixed there. Then the number of tickets, of course, like when something is basically not happening from the server side, from the networking side. So to measure, okay, where are the pinpoints, or where are mostly the digestion. And last but not least, this is basically the tool set there is, it's all about you need to measure it somehow. So you need to go very deep down. So this is where basically my point of view is like observability and monitoring is like a very big topic there. There are lots of tool sets out there, of course, like how to measure it. And from there, you need to measure from the hardware directly to any application, like directly to the function actually of your software stack, from bottom up to directly to your application, how it is behaving from your networking side, from your application point of view. And when you have this overview, then you actually can connect the business values there. So this is like definitely a huge point, and this will definitely like increase over the next years.
Okay, thank you. And Bruno, what's your point here that helps us to bring business value?
Well, I was hearing these feedbacks, and I wanted to bring a different perspective or a question, perhaps for you, Richard, because you've been working on this for quite a long while, and getting a question back at you, which was something that happened to me when I was a project manager like 10 years ago, but I see that it still happens nowadays in smaller companies. I was working in a major bank. Nowadays, I think major institutions are no longer falling into this issue, but many startups and new institutions are, which is for my part, I'm focused on product delivery. So basically, I'm focused on either, like Florian was saying, what are the measures I take, or like Seb was saying, what are and that's a very good insight. Okay, let me just check it and bring shift left to the maximum. But can we shift left even more, which is questioning, or should we? Perhaps that is the question. Question the client itself for what he is asking, giving a specific situation. An example, there's like a business unit, portals, presenting stuff, creating internal internet solutions, and suddenly there's a director from one area that's asking for a report that will take 36 hours to be produced, to be developed into the system. And you look at that, and should you, having understood what are his requirements, what he needs in that report, he's saying that he needs that. Shouldn't we also take to the next question up, which is, but what is the value for the company of producing this? I mean, because it's very easy for people who are not in IT to question things like, oh, I need this, so please do this for me. And sometimes what I notice is that the business asks for stuff without having any idea about the effort involved. So they may ask you for something that will take you a month to produce, and they think, oh, they do it in like half a day. So yeah. And perhaps in this case, it was a reporter, I remember, that he was asking for. He used it once a year, and he had alternative means of doing that. And he was asking that just for, I mean, because he thought it was very easy to produce. So he thought, yeah, in half an hour you guys do that, and I don't have to do, from my side, like a couple of hours work once a year. And he was forcing the IT team to 30+ hours of work to produce that for him. And there's also the other side, which is sometimes the business does not ask us, or they start to invent things that are not the easiest things for us to produce, that are not the best in terms of business value. That's the main thing, because they think, oh, this will take too much effort. And the business itself, the client, does not even ask us the final product, because they think, oh, I know this takes a lot of work. I will not get it on time. It will take a lot to deliver. And so I will ask something on the side that it may be not so good, but that they think they can work on. And sometimes what happens is that they ask for things that are not the easiest ones. And when we are talking to them and saying, but why do you need this? And then we say, oh, but I can solve that problem in half the time doing this other thing, and you have it a much better solution. So I think that my take would be, which is hard for the engineering team, and that's why the main part of a good product owner and having this communication, the functional analysts or the people who are making the connection between the business and the engineering team, are so critical for the efficiency and the business value, is in this regard, is to question and understand the problem and see if the business is asking the right questions to solve the real issues.
Okay, thanks. That's really interesting. It aligns with some of the thoughts I've had over the years, particularly in relation to the Standish Group reports, which show consistently over the last 25 years, we've been unable to have more than around about 30% of our projects on time to budget, delivering business value. And my gut feel is that the businesses are asking for 3 times too many projects, and they're rushing them. Probably 50% reduction in timescale compared with sensible timescales, reducing the budgets dramatically, the resources, and therefore putting every project into this, I know I'm giving a challenging target. So that's kind of really interesting. We need to think much more carefully about what products or what tasks we're setting for IT development teams, I think. Heath, what's your specific point that you want everybody to remember?
So I'm going to tackle it from a different standpoint, Richie, because I'm obviously interested in DevOps. So people have looked at the business value of the applications being delivered. Someone asked me a question in the chat about how do I justify the return on investment of a DevOps transformation. And so the business value I'm trying to get the business to understand is invest in DevOps so that it makes the ability to get that business value you've talked about in the application out quicker. Okay, so that's a different question to just whether that particular thing is there, right? And one of the problems we've got with the software development process is it's all virtual, right? It's all inside a computer. You cannot walk into a software development factory and see all the innovation that's just sitting on the floor, not being used, or waiting for the UAT team to test it, or stuck in a bit bucket somewhere that nobody's built, right? And so really, you know, there's two things that can make an impact here. One is, I talked about the urgency. If something happens in a company where there's some urgency, where they say, oh, this particular industry has now got a big player in it, starting to get ahead of the game, how do we respond to that urgency and create faster deliveries? Or you have a very progressive person who realizes the importance of software delivery and effectively acts like the CMO, the managing operations person, you know, who thinks of it as a production line and says, good grief, look at all the stuff we've got in the production line we haven't shipped. Because in reality, all that innovation has been spent money, but it's not earning money for the organization. So there's two things that need to happen there. So in terms of what I've tried to do, is I've tried to show people the value that's stuck in the pipeline and show them how we can get that value out. Now, the problem is it's very difficult to instrument that pipeline. So actually to collect the information from, I mean, if you had a manufacturing site, you know, and you looked at what Henry Ford did with the car, he took the car down from being 14 hours to be built to 2 hours to be built. Okay, so they could, you know, in effect, basically that'll work. Looking at it, saying, because if you do it in this way, it takes 14 hours. If I do it with a manufacturing conveyor, it does 2 hours. We can't do that because a lot of the stuff is all manual. So we'd have to have like a work study or something like that. So it is quite difficult to do that. So what I did is I've actually almost like hidden some of the cost and then showed the value. So in Ordnance Survey, we used a lot of free tools and I used a lot of enthusiasm from the team to build it. And then I showed people, I went down from 15 people to 6. And that got me more investment, right? In ADP, we did the art of the possible. We showed people what was possible and then got the enthusiasm going to make that happen. And it's really, really difficult because of that fact that that manufacturing line is inside a computer. It's not visible. Most VPs, all they want to see is, I've got this cadence. I get delivery once a month. I get a delivery once every 3 months or once a week. The function's going in. How fast can you do it? How many people do I need to give you? And it's really, really difficult in our industry to make that happen. So what I do, like I said, is look at the value stream analysis. That's a really good tool because then you can show how long it gets stuck in various parts. I use the force field analysis stuff as a tool, but it really is almost like a return on investment justification at a business case level rather than the tools that everybody sells as DevOps tools. It's got to be trying to get to the people who own the purse strings and get them to invest in you as a DevOps team.
Yeah, that makes a really, really important point that we need to produce our arguments and our justifications in terms that our customer understands, not in terms of techie, but in terms of business value, the money, resources, timescales that the customer really cares about. Okay, Marjolaine, what's your particular perspective?
Well, I think a lot is already mentioned, but it's all coming a bit together. If I look in low code, a lot of big companies who have legacy systems want to change overnight, and low code uses a lot of Agile, and it's not used in the right way. If Agile would be used in the right way with demos, with regular deployments, and also kind of what Keith said, the business value would be better because now we have a system that needs to be live in 2024, but we work Agile. But after the sprint, nothing happens if I'm not finished. I do not get a regular reply from the customer because demos are being canceled because we didn't got the sprint done. But if you consider, even in low code, even if you do not have a production environment, the test environment as your production environment, and demo every 2 weeks what you have, then you can show the business what you're doing, and the business can say directly, oh, but that's not what I meant. And then you can sit with them and then you can show them how important it is that the requirements are clear, that what the system needs to be doing is clear. And it will take some time, but if you do Agile right, with the demos, with the also the free amigos, bringing business together with development and tester, you will see that it will go smoother over time. And if you have like a waterfall way of developing and using Agile, it's gonna clash. And I think it's very important, maybe also in regular projects, but at least also in local projects, it needs to go fast. And to go fast, you need to have some standards before you can go fast. So make sure that your team knows what the business wants, that they are connected with the business, that they can ask questions, that the business sees demos, keep them in touch with each other. And I think that's very important. And also a bit what I heard with Bruno and the others. One example what I need to think about when I heard Bruno was, we had a guy who on the login screen wanted an animated picture because all the cool kids have it. And then I said, yeah, but we need like 2 weeks to make it. And it's just the login screen for old people wanting to see the medication schedule. So should we really want this? He still wanted it because all the cool kids have it. But I needed to think about it when I heard you, Bruno.
Yeah, thank you. It's interesting. You're talking about essentially demos. It's a little bit like prototyping. And I know that I built back in the mid-80s, or at least a very small team in SAS and ISPF, TSO, and so on the mainframe in company. We built over a period of 18 months, probably the largest project management system in the world, capable of handling millions of activities. And we had one guy involved who did the primary work in the 3 months kind of sprint, you might say. And he would work with the lead customer, the user, for an afternoon, do stuff, tidy it up in the morning, go back the following afternoon and demonstrate it and iterate it. And we built the 6 or 8 modules over a period of about 18 months. And that system then was running for something like 15 years, almost unchanged, until it got replaced by SAP. And so this idea of working very, very closely with your customer, the user customer, is absolutely crucial. If you can get integrated teams, and I forget who it was talking about, was it you, Seb, about the red and the 4 cards, 4 color-coded cards? Integrated teams working closely together, step by step, even at that 1-day cycle, is incredibly important, whether it's for the screen designs or whether it's for the processing. This is how we did it. And then at the end, when we're happy, then we would hand it over to somebody else who was not such a messy coder, who would take the code apart, rebuild it in a sort of maintainable fashion. And that was stunningly successful. So thanks for that bit, Marjolaine. Now to Kumar, for your key tip.
Sure. I hear a lot on Bruno's, and as well as, Seb also touched upon a point that is very important is, yes, the velocity at which today the Agile is delivering and the velocity in which the business is looking forward, that is the key part. And the tools which is heavily try to get binded as continuous integrations tools, specifically into continuous integration, focusing on continuous delivery. When I mean continuous delivery, I specifically say a continuous delivery with continuous testing in part of it. And that's the area I would like to go and take the zoom out piece in the quality aspects of every deliverables. Whenever we say, hey, we need a business value can be sustainable, can be valuable, and also you can, get this business value in a very, periodic manners, if and only if you're able to maintain the quality. A very simple example is, today, if I say, hey, I'm going to, allow you to give a cost of the plane to fly from, let's say, London to New York, 50% off of the cost, but the plane is untested. I don't think so anyone in this panel will be ready to fly in that plane. So that means it's very clear that as long as we are not giving the quality, you can win the first piece of business cake, but we cannot win the entire business cake very easily. So business value comes mainly on the quality point on it. Yes, the velocity is important, agility is important. There are tools. How you do it, the tools can help, and that is where we have to focus on. And I would love to take the piece of quality more in, if you look at it in the quality, there are various aspects, like I was talking in some of my session, and also I saw some of the sessions in low code. This one, automations plays a very key role. There are various testings which needs to be played a very key role. And as we try to hit the quality is spending an effort on it, and then reaching the velocity of the same and getting the innovation done. For example, we are talking in a world of where IoTs are sitting it. We are talking in a world where container and spectrums are sitting it. We are talking in a world where people are already in a microservices world with thousands to 10,000s of microservices, where people doesn't know, hey, if I zoom it on in 60,000 feet above, it just looks like a dots. That's what today's world is. So we are talking on the complex world with a highly innovative, range of spectrums, where by the time we talk, a new mobile will be getting released on the back of you, where you have to get it tested and so on. And when you are talking, your watch is already listening to you and so on. So that means many aspects of technology has been binded on it. And if you're really looking for a business value, you need to look at quality in it. As you're looking at quality in it, that's where the key points where you can crack and break the value of the business value. And specifically when you're looking at the direction of a quality, bind your process to the tool. That's my key message.
Thanks very much. We need to move on now quickly to
4
Manju.
minutes left.
Thank you. Manju, your key point.
Sure. Hi, everybody. So my key point would be like emphasizing more on what Nanda said. It would be on quality. Being from a testing side, I would definitely say, like, something that we need to focus on is a test maturity model integration, right, where we have a different levels, right? I always recommend and have to do an optimization stage. So I have seen a very great improvement in quality when there is a peer review of test cases done, and when we have a clear metrics of what is the result of the quality that we are produced, what are the different types of testing that we do. And of course, added on to the tools, right? So method wise, I would say definitely it's a test maturity model integration of level 5 optimization stage, where always it is a continuous improvement should follow. With the tools, I would definitely say on more of low code and no code to make it more smarter, right? It's not like in days like where we slog and we create a framework and we do. Now things are readily available. Let's just take it and make it like very easy for us. I would say that would be the smart work that we should be doing. Yeah.
Okay, so you're saying you go to the sort of low code, no code direction just because it makes it easier to produce it quicker. Is that what you're really saying?
One thing is it is making the work easier, and otherwise we can focus on different things, right? See, for example, the team which has to create a framework from the beginning, for example, a test automation framework. But what about how cool is it that already a tool is giving you that framework? It does all the hard work. You just need to do a smart work of managing the tool and making it in an easy way so that the team can focus their energy on testing something like a different, something like a non-performance. Even that also, we have so many tools. I would say definitely finding some unique bug or something, I would say the team should focus on. Where you have something available readily in your hand, why should we slog a lot of time in creating that?
I mean, the question then is, how good are these low code, no code tools at actually creating systems effectively?
Yeah, see, I have some time back, the whole of my presentation was about that low code and no code, how it makes and what are the pros of it. See, there are also cons in everything, but definitely I would say this low code and no code makes your work faster, and it gives you an accurate results, right, than of the other whatever the manual testing that we have created. So definitely I would say the change is happening. It is slowly, people are earlier, how there wasn't resistant to automation testing, now there is some resistance to this low code and no code testing, and I'm sure definitely it would change, and that would be the good future for it.
Okay, just a sort of question to everybody. We've only got a minute or so. We've seen in the sort of press and so on about the use of sort of these big, large language model systems, the NLP systems, which have been trained on code to be able to create software packages or chunks of software from a spoken type of specification, and it then grabs code from wherever and bolts it all together. Has anybody tried any of that? Do you see any future in that at all at the moment in the next, I don't know, 2-3 years? Or are they all too clever and unproven and stealing software from everywhere?
Yes.
Yes, what? They're stealing it, or that?
It's not a question of stealing software. It's a question of using it smartly. When we look at it, some of the stabilized tools like Selenium, or if you talk in terms of tools like JMeters, which have been there decades together, but it still gets you the value what you want with competing to the commercial tools based on a cost balancing act. And if you look at it in the same lines, if you choose a code of .NET OS Java, Java is going to be commercial shortly, but that's a different story. Or a code of .NET or Pythons, which are free of space. The capacity and the power what they have, it is enormous. Even if I spend it on commercial tools of .NET and licensing model, it's not going to get into that areas. So it's more the question of, are you stealing or are you playing around? It's more as, are you smartly taking what you want?
As a comment just came up, is Copilot, which comes, I think, from OpenAI using GPT-3 or one of those giant machines.
Yeah.
So I think we've now run out of time, ladies and gentlemen. So over to Alec. Thank you all
Richard.
very, very much.
A massive thank you to our panelists. A really great, stimulating session. I hope everybody enjoyed it. We come now to the networking session. So again, if you go into Expo and go into Mabel or Unicom booth, you can meet the other participants there, carry on discussion, maybe meet some of the panelists in there. It's a great opportunity. And then we're going to regroup after that at 1:20 for our afternoon keynote, which is by Dave Snowden, who I'm sure for many people needs no introduction. And Dave's going to be talking about engaging users. And I promise you that's going to be another great session. So enjoy the rest of the day and we'll see you back shortly. Thank you.
Thank you.
Bye.
Bye-bye.
Hi, everyone. Welcome back. We're very pleased to introduce for the second time today, Seb Rose from SmartBear. Seb obviously presented this morning, but he's got a different presentation this afternoon, which is on no code, low code, machine code. What level of abstraction is just right? So very topical, and I will hand back over to Seb.
Just a minute. Again, as this morning, my screen share is not enabled by the host.
Oh, sorry about that.
No, it's now in. It's now working. Perfect. Can you see my screen?
I can. Yep, we can see your screen and can see you. So that's great.
All good.
Brilliant.
Okay.
I'll go and lurk in the background and let you carry on.
Thanks, Alex.
Thanks.
So, hello. My name is Seb Rose. I work for SmartBear. I used to work for Cucumber Limited. They got acquired by SmartBear 3 years ago. I now work as developer advocate in the SmartBear organization. This session I have presented at previous Unicom conferences. I know that there's a no-code, low-code sort of theme running through today. This talk adds a little bit of caution to any hype that you might have felt so far, having heard the presentations about low code, no code already today. So my session starts with asking what the problem is, and we'll move on from there. So is there a problem that low code, no code exists to satisfy or solve? Well, let's look at software development in general. there are three common complaints that we hear over and over again from stakeholders and businesses around software development. The first is that there's a misalignment between business and IT, which really leads to the belief that we need to put the businesses in control, and we don't really want to have to communicate or miscommunicate with the technical teams, with test teams. We just want the business people think that if only they could just write the software themselves, everything would be fine. Second common complaint is that it's so slow getting software development teams to deliver anything useful. So why don't we just automate this and have reusable components, and now the business is in control and they can put components that have already been developed together and automatically create, deliver, deploy, and run their software. And finally, there just aren't enough skilled developers and testers in the world. Maybe if we had low-code and no-code solutions, we wouldn't need those specialist developers. So these are three of the common complaints, and they map quite well, I think, to a mantra that has been around for a number of years now, which is, let's get better software, let's have that software faster, and let's deliver it cheaper. So this was always, that holy grail of software development methodologies, tools, techniques, processes. We can get our software that's better, we can get it out in front of our customers faster, and it's going to be cheaper. Let's follow on from there. So this is the goal of low code, no code, or at least it's one of the goals of low code, no code. Research has been done around why organizations opt for using low code or no code platforms. This research is a few years old now, but it maps pretty well to the better, faster, cheaper mantra that we saw on the previous slide. Maybe the only bit here that doesn't feature specifically in better, faster, cheaper is enable citizen developers to improve internal processes. But let's pass that one for now. However, let's have a cautionary tale from my own personal experience. So I started programming computers in the early 1980s, and possibly in the first year that I was working with my first employer, this edition of Personal Computer World landed on his desk, and at one lunch break I picked it up and started reading it. First thing to notice is it came out in February 1981, so we're talking about just over 40 years ago. But the reason that I'm bringing it to our attention here and using it as a sort of cautionary tale is that there was a massive article, and it's the cover story is about a piece of software that was under development called TLO, or The Last One. And this is the quote: "At last, the end of programming." So TLO was intended to be essentially another 4GL, a way that business people could directly specify, design, implement, and deploy software without needing to use developers at all. I was still a young man. I was still at school, and I went to my boss and said, I was thinking about trying to do software engineering, computer programming at university, but this magazine says that this is the end of programming. Should I still do that degree, or should I try and look for something else? And he looked at me knowingly and said, I don't think we're going to be done with developers just yet. And for me, the rest is history. I went to university, I did a degree in computer science and electronics, and I've been working with software ever since. And I don't see any decrease in the demand for developers or testers for that matter. So just a very brief bit of history for how do we get to where we are today. So I don't know if this is in the beginning, but this is early doors. This is Colossus that developed during the Second World War. And this was often programmed by moving wires and changing components and actually fiddling with the hardware. We don't do that. We moved on from there. We moved through punch cards, which I'm not going to talk about, to machine code. So we had chipsets with an instruction set, which got programmed in binary. This binary is quite hard for a human to read. It's perfectly fine for a computer to read, but it's hard for a person to read. And so we came up with an abstraction above the machine code, and that was assembler. Now, assembler is still quite hard to, it's not hard to read as such, once you know the limited syntax that it has, but it's quite hard to understand what the intent of the machine code is. And for that reason, we have comments, which are a description of what the code is supposed to do. So we've gone from fiddling around with hardware on the Colossus to machine code that drives slightly more modern, well, that drives all computers, and the machine code, the assembler that makes that machine code more understandable to the human, and the comment that describe the intent of the program. And skip forward a number of decades, we have wonderful things going on in our IDEs. We have magic auto-completion, suggestion of what you might want to type. We've now got a Copilot on GitHub, which will borrow bits of code from the vast body of code that's already been written. There's still machine code underpinning this that runs that actually runs the instruction set on the chips that implement our operating systems. But essentially, we've gone from really hard work trying to work out which pin to move around on a chip on a switchboard to the development environment actually suggesting what code we might want. And now we move further on. We have low code systems that allow us to bring together regular components and configure them, and no code systems. So WordPress is sometimes billed as a no code system. And although I could have stopped at anywhere along those lines and tried to draw out some of the problems with a particular way of writing software or developing software, I'm going to just focus on WordPress for a minute here, because if you go and do a Google search or other search engines are available, if you do a search for issues around WordPress, you quite quickly come up with a whole bundle of people helping you fix issues that you've got with your no-code solution. So there must be some complexity going on here, because if WordPress is no code and it should just be pulling components together and then you just write the content, this is quite a restricted domain. So we're not even talking about general purpose software development, and yet you still have lots of people looking for people to fix your WordPress application, for want of a better word. Then something's missing, and there's a gap between the promise of no code and the actuality of no code, at least within the scope of WordPress. So let's just dig a little bit further into abstraction, because abstraction is, it's a term that's been in the English language for a long time. It's been a term that's been used in software engineering, software development for a long time. But I just want to dig into, the possible pros and cons of abstraction within software development. So first off, let's define it. Abstraction is a process of removing details so that you can focus attention on the things that are more important. So there's an idea here about, there's lots of different moving parts, but really just what are we trying to achieve? Let's focus on that. So abstraction is about lifting us away from all the tiny details of, maybe you could picture it as the cogs inside an old style watch, to focusing on the hands turning around on the front of the watch, showing you what the time is. And so in a way, it's similar to generalization. We don't want to look at all the tiny details. We want to look at the big picture. We abstract away from the details so that we can understand what it is we're trying to achieve for our customers. And this is a way of taming complexity. However, there are two sorts of complexity. There's accidental complexity. This is where we're sort of searching around for a solution, and we come up with lots of ideas and designs and things like that, and they become complicated and complex over time. And this accidental complexity can be simplified. It might be a new idea, a new design, a new technology, a new skill. but it can be simplified, and that simplifying that accidental complexity will make your software easier to use probably, and certainly easier to maintain. However, there's also essential complexity. If there's complexity that you remove and it causes your software system to lose value, then this is essential complexity that should not have been simplified, because now your users, your stakeholders, can't achieve the outcomes that they wanted. This is a man called Jim Capleen. I was very lucky to meet him a number of years ago at the ACU conference, which was at that point held in Oxford, and he annoyed the C++ developers in the audience by coming up with this statement: abstraction is evil, right? So many of the languages that we have used over the past 20 years to write software have been object-oriented languages, and object-oriented languages have been built on the idea of an abstraction of a class and class hierarchies that allow us to concentrate on the things that are important rather than the details. He goes on to say that in most object-oriented design, most abstraction is evil. And the important thing here is the next statement. Abstraction is an excuse to ignore things that we don't want to deal with, even though we should. So abstraction takes away from the details and helps us concentrate on the big picture, but sometimes the details are important. I'd go a little bit further to say that in most software systems that I've ever come across, the details are the important thing. If you get the details wrong, your customers will be unhappy. So complexity. In no-code and low-code solutions, we're not focusing on the details. We're reusing components. We're wiring them together. We're having business people build their own systems. We're not getting stuck in the details. So what happens to the complexity, the essential complexity of the problems that we're trying to solve? Well, part of that complexity disappears into configuration. So what you see on the screen here is a configuration screen for a widget or a component that gets used in WordPress. So this is, it's not code, but it's quite complicated. And some of the complexity is being pushed into configuration. It's being configured using dropdowns, but you have to understand what each dropdown does, what the implications of it are, and that may not be very obvious. And so although this looks like quite a complicated configuration screen, I can imagine far more complicated configuration screens than that. Additionally, when it comes to troubleshooting, it's really problematic with many no-code and low-code solutions, because the whole idea is to abstract away from the details. So if there's a problem in two components interacting, how do you get down to the detail of their interactions to work out what that problem is? This particular example comes from a low-code, no-code solution that, low-code solution that I used a number of years ago, that you created a state diagram using a graphical interface, and then the low-code solution generated source code, which you could then configure. What I found in this particular case was that although the file that was generated had the big warning at the top of it saying, do not edit this file, it is machine generated. Quite soon after we deployed this within the systems that we were working on, we came across a problem in the generated code, and somebody had the bright idea of going in and editing the generated code to fix that problem. Of course, that had another knock-on effect, which was now the IDE could not read the generated code and regenerate the state machine diagram. That's just one concrete example of how troubleshooting low-code solutions or code generation solutions can be problematic. And finally, this is a classic quote from a discussion website where they were talking about the TLO product from the 1980s. And the quote, I think, is really classic. TLO not only worked eventually, but for many years, its publisher made money out of a consulting business wrapped around the software. So they were trying to create a piece of software that would enable business people to create, develop, deploy their own software without needing to use highly skilled developers and testers. And the side effect was actually they ended up needing consultancy from the people who created TLO, because although it was supposed to be business usable, there was so much complexity that was hidden that they needed consultants, specialist consultants, to help them get around those problems. So I'm going to take those 3 complaints that I showed on the first slide and then come up with these 3 oversimplified solutions that I believe the low-code, no-code movement or hype is trying to pitch to us as a community. So, misalignment of business and IT. We should be able to use low-code and no-code to have the business specify the software themselves directly. However, there's always going to be a need for IT domain expertise, because you need to know how you're going to deploy it, manage it, maintain it, deal with your customers. It's oversimplified to say that the low-code, no-code is going to get to market faster, because you're going to have to find the right components, you have to customize them correctly, and then if you do find that you have problems within a component or interactions between components, then you have to spend time customizing to troubleshooting it, and potentially it makes it not any faster, but even slower. And then finally, the shortage of skilled people. By using low-code, no-code solutions, it doesn't mean you don't need skilled people. First off, you need people who are skilled in the low-code, no-code tools that you've chosen. And if they don't work well, now you need even more specialist consultants who are experts in the specific low-code or no-code tool that you've chosen. So low-code, no-code promise, or at least suggest, that they will be able to help fix this misalignment of business IT, the time to market and speed issue, and the shortage of skilled people to work on your software. But in fact, even with low-code, no-code solutions, even with the best ones that are currently available, we still have issues in all 3 of these domains, all 3 of these areas. To add hype to hype, then people go and say, well, as AI and ML get better, that'll fix the problem. I think of AI and ML as a knight on a charger jousting with the problems of the world. AI is the little man in control of the horse, and underpinning that artificial intelligence is vast amounts of machine learning. Now, there are all sorts of issues that go into that we could talk about with regards to artificial intelligence and machine learning, which I'm not going to deal with today. What I do want to say, though, is that AI is a term that is frequently misunderstood. Back in the old days, when people talked about AI, they were thinking about robots. They were thinking about a general intelligence where you would have something like commanded data in Star Trek. However, that's not what we've got today in AI. What we have is weak AI or narrow AI. And here we have machine learning assisting very specific algorithms to solve a specific problem. So some of those specific problems are now more complicated or complex than the problems that were solvable or soluble by machine learning 20 years ago, but they're still very narrow. It's not possible at the moment to go and speak a specification or a requirement to a narrow AI and have it generate a piece of software that you can work with. Just think about what you can do with Siri. It's very narrow. You can ask it to send a text message, but it still misunderstands what you say and sends misspelt messages with bad grammar to the wrong person. So AI and ML are wonderful tools, but specifically narrow AI is a tool that we have at our disposal for specific solutions, not general purpose solutions such as an application that can develop any software application that you want. So where does that leave us? Let's go back to the 3 challenges that we started the talk with and find 3 appropriate solutions. I believe that misalignment of business and IT is about collaboration. We're going to need to have the business, the stakeholders, the customers collaborating more effectively with IT. We've found over the past 50 years that throwing specifications over the wall are insufficient. The Agile period from the year 2000 to today has found that having a product owner working with a team on a daily basis improves things. I think we've got further to go. My personal approach to solving the misalignment between business and IT is to adopt behavior-driven development, or more specifically to shift left and do early learning with a collaboration technique called example mapping. For time to market and speed, I believe that continuous delivery is the solution. What we want to do is automate the testing, automate the build, automate the deployment, and automate the delivery. And at this point, what we can do is we can get candidate solutions from idea to at least potential release very quickly. And in the shortage of skilled people, we've got to address our hiring policies. There are going to be more people with skills that come out of universities, that come out of boot camps, that come from learning it themselves through apprenticeships. But what we need to do is stop writing out job descriptions with long lists of skills and expecting to find people that have exactly the fit that we want. Organizations need to take the responsibility of hiring people who have the right aptitude, training them in the way that they need, and ensuring that they are retained by giving them autonomy and remuneration that is commensurate with the benefit that they bring to the business. So the takeaways that I'd like to leave you with: essential complexity should not be simplified. If you can find a domain where there is narrow AI that will be able to deliver very componentized, very regularized, well understood solutions that's over and over again, then perhaps low code, no code solutions are the right way to go. But if you, by adopting a low code, no code solution, you are getting rid of it, or you're unable to include the essential complexity of your problem domain, then you're making problems for yourself. And AI and ML are not solutions for this in and of themselves. They are tools that can be used to craft slightly better low code, no code solutions, but they are not yet and may never be general purpose. Automation itself is a skill. By giving people tools that they can use, it doesn't mean that they don't need to understand what they're doing. That's true in automation, and it's also true in communication. We need people with skills. I do not believe any of the low code, no code solutions are ever going to get rid of the need for skilled people to operate them, maintain them, and debug them. So my final takeaway is that no code, low code is not and may never be a universal solution. I was going to have a stronger statement there and say, and will never be a universal solution, but everything's possible, and I'm prepared to be proven wrong. So thank you very much for your attention, and I'll hand over to Alec with questions if there are any.
Seb, thank you very much indeed. Second great presentation of the day, much appreciated. Just waiting to see, we've got some questions coming in. I'm just going to have a look in the chat. Sometimes it takes a minute as people are typing. So yeah, no, sure. That was a really good session.
Thanks.
We're slightly over time, so we've got, I think, about 4 minutes for Q&A. So I'll just read the questions quickly. First one that's come in. When is the low-code development ideally suited? It's a good question.
Yes, so I believe that low-code development is ideally suited if you're not working in an innovative area, if you're working in an area where the same thing is being done over and over again. So if you think about some of these website generation arenas, this is a reasonable place for low-code development. So I think WordPress is a suitable. I mean, I use WordPress. It's fine for doing sites that are mainly blog oriented. So as long as it's a well-defined area that's well understood and you don't want to do massive customization, low code, no code is a reasonable way to go.
Yeah, and the next question is, what innovations do you expect within low code?
Yeah, so what I expect to see is more, slightly less narrow AI integrated into the low-code platforms that exist. I'm afraid I'm not overly confident that the low-code solution space is going to see innovations in a period of time. My feeling at the moment is that we're on one of the standard analyst hype cycles with low-code, no-code. We're finding it difficult to find the staff. We're finding software to be expensive. So there'll be a lot of solutions put forward that in the short term will appear to be a great way to go. But in the longer term, I believe we're going to be building up a legacy of debt in those low-code, no-code solutions.
Thanks, Seb. An interesting question. Can you recommend, or do you have a link that would help build experience and support on low code to take it forward?
Well, no, I don't. So I think that's one of the problems, which is that low code is most of what I see coming from the low code community is product development, people trying to sell you stuff, right? So they're giving you really big promises and they're showing you nice case studies of very well curated domain where the low code has been beneficial. I would caution though that I think that benefit, even in some of those well curated case studies, is going to become a drag after a number of years, because these low code solutions do not have the same tooling to help you maintain a huge system. If we look at, for instance, what am I thinking about? So some of the big accounting or inventory management systems that are supposedly low code. What I've seen is that most organizations who try and deploy them, they don't have the right skills in-house, so they bring in external consultants. The external consultants deliver to the requirements that they see on the books and then move on to other jobs. And then when it comes to enhance, change, modify the implemented solution, it's really hard because they are not well structured. The software development using programming languages has got a large amount of tooling that's been developed over many decades to help us analyze complexity, see the linkages, help sort of reverse engineer what was implemented. Whereas a lot of these low code, no code solutions are really all about build it and run it, not go back to it, work out what it was supposed to do, and be able to refactor it. So refactoring support, for instance, in low code, no code solutions is almost absent. I mean, maybe I could just, if I've got one more minute, Deborah Bauer says that low code is going to be the next big thing, but I differ from the experts that say that. No, I think low code is going to be the next big thing, and then low code is going to be the last big thing, and people will move on back to writing software using skilled software development teams, because I think that low code is going to overreach itself. I believe organizations will buy into the low code promise of better, faster, cheaper. I believe that people will be sold it on golf courses, and then 5 years later, we're going to be ripping it all out again and bringing it back in-house to develop using more tools that have lower levels of abstraction.
Thank you. Thanks, Seb. Great session as always, and perfect for time. So thank you very much on 2 levels for that. We've got our next session now just starting from Florian on ML Ops 101. So again, Seb, thank you very much indeed. And it was a pleasure. Thank you. I'll see everybody in the next session.
Bye.
Thank you. Hi everyone, welcome back again. I'm very pleased to welcome our next presenter, Florian, who's got a really interesting topic. It's on ML Ops 101, building an ML pipeline with Kubeflow. So, Lauren, I'm fascinated to hear your talk. I will hand over to you. Thank you.
Thank you, Alex, so much. And hey, everybody. So let me just start here and share my screen so that we can get started. Let me just start here the presentation mode. Yeah, let's dive right into it. For the next 30 minutes, MLOps 101, I think it is a very important topic, and it will definitely be even more important in the future. And why? Yeah, let's figure this out. So first of all, you can see here the gender. So what can you expect the next 30 minutes? So first, I would like to talk about machine learning nowadays, just to point out some important aspects. And then we will actually build together, theoretically in a way, and I had it written, a sample ML application without MLOps, like that you can see what you need to do. And based on this application, you can actually see, hey, there is actually a need for MLOps. And what about the MLOps ecosystem? And then we will actually build based like together with Kubeflow, which I will explain later on, this machine learning application with MLOps. And yeah, last but not least, there will be the conclusion there. So first of all, or like in a way, who is talking there, just to have a bit of background. So I'm part of the Cisco DevOps team. I have a software and networking background. And here you can see some projects there, but right now I'm focusing a lot on machine learning and of course on this specific MLOps part, especially machine learning at scale. So machine learning nowadays. So I usually would like to start with a really easy example there. So I don't know if you know, so like this is my Google Photos account. So you can see photosgoogle.com, and this is actually real. So when you actually type in, when you upload your Google Photos in your smartphone, like on my Android phone, and you type in hamburger, for example, in your Google Photos, then actually like images of hamburgers or like these, what you photographed, or you will see. You can type in like cats, then maybe your cat will be there, or your dog, and so on. But this is basically like one example of machine learning application. This, for example, is using deep learning, where it will detect hamburgers, which are looking like this. So the bun up, the bun at the top, and the patty in the middle. Then that you can see, hey, this is basically a hamburger. And this is just like one daily example, right? So there are lots of other examples used in various fields in various industries. Coming from the technical field, I'm using also from the networking field, I'm using some examples. So there is, for example, especially for networking, Cisco AI Network Analytics platform. So here you can see when you onboard a wireless client. So this has something to do with access points there. Like your smartphone is basically connecting to the access point. You can see that the failed onboarding sessions here are rising, especially in the morning till midday. So here you can see like there is some issues. There's definitely some issue going on because the predicted value should be like in the lower 20s. And here you can see it goes up like to the 40s or 60s even, where something is happening, something needs to be. And what can we do with it? This is, again, machine learning based, saying, hey, there is an anomaly. You can see, hey, there is something wrong there. And so you will get a notification that the operator needs to do something. Another example is, for example, like the removal of background noise. So this is a machine learning application. So for example, if you talk to something and there is some cracking in the background, or your colleagues are talking in the office, then, for example, with a really simple radio button here, you can do some noise removal. And this, again, there's a huge machine learning application and backend from there. And finally, like last in the end is about from my examples, and there are tons of them, of course, is like bots. And here this example is like also like a WebEx bot, for example, where people are chatting with other people, like with customers, for example, and then actually with NLP, so natural language processing, they actually talk to bots, which they don't even realize, or it's written there, but they have a really human feeling, especially when it comes to like really simple questions and other things. All right, so like with that being said, you can see, and this is the outcome of these things, the machine learning model is actually just the tip of the iceberg. So like the model itself, like the inference actually, like the trained model, like what was already trained, you could see like all these applications are actually like a tip of the iceberg. But actually what is below? Below is like a lot of machine learning preparation, a lot of training the data, a lot of creating the model. So there goes like a huge thing there, like what is beneath the iceberg. And this is what we will explore. And this is as well, like how can we make this also more efficient? But first of all, like before going as well into all these MLOps, it is very important, like how are these machine learning applications built? So why is it important? Because like to understand MLOps, you need to understand how machine learning applications are built. And with that, I have actually brought an example. The example is like that. So we as the human, we have a human brain, we have like a computing processor, and this is our brain, which is pretty powerful. So we can actually detect, hey, these are handwritten digits. We can detect this as 0, a 1, a 2, and like throughout the lines, we know, hey, this looks like this. And with our brain, our image processor, we are actually can detect that this handwritten or is basically a number, this handwritten symbol. And yeah, let's do it actually now and create a machine learning application, or let's try that a computer is actually doing it to detect like what is written there. And this is a classic example. This is why I'm using it, because it's super easy. Like this is like a machine learning 101 project where you do handwritten digits recognizer, because you can see here in the digits, you can see like there is an image. And this image has 28 pixels, like 28 in the width and 28 in the height. And you can see that the white one, or the white the pixels are, it is a 0. And the more black it is, you can see it like this. Then it's like a 233, or the maximum value is like 255. And you can see right now, so like the computer actually is computing numbers. And this is the most important part. Like an image is nothing else than a bunch of numbers to the computer. And these bunch of numbers you can compute, and you can create out of it a machine learning a model. And from there, you can detect those the handwritten digits there. How does it look like? I'm sorry. How does it look like? Like, how does the application look like in a way? So as you can see, I'm not going super deep into the machine learning part. I will just cover the overall step. But like for you to have a basic example, for those who don't, maybe you're already familiar with that. This is even better. But MLOps will come in the next part. So the machine learning application you can see here is this, for example. So there is on the left side, I see a really simple application with a digit recognizer. So you just like write with your mouse, and then you say detect. Then this will send actually like the image, or basically like this 28 pixel image to the machine learning model inference server via REST API. And then here, a classic one would be, of course, you do some model training there and update the inference model or the inference server with the latest version of the model. So basically, this is all what's happening. So you have digit recognizer, the REST API, and the machine model inference server or application. So how do you do this? So really simple in a way, like there are 4 steps, and these are here. So first of all, what do we need to do? First of all, we need to get the image data. So image data as in we need to get the handwritten images. So usually, of course, you need to write all the images, or like you need to write handwritten images, scan them maybe, and then pre-process them. So this would be the second step. So pre-processing image data, like cutting it to a standardized format. And then, of course, do image labeling. So you need to label the image, for example, like the handwritten image, that this is a 2 or this is a 3. So you need to do this by hand, or like maybe there are, some other numbers. So with the labeling, I just visualized it a bit, especially for those who are new. Is like you really need to check, like this is a 0. Like look at the left corner. and this is a 0, and this is a 0. So you need to detect or like label all of those images there, especially like so that the machine can actually realize, hey, this is actually the output or the true result of this handwritten digit. So if we go back, so then we need to define the features, like for example, okay, what kind of like do we want to state if this a grayscale image or not? But I think our feature is like pretty sure it's like we say what number is it, like the feature is just a number, which is said is a 0, this is the 9, this is the 8, whatever there is. The third part is to select, of course, like the algorithm. How would you like to do it? The machine learning framework, which would fit the best. And then, of course, the hardware. So usually you can check your training in the cloud. You can, if you have a GPU on-prem, you can do the training on-prem. If you need for inference the GPU, then how can you do it? Like put it in the cloud, put it on-prem. So this is really up to the app developer. And fourth, of course, like once we build the model, there is of course some building the application there. So in order, because we had this inference server there. And this all comes together now, because you can see there is a lot of stuff happening. And this is also why this is then coming all together with the need for MLOps. So going to a really cool graphic there, you can see, and this is part of the based on David Scully's research paper, Hidden Technical Depth in Machine Learning System. And he said, like, this was 2015, that actually machine learning code, and here in the middle you can see it, is actually one small part, or one part, let's say, of all the other components. So compared to data storage, you need to have a data pipeline, you need to have feature engineering, you need to have like the right machine learning framework, the serving infrastructure. So all of these things, they are basically really tricky, of course, because machine learning code is important, but then again, there's so many other things around it. And to back this up with facts, actually, or with data, you can see that by a survey from Anaconda, you can see that data scientists spend around 45% of their time on data management tasks. So you can see here, like the blue one, 19 is data loading, 26 is data cleansing, and 21 is data visualization. So here you can see like 45%, over 45%, they spend a lot on the data itself, because the data quality is very important. You can have the best model, but if you don't have like the right data, then the model won't work, especially in production systems. Also, another survey from McKinsey is like a lot of companies are stuck in the pilot stage. So only 36 of respondents said that the machine learning algorithms had been deployed beyond the pilot stage, which is pretty low, like 36% only, they are stuck in the pilot stage, they can't move any further. And this is why it is very important to create a framework around it. It is very important to define or focus as well on the other components there. And you can see it like this, like with DevOps. So classic example with DevOps is you combine software development, the developers, with IT operations together. So this is you have the set of the practices, the set of the principles there. And now out of it, basically out of it, you have MLOps. And this is why it is very important to focus on this, because MLOps is similar to DevOps, is that it combines basically data and machine learning engineering. So the data scientists, the machine learning engineers who are creating the model, they are put together with IT operations to, again, provide the hardware, to provide, of course, the container management, to provide the logging and the monitoring system. But then also, because it's part of the application, it will also combine like software development. So this is usually, some people say MLOps is like a mix of DevOps and machine learning engineers. But here put into this, it's like there is a triangle where machine learning engineers are working together with IT operations and, of course, the software development team. Right. So finally, what comes there? So like there is already right now like a huge MLOps ecosystem there. And I also would like to start with Kubeflow actually, because start with Kubeflow. Kubeflow has everything included. I will talk about it in a bit. It's like an open source machine learning ops framework. And I think you get a pretty good understanding, especially when you start with Kubeflow. So yeah, so this is the huge landscape. So don't, it is fine if you get a bit overwhelmed with all these logos there. But this is a classic example of from the Linux Foundation, AI and data landscape. And you can see here, like, just focus here on the left part, or like here on the left captions, where you can see there are frameworks for machine learning specifically. There are frameworks for deep learning, like here, for example, classic TensorFlow or PyTorch. There is for reinforcement learning, programming, as you're familiar with, data, lots of data framework when it comes to various data relation databases, when it comes to data versioning, which is also very important, feature engineering, stream processing, visualization, data visualization, and then machine learning model, like a bunch of tools, like how to create machine learning model workflow, how to train machine learning models there. So you can see there are a bunch of and lots of tools out there which help, especially with machine learning model development. The tricky part is how make them work together. And this is what machine learning ops is definitely all about. So it's the data scientist or the machine learning engineer, they know, okay, this is my model, I know how to build it. But now is the time, how can we, or like how can DevOps personnel, how can IT ops, how can they support these teams? So with that, just to have some examples out there and just to have some specific names, is like for infrastructure, a lot of people are tending to, of course, like to Kubernetes, because it has like a scale out scenario, which is where you can do a lot of horizontal scaling, especially when it comes to if you need more workloads for training. There is GPU support as well. So this is definitely something you need a good infrastructure there. Data streaming, version control, just to say some names there, like Apache Kafka is a classic one. Data version control, Pachyderm, machine learning model framework, as I already said, like with TensorFlow, PyTorch, for example. And then, and this will come in a bit, is like collaboration of various machine learning models, or between the data scientist team, Jupyter notebooks. So you have Python, and I will show this in a bit in the browser. And then very important part is think also about like model serving, because once you created the model, how do you serve it? There will be you need maybe a load balancer, you need like some serving applications there. So this is example, and Kubeflow is using Kserve as an external add-on for that. A bit about Kubeflow. So Kubeflow is an open source machine learning framework, so which orchestrates and automates machine learning frameworks. So this is like just a screenshot there. And Kubeflow runs on Kubernetes. So Kubernetes it's very important, so that because it leverages basically the whole Kubernetes ecosystem. So if you use Kubeflow, and if you don't have any Kubernetes guru next to you, get started as well with Kubernetes, like to know more about it. For Kubeflow, and I will show this now. So we have some popular components. So Kubeflow has several components there. So you will have the Kubeflow notebooks, which is the web-based development environments. Then very important, like the Kubeflow pipelines, because with the Kubeflow pipelines, you can actually build a whole machine learning pipeline. And I will show this in a bit in the demo. Ktip, I don't use this in the demo. This is like for AutoML. And then Kserve, which was previously KF serving. So the team split up there. And Kserve is used for model serving there. All right. So with that being said, so like to know a bit, have some backend stories with Kubeflow. The question is actually, so how can we enhance our machine application using the DevOps principles? And with that, I have now like created some architecture so that you know, okay, where how it looks like, and it would look like this. So first of all, I built this on a Cisco Intersite Kubernetes cluster. On top of it, I deployed Kubeflow. And then I will show you now with in the next steps, basically, is about Jupyter notebooks. So like how our data science team working together. how can they they store the data, or like in this demo, they store the data in min.io with Kubeflow pipelines actually. So you're creating with Kubeflow the Kubeflow pipelines within the Jupyter notebooks. Like this is a possibility. There is a specific API for that. And then you actually directly with the Kubeflow pipelines, you create an own KF-serve instance and K-serve instance, and there you can do a classic model inference there with the digit recognizer. All right, so with that, this is the whole overview. So let's get started. So first of all, I think it's a classic one. Just I did an orchestrator there. So like I just said, hey, Cisco Intersight, please download Kubeflow files, use customize, and then deploy Kubeflow there. So this was a pretty simple and straightforward command that you install on your existing Kubernetes cluster, that you install Kubeflow there. And then one thing is about, first of all, data sourcing. So very important thing, this is like you have data streaming, you need to have a data ingestion and so on. Lucky for us, there is already some data set out there. So the MNIST data set with handwritten digits. So after you, of course, did some data sourcing, and of course, it's very important here that also the data set has a versioning tool, like that you actually say, hey, this is data set version 1.0 or 1.2, because data will be added. Machine learning models, the model won't stay the same. So it's very important to definitely get a centralized database or object storage out there. And create a specific versioning tool for this specific data set. For the data management, there is it's very important to set up a collaboration tool so that there is a specific code, single source of truth for all the data scientists to work on that. Maybe also some testing tools, of course, like for each scientist to test on a specific data set, test on a specific model there. Like I said before, so we have the MNIST handwritten digit data set. So let me actually go now to the browser, and here you can see the Kubeflow dashboard. So this is the Kubeflow dashboard like the home screen basically, and Kubeflow works like this. Like they have various modules there and various components. So for now, I will go to notebooks. And you can see here that you can actually create your own notebook server. So if you click on new notebook, you can spin up your own instance with predefined, PyTorch, TensorFlow, whatever you like. You select the number of GPUs, how many CPUs and so on you would like, and then you click on launch. Lucky for us, like I created already the notebook server. And when you open this one here up, the Jupyter Lab instance will be there. And then you can actually see I have already some Jupyter notebooks there. So when I click here on the Jupyter notebooks, you can see that this is basically like a simple Python or like a Python script there available, where you can create your Kubeflow pipeline and collaborate with what kind of data or data test you would like to have. So once you created this, I will now go back to the slides there, because now it comes to after the data management what you have. Now it comes to machine learning model development. And here again, it's very important to standardize the frameworks within the organization. Be aware that data will change, that's for sure, and add a really good like a model management so that you can see like how your model is performing there. And I will do it now like this. So again, I will with the API, so with the Python components, as you can see here. So I won't go into the detail of the code, but per you can see like I go to the bottom there. There are some steps which I can create with Kubeflow pipelines. So if I just run this script, and I just can run this with by selecting Shift and Enter, I'm creating out of this Python script here several components of a pipeline.
Hi, Florian, sorry to interrupt you. Just to let you know, we're slightly over on time, so only got 5 minutes left, including the Q&A. So just giving you a
Right.
reminder.
Perfect. No, thanks for that, Alec. I will be done in a
No
bit.
problem.
Thank you for that.
Thanks.
So basically, what was triggered right now is the experiment. So you can see here that I can actually, because I triggered this in the Kubeflow pipelines, you can create experiments, what I just did with this Python script, and see here how they are being executed. On the right side, you can also see like a good overview of the model accuracy and the model loss. And when I would like to check like how does the processor look like, which I created with just a simple Python script, you can see this. So you can see here that you get the latest data. You can see it here with some details like the logs, for example. But what kind of data here you created. Then reshaping the data. So you can see here that what kind of that it succeeded and the data is reshaped. And then with the model building, so you can see here the specific input parameters, the number of epochs time, what kind of optimizer you're using, then some kind of the metrics there, some the accuracy, and some metadata. So for example, with visualization, you can see here the confusion metrics, you can see here the model summary, the performance, and so on. And finally, also the model serving. And here, coming to my last part actually, is about model serving. So when you can see here is about application model serving. So the cool thing is that we actually included this one in the CI/CD in the pipeline there, in the Kubeflow pipeline, and that you can actually directly do it in Kubeflow as well. And when you go to models here on the left side, so we have here the runs, we have here the pipelines, that you can see that there is already a model server there, a digit recognizer. And here you can see the URL, the internal external URL, and there you can send the data to and see, hey, to your web application, hey, is this an 8, is this a 9? Then you can detect the digits there. All right. So yeah, so with that in mind, right? Like, what are the key points there? So key points is definitely don't focus only on machine learning models. There are other components as well. Have a framework ready to automate the processes. And then, of course, go hybrid. So leverage workload on-prem, use only like the minutes or the workload what you need for the GPU. For example, in the cloud, have your classic web application on-prem, like whatever fits your need there. Yeah, with that being said, I'm all good. I hope this was useful to you.
Florian.
Feel free to stay in touch there, and let's see what questions there are.
Thank you. I'll be really quick, and apologies because we've such a good talk. I didn't like to interrupt you, but we've literally got about a minute for questions, and I can see one question that's come in, which is, when is it best to start with ML Ops? I think we've just got time for this one question.
Right. No worries there. No, cool. So basically, that's a usual question. So it's like, it is definitely time when you have like a huge machine learning application. So if you have just a small one or just a small part of it, then you don't need to start super big. Like have a framework ready, especially for huge workloads, especially when you work with like lots of data. Then it's definitely needed. If you have like just for testing or for experimenting, let's say, then there is not that much needed. But if you are really focusing, if you have a team, at least a team for data scientists, machine learning applications, then definitely go for it.
Thank you very much indeed. That brings us pretty much up to time. So again, Florian, big thank you for a great session. And sorry we didn't get more time for questions, but I think there was a lot of information, a lot of ideas in there. So much appreciated. Just to let you know, the next part of the program, it's a tradition of this conference. We have a session where we showcase some sort of cool and new technologies and interesting companies. And we've now got a very short tool showcase, technology showcase by Mabel, which is starting shortly. And then there's an opportunity to network and visit the expo to talk to Mabel, and also to see the other participants in the booths. We've then got our next presentation, which is at 3 BST, and that's on overcoming the testing bottleneck in DevOps pipelines, which is something I know is a topic that comes up a lot. We've been asked a number of times to have a session on this, so it's a really good subject, and that's by Fernando Matos. So we shall see you in a technology showcase in about a minute or two, and then later on we'll see you in the next session. Thank you, and thanks again, Florian.
Sure. Thank you so much. Bye-bye, everybody.
Bye.
Hi, everyone. My name is Andy Horgan. I am a solutions engineer here at Mabel. And today I'm going to talk to you about and walk you through some of the Mabel platform, a unified intelligent testing platform for your entire team. So what we're looking at here is a Mabel workspace, which is just a shared testing environment. And you'll see you have a lot of great metrics about everything going on within our testing environment, number of teammates and tests in the workspace. We can see all the recent test runs over the last hour. We can also see the different environments we have configured for an application. And toggling between these will actually show us the different output of our test results for that specific environment. And then lastly, we'll be able to see all of the recent plan executions for that workspace. And within Mabel, a plan is just a suite of tests or group of tests that help replicate some sort of user journey, or maybe it's a group of tests that all touch a particular feature. The Mabel trainer allows us to record our interactions with our application from that end user perspective as runnable steps to our test. And it does so in a very seamless, intuitive way in which we simply start interacting with the application, such as clicking on this login button, and then having that step get recorded as a runnable step. We can also, in a similar fashion, make assertions and validations against our application with this dedicated assertion button, which allows us to select any of the elements within our application or assert against, say, the page URL or some sort of cookie. In this instance, I'll select that pop-up. We can make that assertion type equals, greater than, contains, any number of these different types, as well as a number of different attributes or properties we can assert against. In this instance, equals inner text should be perfect, and I can click OK. And so with a couple of clicks, we've already started to do some negative testing in our application. But a great benefit of Mabel is the ability to wrap these steps into what we call flows, which is just a reusable set of steps. In this instance, I'll go ahead and import this login flow. And you'll see it's used across 14 other tests. And so as I play back this flow, you can see it, walk through the application, inserting the data, much like a user would to authenticate in. And the benefit here, of course, is not only are you saving time on the test creation portion of tests, but also from the maintenance side as well. If anything changes to how we have to log into this application, all those, we would simply need to update that flow once, and that change would propagate throughout any other instance of that flow. And so there's all sorts of other ways we can interact with our application via these more advanced features, such as executing custom JavaScript code, using conditional logic. So if we see X, do Y. If you see Y, do Z. We can loop flows within our tests. We can use CSS and XPath queries. We can make API requests as part of those UI tests as well. So if we wanted to validate something on the back end based on some sort of front end interaction, you have the means to do so within Mabel. So we allow you to handle very complex end-to-end user scenarios while abstracting away all the complexities of a traditional coded framework. But some of the other benefits of Mabel come from the test output side of things. So if I go ahead and close this test here, we'll actually just switch back to our workspace. We can start to see how we can begin to orchestrate these tests in a meaningful way in which we tell Mabel how and when to run our tests and what kind of meaningful insights we'll get from the test output perspective. So within Mabel, plans are the when and the how of we're running our Mabel tests. It allows us to define whether we run our tests on some sort of set schedule, such as Monday and Wednesdays at 5 a.m., or if we want to run on deployment triggers, by integrating within your CI/CD pipelines. It's also the mechanism that allows us to run our tests within different stages. We often find this lends itself well to the paradigm of set up, test, and then tear down. So for instance, we can have these tests run configured in a number of different ways in these stages, such as having our first stage maybe run in parallel or in sequentially if you have tests that are dependent on each other in order to create data. In other stages where maybe we're just doing simple validations, we can run any number of tests in parallel, really being able to leverage the scalability of Mabel to increase the efficiency of your end-to-end tests. Also within Mabel, a really unique a unique way we can leverage our plans is the ability to mix and match API tests alongside our UI tests here. And so you'll see in this particular plan, we can not only have a UI test that generates some sort of access token, we can then pass that data forward to another standalone API test. And this really gets the benefit of being able to run in a headless fashion, so that when we are doing these data interactions, such as creating a client, we can do so via just API and be able to really get some great efficiency in the execution of these plans. Finally, on the test output perspective of Mabel, we're going to collect a lot of different data and diagnostics to help ease the burden of root cause analysis. So for instance, if we go to any one of these steps within our test, what you'll see is we're capturing all this data, such as a screenshot of the application at the time of that step. We'll highlight what element we were interacting with, and then we'll provide logs about what was Mabel doing when it tried to interact with that element, what kind of network calls were being made by the application at that time. In this instance, we see we have a couple of 403s and a number of 200s. We'll provide a full DOM snapshot, as well as console logs as well. Of course, we also provide performance metrics of that step over time, and we give you the ability to download all of this data in a really easy fashion. We also, try to be best in class by integrating with all of the different tools that, every team may be using. So for instance, in this instance, we could, really easily create an issue in Jira directly within this test output perspective. And then also switching gears, looking at our different integrations, you can see, we really integrate with any number of tools that you might be working with, be that Jira Cloud, Slack, or any number of CI/CD tools, whether it's through our native integrations or through one of our API-based solutions, where we allow you to trigger Mabel tests and retrieve those results programmatically.
Hi, everybody. Welcome. Thank you for joining us again. I'm delighted to welcome and introduce our next presenter, who is Fernando Matos. Fernando is product marketing lead at Mabel. And as I mentioned earlier, we've got a really good presentation topic, which is on overcoming the testing bottleneck in DevOps pipelines, which I know is a topic that fits really well with this agenda. So it's a pleasure to hand over to Fernando. Thank you.
Thank you, Alec. Let me share my screen. Sorry, I got kicked out of Zoom here.
The same happened to me, but I think we're back in, so all looks good now.
All right. Can you see my screen?
Perfect. I can indeed.
Right.
That's great. So I'll just hang around backstage and I'll be watching from the side.
Sounds great. Thank you, Alec. Appreciate the introduction. Hi, everyone, and welcome to Overcoming the Testing Bottleneck in DevOps Pipelines. As Alec mentioned, I'm Fernando Matos. I'm the product marketing lead at Mabel. In case you're wondering, Mabel is the leading SaaS platform for intelligent low-code test automation focused on high-velocity teams, right? So exactly focused on the topic of today's session. Let me briefly introduce myself, and we'll get started with the session today. So again, I'm Fernando Matos. I've spent many years in my career in computer science and engineering. Then I moved into product management, and now I'm in product marketing. I hope that doesn't mean I'm going to end up in sales in the future. In the past 6 to 7 years, I was the product manager for products focused specifically on the SDLC. So I was the product manager for the Swagger open source tooling for API design, which became the Open API specification. And then I was the product manager for Zephyr, which is one of the most popular test management solutions in the market today. And I'm sure you're familiar with that. So I've been in the software development space for some time now, and it helped me build a passion for the SDLC and the future of software development. Right? My mission is to empower testers to really embrace all aspects of quality engineering and become customer experience advocates for the development teams. So what are we discussing today, right? What do we mean by overcoming the testing bottleneck in DevOps? Let me share an outline so you know what to expect. We have a short session today, right? I'd like to make sure that you leave today with a few practical takeaways. So we'll start with a typical DevOps pipeline, and very briefly, I'll give an overview of the different stages, right? Just to make sure we're talking and using the same language. I'll then talk about the testing bottleneck. So I'll give a brief overview of the different types of testing typically added to the DevOps stage and why this strategy leads to a gap in user-centric test coverage, right? Creating this testing bottleneck. I'll talk about the proposed solution here, which is through careful choice of specific user-centric tests that you can embed throughout the DevOps pipeline. And I'll touch on Mabel's capabilities, right? I'm only going to touch on specific features that are related to achieving this goal, right? And hopefully entice you to learn more about us. And we'll have a Q&A session in the end. All right, so let's get started. First, let's talk about a typical DevOps pipeline, right? And again, just a very basic, very quick overview to make sure we're using the same nomenclature. If we break it down to the most basic components, right? The DevOps pipeline is really composed of the following stages here, right? There's the code stage, which is the stage at which developers are working solo, right? Creating and updating product code, typically working on a local copy of their code. Then you have the pull request stage, which we separate into two parts here. There's a commit stage, right? Where developers add their work to an experimental branch of the source code. And there is submitting a pull request itself, right? Which is where the experimental branch is merged into the main branch. And then finally, you have the deploy stage, which can be broken down into multiple stages depending on how many environments you have, right? So in the most basic form, you have deployments to ephemeral environments, right? Which are short-lived and focus on testing. So you have your preview, development, and staging environments. And then you have the deployment to production itself, which represents a functional change to the software in production, right? That impacts your users. All right, so just with this basic understanding now, let's look at the testing in these different stages, right? And why we need to, why the way that we prioritize this test now leads to a testing bottleneck. So let's talk about the testing bottleneck. Again, just to make sure we're using the same nomenclature, I'm sure you're tired of seeing the software testing pyramid, right? But at least here's what an ideal pyramid looks like. And let's just talk about that real quick, right? You have the base with unit tests, right? These are focused on individual modules and functions or components, right? That are tested in isolation. The reason that this has the biggest volume, right? And you want that to have the biggest volume is because they're hyper fast to run, right? They provide immediate feedback to developers. But then they are the furthest away from the user experience, right? Running this test and having them pass doesn't give you any guarantee that you have quality at the UX level, right? Next up on the pyramid, you have integration tests, right? Which is where individual modules are combined, right? And tested as a group to ensure that, you know, the different modules can talk to each other and the application behaves as expected, right? Working together. Again, these are fast, but still very focused on specific functionality and removed from the user experience. The next stage up is where you finally get to end-to-end tests. This is where you're going to test how a user would actually interact with your app, right? Typically at the browser level or really at whatever level the end user is interacting with, right? If you're an API-first company, then your users are going to be interacting with your product via the API, and that's where you want to test. But this is the point at which you get closer to the user experience. And then at the very top, you have your exploratory testing, which, you know, by definition, they're exploratory, they're manual. It's an important step, right, in the quality assurance process, right? But they're typically done by testers, quality engineers who are very closely in touch with how the product is used by your customers, right? So how do teams typically spread these types of testing across the DevOps pipeline? Let's look at that. Because of the existing set of tools and frameworks that are in the market, and because they're typically too cumbersome and inefficient to automate end-to-end tests, right, early in the pipeline, teams will typically focus on unit testing during the earlier stages of the pipeline. So the code stage will typically focus on unit tests, maybe some integration testing. During the pull request phases where you have integration testing, right, That's going to be the biggest focus there. And then as such, end-to-end and exploratory testing end up being pushed only left for the later deployment stages, right? And these are the ones that are closer to the UX. And this is what really causes the testing bottleneck, right? Most organizations concentrate their user-centered tests during the deployment stage. Right? And finding end-to-end issues this late in the game can just cause a domino effect, right? Preventing developers from reaching the cadence that the most mature organizations or their competitors achieve, right? So it's completely offensive actually to the DevOps philosophy, right? So how do we solve for this, right? How do we remove this bottleneck? How do we enable our teams to really benefit from the speed of DevOps? And that's the core of what we want to talk about today. So let's talk about how to test in DevOps, right? Specifically, how to integrate end-to-end tests earlier in the pipeline. And here's our proposal, right? We'll show how it's possible to scale end-to-end testing, bringing them all the way to the code stage, running on a local branch. I know you can't read the details here. So again, let's walk through the different stages of the DevOps pipeline and talk more details about the types of testing that should be included in each of these, right? Let's start with the code stage, right? Where developers are working, again, they're working on their own copy of the code base. In this stage, they typically save their work locally multiple times, right? And they run tests locally. The goal of this stage is to provide quick feedback to the developers to ensure that they have working changes, right? And to achieve this, in addition to what your teams are traditionally doing, right? Which are running the unit tests, running maybe some integration tests, linting and static code analysis, right? To catch some obvious coding issues. We also believe that developers should get some quick feedback on core end-to-end tests, right? Of course, not all scenarios, but exercising a happy path perhaps, right? And the best way to achieve this is to run a set of headless UI tests, right? Because they're fast or faster than normal UI tests and API tests, okay? Next, we move on to the commit phase, and what I believe is also the most pivotal point in the whole process for a DevOps team, which is submitting a pull request, which is where, as a developer, you have a set of changes that now I'm proposing to merge into the main branch, right? At this point, I have to be very careful, or better yet, we as a team have to be very careful that we don't merge something without proper testing, because once it goes into the main branch, in theory, it's on its way out the pipeline through an automated process, right? Or at least a semi-automated process. So the primary goal here is to not let something get merged that could potentially stop the pipeline and force a rollback, right? Which is time-consuming and expensive. We also want to know that there's effective end-to-end test coverage, right? Related to the change that was just implemented, be that a bug fix or a new feature. So to achieve this, in addition to what traditionally your teams are running, right? The unit testing, the linking static code analysis, probably running more comprehensive integration testing. Ideally, they're running right code and test peer reviews. Maybe some teams are doing some exploratory testing, really done manually by a quality engineer. In addition to all of this, right, we have a little more time in this stage, and we propose that you should also be running UI and API smoke testing. So not only the core scenario, the happy path, but additional scenarios here. Visual testing, cross-browser testing, right? And UI and API feature testing as well, right? And all of this ideally should be triggered by your CI tool. All right, so then from this stage, once all of this is passing and approved, we move to the deploy phase. So once we hit the deployment stage, once everything looks good, right, and we're happy with the core functionality of the code, this code gets merged into the main branch and we start down the automated pipeline, right? The goal here is to make sure now that we don't let any defects out to production to impact our users. And we want to make sure that we have comprehensive testing related to the changes before they get deployed. We want to aim for a broader understanding of quality at this stage beyond functional testing. And to achieve this, we believe you should run, right, all of your regression testing, your API and UI end-to-end testing. We propose also a performance review at this stage, right, to ensure that changes are not significantly impacting the performance for your users. And accessibility testing, right, which has become critical in recent years. So this is the deployment stage. And then what about production, right? Should we run any tests directly in production? We believe so, right? You need to be careful not to overload the system and cause potential performance issues because of the testing that you're doing. And as such, we recommend it to run nightly testing or periodic testing when the user load is lowest. Our main goal here is to catch issues due to dependencies to third-party services, right? Which may be updated outside of our control. For example, e-commerce platforms, in-app chat, which is very popular, third-party APIs, browser updates, which could impact your users and all of that, right? You want to make sure that you're monitoring those and testing those in production to catch those issues. So on top of synthetic monitoring that you may be doing, right, we believe you should also run some sort of regression testing, cross-browser testing, and UI and API end-to-end testing, right? In production, hopefully nightly. So that's it. That's our proposal for scaling and embedding end-to-end tests within the DevOps pipeline. But how do you actually achieve this, right? Let me briefly touch on Mabel's capabilities here, right? As I mentioned before, Mabel is focused on specifically helping high-velocity teams achieve quality engineering, which is, you know, some of the core tenets of quality engineering are embedding holistic quality, right, beyond functional testing throughout the entire SDLC, right? I'm not going to cover all the capabilities in Mabel, but I want to touch on the following ones today. I want to touch on low-code test design, right, which helps to separate intent from implementation, auto-healing to minimize maintenance, the ability for developers to run tests locally, right, for the quickest feedback, branching support that allows testers to pair with developers on feature branches, task coverage reports to identify gaps and tell you where to invest more, and then CI integrations to allow, of course, allow you to automatically run test suites, which we call plans, against any environment that you have, right, including all the ephemeral environments created in your DevOps pipeline. So the first capability I'd like to talk about is low code. So why is low code relevant to our discussion here, right? It's important because you want to enable the entire team, including non-technical members, to create tests and participate in quality. Without low code, we're going to necessarily limit the number of people and the roles who can participate in quality, as they typically need to learn to code in Selenium or Cypress or all those other tools, right? The other reason is you want tests that are focused on the user experience, right? You want the people that are closest to the customers to implement the tests, or at least to participate in the implementation of those tests. For example, you want manual testers, you want product owners, members from your support team, right, to be involved in quality, so you don't end up with silos in quality throughout the team. And also, you want to focus on intent instead of implementation. Applications are getting more and more complex these days. The last thing that you want is for your test creators to spend hours and days figuring out how to test the scenario, right? You want the tool to take care of that and abstract that away. So now machine intelligence has evolved and it plays a big role in low code, and it enables low code. And let me show you how. The reason that low code works well today, not only when it's implemented but as the application evolves, is auto-healing, right? The system itself is smart enough to update tests as the application evolves. Why does this matter in a DevOps team? Well, for a DevOps team to work efficiently, you have to create and maintain trust with your developers. And the number one reason developers lose trust are flaky tests. It's absolutely frustrating to wait for tests to run and then not trust the results of those tests, right? Not trust whether the failures are actual bugs or the test that just ran into some race condition. Right? Worse yet, there's no worse situation than having someone for the QA team just tell you to run the test again. So with auto-healing, the system is smart enough to update the tests as the application evolves. And over time, developers come to trust that the tests are actually, the test results are actually correct. So just to give you an example of auto-healing, right? If the intent for a given test is to submit a form, right? And there's a submit button on that form, and then that submit button is changed, right? With a traditional test automation solution like Selenium, like Cypress, the submit button maybe has a new ID, and the test is going to fail, right? Because the test relies on the ID to locate the button. You're probably very familiar with this challenge. With auto-healing, because we're collecting a lot of contextual information around that submit button, right? And not only that, but around all the elements that your test is interacting with. Even if the ID changes, we can still find the element based on the other properties that we collected. Right? And once we find the element, the new element, if we run the rest of the test steps and everything passes, then we're going to assume that the test is working as expected, and we're going to perform an auto heal, right? So Mabel will automatically add a node to this auto healing, right? And we can send a notification via Slack, so you can confirm that this is what you expected. But this saves an immense amount of maintenance work, right? That many times have teams throw away all of their UI tests because of maintenance work. So again, this goes back to what we just talked about, right? Separating intent from implementation and letting the system handle the complexity, right, and the implementation, right? So this enables testers to represent their users and focus on the user experience. So this is all good, right? And we can build the trust with developers, but developers like to work on their own environment and they like to be efficient. So let's talk about, in our proposal here that we just talked about, we talked about enabling developers to run a subset of end-to-end tests, right, locally. We talked about headless UI tests and we talked about API tests, right? So let's talk about Mabel's local runs, which by the way are unlimited and we don't charge for. So why is local runs important? You need to make it easy for developers to run the tests, right? And they absolutely must be fast. Nobody wants to sit around multiple times per day waiting for tests to run. And also developers don't want to leave their environment or open a new application to run tests every time that they save or commit their work, right? So with local runs, you can create a test suite, right? A plan in Mabel with a subset of the specific end-to-end tests that you want your developers to run, and that can combine UI tests and API tests. And then you can easily give your developers the CLI command to run those tests locally. And developers can choose to run the test headlessly, which is faster, or they can choose to run the test in the browser so they can see the execution in real time. And if your developers are using Jest, they can just automate this so that tests happen automatically on every commit, for example, right? This way they have a set of end-to-end tests that run in the background in an unobstructed way to let them know whether the changes are breaking any existing functionality. And by the way, you can use this even for accessibility testing, right? We have some customers running accessibility tests locally to make sure that developers are not introducing new accessibility issues into the main branch. So talking about branching, right? Another related capability is branching support. You want to know, for example, you want to allow a quality engineer to pair with the developer on the changes that are happening on an experimental branch, right? They want to make sure that they can modify and create new tests for the new features that are being developed. And you don't want those modifications to impact the tests that you're running in production or in later stages of the deployment, right? You want to have an independence between those. So Mabel allows you to work on branches that can be tied to the work in progress feature branch and propose those tests and promote those tests along with the code. So how do we know where our test coverage has gaps? Right? You need to nail test coverage down to specific pages and features, right? Mabel crawls through all your application pages and understands the complexity of each page. And it also integrates with segments. So it can combine usage data, right? And provide a clear view of page complexity in usage versus all the tests that you have for that specific page, right? So it provides comprehensive test coverage reports at the release and page level to help your team identify gaps and focus on building tests that will have the biggest impact on your user experience. And with these reports, you can easily identify the gaps when new features are being developed in the coding phase. And what about running tests automatically in the deployment stage? This is where our CI tool integrations come into play, right? Mabel allows the ability to reuse tests across different environments without the need to duplicate those tests. So from your preview development environment to your staging to your production, you can have your CI tool automatically trigger Mabel tests, which include your full regression test suite, your cross-browser testing, and even accessibility. So for example, during the pull request stage, right, you can get all the contextual information about the tests that have been run at your fingertips, right, and even click through to see the results inside Mabel. Alec, are we doing fine on time?
We're just 2 minutes over. We're into the question time now. We had 10 minutes for questions, so we can take the questions whenever you're ready.
Yeah, let me just wrap this up. Anyways, this is what I had actually. So Alec, that's perfect timing. I hope this leaves you with some practical takeaways, right, and entice you to look at Mabel. and see how we combine low code with dev friendliness and intelligence to enable your team to innovate faster, right? And innovate at the speed of DevOps. Just a very important takeaway. If you're not a customer yet, you can start a free trial. We have a 14-day trial. We have an award-winning support team. We have formal POC process that your team can help you evaluate Mabel and understand how you can integrate all of this and have specific milestones and KPIs. And let's go, Alec. Let's open up for the Q&A session.
Okay, great. We've got about 7 minutes for questions, so I'll dive straight in. So I'll just read them as I'm seeing them. So first question is, we're just testing pre-production today. Any tips on if we should start shifting into pull request or prod phases and what to prioritize?
Yeah, absolutely. So we do believe that you should, yeah. And that's the whole goal that we have here, is to allow shifting left end-to-end tests that you can, right? Developers can run locally and understand, and you can limit and create a test specifically for a subset of the end-to-end tasks that the developers are working on. Right? So as they're implementing features and saving and committing, they can run those tests and make sure that they're not introducing issues that will impact your DevOps pipeline down the line.
Thanks, Fernando. Another question coming in from Bola. Is end-to-end testing always feasible when you haven't got all the environments, especially test environments, available? How can developers do end-to-end testing on the code they've built?
That's an excellent question. And yes, there are indeed specific situations where an end-to-end test is not possible, right? And that's really up to you to understand which ones are not possible to run locally, right? But there is a subset of those tests, especially a happy path, that you can create as a subset and give to your developers, right? And you get a lot of value from running those tests locally.
Thanks. Another good question just come in. Do you have any advice for getting more team members, i.e. developers, involved in testing?
Yeah, actually, there is a big movement, right, for the developers to handle quality, right, and get involved in testing. What we're trying to do here is to bring the whole team together, right? And that's why we believe low code is so important. Low code enables not only your developers, but the whole team, right? Non-technical members, business users, product owner, support team, to get involved in testing. We also, for example, Mabel does allow the use of JavaScript snippets, right? So that your developers, if they need to extend the functionality of the low code trainer that we have, they can do that as well. But we believe that the whole problem is actually bringing the whole team together to create a culture of quality.
Thanks. Another question is, could you share more insights on API testing?
Yeah, absolutely. I guess I didn't touch much on this. I mentioned API testing. Our low-code tester, our low-code trainer, actually allows you to implement API tests. So it integrates directly with Postman. So you can import the Postman collection. You can assert specific expectations that you have from the API using low code, so without programming. And you can also extract variables from those API calls, right? So you can extract a variable from one API call to test and assert a different API call, or extract from an API call to assert a UI test, for example. Right?
Thanks. Another question for you, Fernando. Does Mabel support performance and load testing?
Yeah, it doesn't support performance and load testing yet. That's something that we're looking at. Mabel is a unified platform, and we envision it to support quality engineering and supporting holistic quality, right? And we see that our customers, a lot of our customers, reuse end-to-end scenarios that they did for functional testing, and they want to reuse those for performance and load testing, right? And we are investing in that, and the platform is built to support that. We do, at this point, performance insights. So we help you understand specific tests or test plans, which are suites of tests, how they perform over time, and if they deviate, we let you know. And we'll be investing more into performance and load testing over the next year.
Okay, thank you. And this slightly different question. Many software companies do not automate testing. This is because some tests still require manual testing. What are your views on this?
Yeah, that's exactly where we're trying to tackle here. And we understand that, and we talk to many customers who still have a lot of manual testing. And those have many reasons, right? It's one is the existing workforce, the lack of coding knowledge, perhaps, or the difficulty to get started with Selenium or other high code automation frameworks, if you will, right? Mabel's focus with the low code trainer to allow the entire team, including manual testers, to implement some automation without knowing coding, right? And with the use of auto healing and machine intelligence, we make sure that those tests work as the application evolves, right? So, which is another big problem that you have with the high code automation frameworks. So anyways, to summarize, yes, this is exactly what we focused on. And we believe that it's a first step to allow your manual testers to actually implement automation, right? And still keep some of the manual tests as manual, that's fine, right? Or they can focus on exploratory testing, but it gives them a way to get started.
Thank you very much. Thanks, Fernando. I think we're pretty much we're up to time. We've got time, I think, just literally for one question. Can I ask you one more, which is coming? It's interesting. What are some of the precautions that teams need to? So, what are some of the precautions teams need to consider before implementing DevOps pipeline, as per your experience?
Yeah, I think the biggest one is don't try to create too much testing, right, for your developers. Developers are really focused on being efficient, right, and being able to save and commit their work multiple times per day. And the testing, it needs to provide a quick feedback, and it needs to be reliable, right? Those are the core tenets that you need to keep when working with the developers and implementing this pipeline, and just keep that in mind.
Thank you very much indeed. Fernando, fantastic presentation. And thanks everyone. It's been really interactive, lots of questions, so much appreciated. I hope you enjoyed that as much as I did. I think, Fernando, we've got the Mabel booth here, so I guess if anybody's got any questions, they can pick up some handouts, materials from the booth, and also if you go into expos, you can go and visit Mabel there as well. We're about to start our next session. Next presentation is going to be by Richard Self. You met Richard earlier. He was moderating the panel session earlier, and he's going to be talking on testing AI. Model cards will add value. So again, thank you, Fernando, and we will see you in the next session.
Thanks, everyone.
Thank you.
Nice talking to you.
And you. Cheers. Thanks. Session is entitled Testing AI. Testing AI, model cards will add value. So I will hand over to Richard.
Let's see. I'll share my screen.
We can't see your camera yet, but
bother.
I can see,
hang on.
Screen looks fine. That's it.
I'll have to do that again. There we are. It's curious. This platform has a little bit of a problem that if I come in with my camera live, it kills it. Anyway. Okay, thanks very much for that,
Looking
Alec.
fine now.
And I guess
I'll
you can
hand
see
over to you.
Can you see the presentation now?
Yes, we can. Yeah, it looks absolutely fine.
Oh, excellent. Right. Okay.
Brilliant. So I'll hang around
thanks.
backstage and hand over.
Yeah. Okay, lovely. Okay, ladies and gentlemen, my name is Richard Self, as has been mentioned. I've been involved with governance for quite a long time. One of the areas I'm particularly interested in is how do we make sure we can use our technologies in the most effective way and in ways which are compliant with laws, regulations, good practice, ethics, and so on. And I've been concerned for some while about the way that we are developing and testing and proving our AI systems, because I've taught at a range of software testing conferences now for 5 or 6 years, and we've known how to test traditional algorithmic type systems for donkey's years, and we're getting better and better at it, as I'm sure various of the speakers today have covered. But when we look at many of our AI systems, then we seem to have a bit of a problem, because they don't work like traditional systems. Basically, we just have a whole long, big series of if then else's, essentially, in our traditional types of systems. But AI systems don't work like that. We train them to detect patterns, or the vast majority do. And I'm going to be taking you through a little journey today about what some of the consequences of that are and some of the problems we end up with that perhaps something called a model card will help us to provide a greater level of trust in the AI systems which we try to go out and create, develop, or just use. So there are a whole range of interesting questions we have to ask ourselves. And I want to start off with a very, very basic one. What is AI? Because there are so many perspectives of AI, and there's an awful lot of people out in business and elsewhere, particularly in academia, who think of AI and immediately think of neural networks, deep learning, etc., etc. But it's actually much broader than that. And where we have these problems of systems which are trained, not just process chunks of data. There are some ethical questions which we need to be thinking about, and we also need to ask questions about our data. In our traditional systems, we kind of assume that the data will be the data, and that if we build our systems correctly, then we'll have validated the data at the beginning, and you could test it with traditional test harnesses and so on to make sure all the data that goes into databases is as clean as we can make it. And yet, even so, over a period of time, within 3-4 years, often much of our master data is contaminated, which is why data science practitioners and data AI practitioners spend maybe 80% of their time cleaning the data before they start doing anything interesting. So we've got problems with data. We have problems with our algorithms because our algorithms are bolted together to find patterns in the data rather than doing particularly specified stuff with our data. And because of all of this, we need to think about how do we provide evidence to support, hopefully, a developing trust in our applications, our AI applications. And I got a bit of a shock this last week, and I'll be bringing this particular piece into the back end of the presentation, where a lot of data scientists have created all sorts of interesting metrics to help evaluate the accuracy and the efficacy and so on about our AI systems. And it turns out that in many situations, particularly it came out in the healthcare diagnostics environment, some of the data, the metrics are extraordinarily misleading. So I want to cover that as well. This is new stuff which hasn't ever been in any of my business presentations. So you're privileged to have some brand new thoughts. Now, defining AI is interesting, and you can go to lots and lots of people, academics, practitioners, developers, all sorts of people, and come up with all sorts of different definitions of what AI is all about. But fortunately for us, about 1.5 years ago, the EU decided they needed to think about what is an AI system, and are there circumstances where we need to actually put in place considerable levels of regulation in terms of the safety of human beings. And the AI Act, it's not gone into full implementation yet, it's out for discussion, but what it has is a really clear definition of the types of systems which they and their advisors, they've had huge numbers of academic advisors on the panels, helping them to come up with the types of systems which they want to class as AI, and also which ones, what application, what use cases or circumstances should fairly strict levels of regulation actually occur. And so Title 1 and Annex 1 of this document will help you understand what AI is. And it's very easy, just Google draft EU AI Act and you'll get to this URL here. And it's a great big PDF. Now, the important thing that you need to think about is that, one, AI is defined as something that we give it an objective and then it goes and does stuff. It produces recommendations, it can produce predictions, it can produce decisions, it can classify, have you got a particular illness, or are your vital statistics in relation to this illness showing that you're okay and you don't need to be treated. That's title one. This is the annex one here, the 3 bullet points. And these are interesting because the first bullet point is modern generation 3 AI, pattern learning systems, neural networks, deep learning, all of these sorts of things. The second bullet point is something that I was expecting to see there with my background of over sort of 40, 50 years in the business. It covers the generation 1 and 2 types of AI that, you know, from the 1960s onwards. Logic systems, symbolic logic, knowledge-based, inductive logic, rules-based systems, inference, and so on and so forth, and expert systems, all the sort of stuff we knew about in the 1960s, 1970s, 1980s, before we had the second AI winter. And then, and it was about the early 2000s when compute power began to become big enough that we could actually implement these things called neural nets. Which have been around for a few years, but we couldn't do anything with them until the early 2000s because we had enough compute power to, and then we came out of the second AI winter. So we've been using neural networks now for 20 years-ish. However, when I saw this list, the thing that really surprised me, but also actually I was relieved, was it said 3 statistical approaches, Bayesian estimation, search and optimization methods. In other words, the technologies that have been used in big data analytics for the last 20 odd years, because they are being used for things like decisions or with predictive analytics. Shall we offer or accept this person for a loan, for an insurance policy? What level of premium should we apply? And they would pour data, huge amounts of training data from the last 3-6 months into the machine overnight or over the weekend, and get sort of 6 different predictive analytics models, which were rated for success. And that, of course, bumps into GDPR. So these are what we call AI. And the ones that we're particularly interested in, what they call high risk, these 2 ones are to do with sort of science, technology, engineering, and management type systems, safety components within car products like AI inside autonomous vehicles, operating things like the national grid. But then we have these groups here. These are the ones which fundamentally affect humans. They're taking their personally identifiable information and they're basically coming up with types of decisions. And we saw about 4 years ago how Amazon were looking in the field of HR to use an AI system to analyze and parse and process job applications, and they discovered that it learned the patterns that Google had been using for the last umpty years, that they only employed males by and large. And so the system became massively sex discriminatory. These are the sort of problems that we have. This is, you could say, most of this is the field of social sciences, where the data is not precise, where the data is not exactly measured, mostly. Not all of it, but mostly. But all of these are treated as high risk when analyzed with those 3 eras of technology that we had in the last slide. Ethical, well, one of the problems we have at the moment is there's too much we can and we will do stuff. And we have too few people, whether in the academic research area or actually within businesses at times, who say we can, but we will do, rather than we can, but the question is, should we really be doing this? Do we really understand the ethics? And yes, indeed, much of this is that should be answered by the project sponsor. Some of it should be answered by the data scientist, some of it by the domain expert. But part of the question is we all need to think about ethics. I was listening to a bit of one of the previous presentations, and it came up in our big discussion at lunchtime. We need to bake in security right at the very beginning of all of our projects. We used to leave the security questions and as the least important of the non-functional requirements until late in the day, and then they all went a bit pear-shaped and very, very expensive. This ethical question is going to be the same, because we could have invested an enormous amount of money in some of these AI systems. Some of them cost a fortune to develop. And then when we ask the ethical question, we say, oops, we have to bin that project. So we've got all these sorts of questions here. And of course, this is the one that really causes a big problem. It bumps into some of the GDPR aspects. It bumps into PII, personally identifiable information. It bumps into explainability as well. And so we have to think about all of these questions. Data. Well, some of you will have been involved in major data migrations from legacy systems into beautiful new shiny systems like ERP systems. And you know as well as I do that you look at all the data that you've got in your existing systems, your master data, and you suddenly discover you have to prune something like 70% of your master data that is irrelevant, it's old, it's inaccurate, and you put only about 20–30% into your new, beautiful, shiny system. But what we all learn is that within perhaps 3 or 4 years, that beautiful, clean, shiny data has become contaminated, and we need to start running data cleansing exercises so we can trust our data to actually do our management and analytics, to do our big data analytics. The data gets dirty very quickly. One of the indications is beginning to sort of filter out, and I've got a whole team of master students doing a project together of various aspects of AI success. How do we know, or how can we measure the success? What areas have successful implementations of AI? Is beginning to show that one of the key markers is the data objective. Is it part of our fundamental operating data? In retail, it's the prices, the amount paid, the quantity sold. In STEM, science, technology, engineering, and management, it's mostly the parameters which actually are those which we use to design a system, which have causal relationships with our decision criteria, on, off, up and down, what have you. So a very significant question about our data is it essentially from sensors, the measurements? Do we have physics models or scientific models which actually explain how the thing works? Which kind of leads us to a problem when we get data from humans. Assessment of people's skills, assessment of people's behavior is captured as words. When we look at medical diagnosis, a lot of it is based around medical notes. Words, and words. Some of it is based around numbers that have been measured, blood tests and so on. So we have to think about that data. We also have to think about the biases in our data. Amazon's failed HR advisory system failed because the training data only had information about males that being accepted and that women were rejected. I don't care how it found out or detected males and females. It's a long story. But the point was very small numbers of sets of data about women and they all got rejected. So why wasn't it? Didn't the system, or why was it unexpected that the system would do that? Or face detection. Most face recognition systems are trained up on or were trained up on a standard 100,000 photos of faces. 75% of those were white, middle-aged men. 1.5% was black, dark black women. It treated those as an outlier, nothing to be thought about. It wasn't interested in them, and so it couldn't see dark black women's faces. Data was biased. However, we also have an even as big a problem where we have whole categorizations missing. Things which we've never recorded, or groups of people who haven't been included. It could be ethnicity, it could be gender. If you're looking at medical data about drugs trials, you are very lucky if you ever find any data about the safety of the drugs for women, because they don't test it on women for a range of interesting and good reasons. So we need to be thinking about what type of data isn't there. Then we have to look at our pattern finding systems, our algorithms. The question is, do we actually understand what our algorithms are doing? Either in principle or in detail, both of those questions are important. And at one stage, I had a view that it didn't actually matter too much about these neural networks things. You just poured the data in and it kind of did huge multivariate type analysis. And it came up with weightings and huge matrices in the different layers of the system, of the neural networks, with feedback and feed forward and stuff. But then I took a kind of a view that says, it's just a pattern learning system. But then I saw a rather interesting video that convinced me that actually even these algorithms have biases, because a human has decided A, what the layers are, B, what the feedback loops are, and C, as importantly, what are the factors in those input data that are important. And this goes as well when we look at other types of self-learning systems. That is our human choices as to the types of algorithms or software code that we put into that can lead us to a very biased approach to how our systems work. We also need to understand, can we explain its decisions? And explainability is really, really important in things that affect human life. We're not allowed to have under GDPR and the UK Data Protection Act 2018, we are not allowed to have computer says with no human ability to interpret. And we have these other questions here as well. Do we know whether it makes the right decisions? And that comes into the metrics, which I'll talk about in a little bit. And how do we measure its accuracy and its effectiveness? Are the standard types of metrics that data scientists have developed over the last 5-10 years, and statisticians as well, are they actually useful? Are they telling the truth, but not only just the truth, but the full truth? And then we need to think about proving that it's working correctly. And because of commercial sensitivities and intellectual property rights and so on, commercial organizations are very, 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 very reluctant to tell us anything about how their AI systems are constructed, how they're developed, what sort of data they're tested on, how it was tested. It's trust us, we've tested it and its accuracy is whatever, maybe 95% or 80%. Problem is, when we start looking at the movement of these developed, tested systems from proof of concept in the labs out into the wild, where real people are doing, not experts and so on. It all falls apart disastrously. You know, retinal evaluations that I was reading just recently, someone built a system that took photos, that allowed people out in the dispensaries, optician, ophthalmic dispensaries, to actually take photos of the patient's eyes, the retina, and submit them onto the system, and it would tell them whether they had problems with their retina. It worked a treat in the lab under perfect conditions, with good lighting, with perfect cameras and so on. But you put it out into the dispensaries in rural India, and it all went seriously pear-shaped. It wasn't accurate. It rejected 20% of all of the photos. So you've got to go somewhere else. Lighting levels weren't good enough. It didn't upload properly because the internet wasn't good enough. So there's lots of interesting questions here. This page comes from an ENISA report, which they're rather interesting European organization based in Greece, who do a lot of interesting work on a whole range of topics. I've been following them for 15, 20 years. But they have this rather useful diagram that explains a little bit about the types of systems, self-learning or of learning systems, where the decision can be explained completely, if then else type of stuff, where the broad picture can be explained. It is doing broadly this sort of thing. And then the types of learning system, modern generation 3 neural network type systems, where we have no way of explaining in detail in any particular instance. We don't know what it's doing or how it's doing. Part of it is volume. There's if you look at some of the big language models, the transformer type, there's 175 billion parameters and weighting factors sitting inside it. No one can go through that. So explainability is another area that we need to be thinking about, and that as we develop, even the testing community needs to be thinking about this. Now, one thing I should say just before I get close to the end is that testing these systems is completely different, because the behavior of a trained AI system depends only on the training data. Change the training data, the behavior of the AI system will change as well. So how do you do the tasks that you normally do with system development, and particularly modifications? You use your test harness to basically prove full version is working, meeting the spec. And then when you do a few modifications, you change your test harness to take account of those modifications, and yet you still run the whole of the rest of the test harness to prove you haven't messed up some other functionality. You can't do that with these systems. So this is part of the method of providing more assurance and demonstrating to ultimately the regulatory agencies who are going to be involved with AI systems and the high-risk AI systems in the EU. They will probably be looking for something called a model card to actually help us to demonstrate to them and to our customers and everybody else that we actually have a well-specified and a well-tested environment or system. These two sets here give you some examples of what a model card might look like. They were developed by a couple of ethicists, the top ethicists at Google, a couple of years ago. They were fired, as it happens. So the content of a model card are these areas. And when you step through all of this, you can see just how it'll build up to delivering a trustable or trustworthy product. Now, the reason for talking about it at a conference like this on DevOps and testing and so on, is that basically many of the computing team involved with these are going to be in the best position to actually help provide much of what we've got here. Now, one last little point is that some of the metrics that quote accuracy can be hugely misleading. And this link here to a report about a company called Epic, a big organization in the USA that provides medical diagnostics type systems to many doctors across the USA and all sorts of health management systems. They were are busy promoting a system to identify sepsis in their patients very quickly. And they quote this accuracy factor of 80%. The problem is that the data is very heavily skewed. In real life, and there's an academic study that was done on using this, which shows that if they take up all the data from one hospital, they had about 38,000 results from, I forget, about 27,000 patients. And when they ran it through, and when they looked at the diagnostics that came out of the system, there was about 3,000 odd people who actually had sepsis, and all the rest, about 77%, or more, slightly more of the patients had no sepsis. So there's 77% accuracy in identifying most of the people without sepsis.
Richard, sorry to interrupt.
Yeah,
we've just come to the end of time.
Then we got a little bit of question time, haven't we?
No, we haven't. Unfortunately, we've gone.
Oh, sorry.
We got up to time. That's okay. But I didn't like to interrupt you. It's an interesting talk.
Okay. So I'll just finish this last little bit. But it missed out 88% of all the true positives, the people who needed to be diagnosed and treated. And that was a real problem. So we have to be thinking about our tests, our metrics. So what I want to leave with you is these 4 or 5 takeaways. Did we agree? Do we agree on the definition of AI? Do we understand our ethical questions? Can we trust our data? Can we even trust our AI? And then how do we provide evidence to support trust? And I suggest this is going to be through something called the model card. And the last little bit, useful reading. Yeah, thanks very much, ladies and gentlemen.
Thank you, Richard. Thanks so much. Apologies, we ran out of time, but great session. I really wanted to let it run because I had a lot of good material and research in there. So thank you very much, Richard. We'll go on now to our final session of the day, which is a low-code mini workshop, Challenges for Data Migration in Low-Code OutSystems Platform by Bruno Costa of Infosistema. So I will now see you in Bruno's workshop. Thank you. Joining us.
Sorry, I was just trying. Sorry, Lala.
No problem at all.
I was just starting here the share screening.
So, welcome to our last session. As you can see on screen, it's a low-code mini workshop by Bruno Valente y Costa, and Bruno's going to be covering challenges for data migration in low-code OutSystems platform. So, Bruno, thank you for joining us, and I will hand over to you now. Thank you.
Thank you very much for this opportunity to speak a bit about the challenges in terms of data migration, particularly in low-code platforms. This is something that I've been working on for half a dozen years now, and specifically in one specific low-code platform, which is OutSystems. But most, if not all of the things that I'm going to talk about today are applied across all low-code platforms, and connecting also with the topics of DevOps that you've seen during this call in the other sessions. So here to start. So when we are talking about low code, we see a lot of great features, some wonders that it's bringing to ITs. Some of my fellow presenters took some notes about that in previous sessions. But there's no denying in terms of the speed of development, automation that is being embedded into the platforms. So features like lifecycle management, inclusively helping things like DevOps, but all the low-code platforms, or at least most of them that I've seen, and in particular OutSystems, they don't have out of the box the capability of providing a bulk data migration. So they have integration capabilities, you can connect, you can do different things, but there's no easy way to do data transfer between the environments, between the applications. And OutSystems is one of the best ones out there. So in terms of the Gartner evaluations and things like that. So I also think that most of the others will also have these kind of issues that I am presenting and that I am talking about. Now, the question may come up about why would you need this to be relevant? And I will answer that by asking back the question, which I hope the answer is yes, which is, do you want to be better? And this is basically because when you see and when you are talking about data migration, you see there are lots of use cases, lots of situations where by themselves they help you to be more efficient. They help you to be more efficient in terms of what you are developing, what you are deploying. They help your DevOps, most certainly, and also help you correct errors. Things like we are hearing here, like customers have a zero tolerance for poorly performing software. This is something that is only coming even more prominent in our industry, in our IT industry, because getting it right the first time, if it was important 10 years ago, and actually I'm seeing a TechCrunch report from 2013, the attention span, the current attention span of the consumer with TikToks and other platforms is even less. So if something does not work right the first time, they will not try it a second time. And besides all of these topics related to doing better work, better IT development, and there's also the topic of cost, of investment. How does it cost us, the return on investment that you have? And I found this quite interesting analysis made by IBM, where IBM did an in-depth analysis of a big factory that they had, and they detected that 21% of their investment in the software development and quality assurance of that factory was being spent on data management. So data migration is definitely something you will need and you will use. Talking about useful scenarios, so situations to be more on point and so to be more clear where you will be deploying and why this is important. So why we have this mini workshop around the challenges around data migration, specific for low-code platforms, but why is this particularly important for the whole conference that we are talking about in terms of DevOps and low code? Well, one of the things that I believe is, I would say even the most important one, is improving the development quality. I was a developer 15 years ago, and I know the type of testing data that as a developer I created to test my applications. So I created basically cycles with numbers to just put something inside, or strings followed by numbers, concatenated with numbers to add that information into the database. And that's not either variable data or in quality data to perform tests. And so if I can migrate data from higher environments, from production environment, and copy that into the lower environments, I will for sure improve my development quality. I will also do things like focusing on what that study from IBM was saying, the effort that is spent in testing and validation. Well, I can reduce that a lot if instead of creating manually all test cases, I have production-like data available for my quality assurance team in the testing environment to be able to validate whatever developments I am executing. All of this translates into a minimization of production errors. So my production acceptance tests are made in an environment where I have production-like data. Obviously, then the use cases that the users come up, and we all know, at least everybody that's working in IT development, nobody comes with as much test cases as the users. So the final users are those that come up with situations that we never thought of, but they just come up with it and imagine it, and we unfortunately many times don't expect that when we are developing our tools, our solutions. And so we'll minimize these production errors if we copy that batches of that data into the lower environments. Other very useful scenario that we have is performance testing. And this is something that for the past 3-4 years, I think probably once a year at least, I have a client that comes to us with an issue around this, and usually after he had a problem. So not in a proactive way before having the problem, those also happened, but at least one a year usually appears when what happened was he did something, and he had like a database with a terabyte of data, a few tens or hundreds of millions of records, and everything was working all right. Suddenly he put some development that he did in production, and that stopped or made a huge, created a huge problem in the performance, perhaps in a similar application in that environment, perhaps in that same application, but something connecting, relating to that did not work correctly. And this happened because in the lower environments, there was no ability to test properly this situation because there was no testing data with the kind of volume that was needed. I remember in a conference that I was 5 years ago, I think. Now with COVID, it's hard to remember the dates, but in which a guy came to me and said, look, I need that. I need your product because last week we put something in production, and suddenly we noticed we had like a full half a day without anybody buying anything. And when we went to see what was happening, it was because we had like in our checkout routine, we had a combo box with the product selection, and we changed that to a combo box. It was something else differently. And now that combo box in production have over 1,000 records on it, 1,000 entries. And so the users were not able to select which product they wanted to buy. And obviously in the UAT environment, in the development environment, he had half a dozen records, half a dozen products just for testing. So he was able to do the whole happy path of testing. Well, he was working in low code. So reverting the issue was quite straightforward for him, and he just reverted to the previous version of the software that he had, but he had half a day in which things did not work, and he wasn't selling anything. So this is obviously something, usually, like I said, I think that at least once a year I have somebody that had this problem and comes running saying we need to do the testing, performance testing on our systems. Security testing, now with the political environment we are in, is something that is even more important, and with COVID also testing about penetration testing, mainly in banks, financial industry, even healthcare. We've seen several attacks in that regard, and you can only do this kind of penetration, white hacking tests in environments where you have good data. I mean, you can do them in others also, but to get best results, it's better to have good data in them. And when I mean good data, I mean data that has quality in it, variability, and that has volume in it. So, and you don't want to do this kind of testing in your production environment where you may corrupt or corrupt the data or even destroy it in some way. So you want to have a parallel environment or some other environment where these kinds of penetration testing can be executed. And then there are other use cases. So things like when you are, there are lots of people in low code that enjoy the environment, the platforms that are being used, are betting on it, but suddenly they have, for example, older applications, older solutions made in legacy, I'm going to call it this way, sometimes even like Excels or VBA applications, and they have data in it, perhaps even business critical data in it, and they say, okay, I want to stop maintaining this legacy application. I can deploy and create in low code or no code platforms. I can create this same solution in like half a day, but the business says I need the data, the old data that is in the old application. So you have to bulk load that into your solution. Or the other way around, you have built a great solution, low code and no code is very, in many situations, used as the front end. So something that is in the client interface, so it's the point of contact. And with it, you need to bring perhaps into analytics, a business intelligence solution data. And so you want to import, export from the low code and import into that other solution, a data lake or something, the data that is inside your low code or no code solution. So specific backups or specific exports, or in the case of OutSystems, for example, one of their best practices is around segregation of pipelines. So don't put your 30, 40, 100 applications all in the same pipeline, segregate the pipelines. And so when you are segregating pipelines, you have to migrate data between environments. So specifically, these are why you need to migrate data. And having the knowledge of why you need to do it, for DevOps, for all these business reasons, performance, quality reasons, the topic of our workshop comes up, which is, why or how, why can't I do it the old way or the regular way that I always use it? Either manually, and here by manually, I'm going to say like manual scripting. We have DBAs, we've had them for, since we had databases. Why can't I do it as I usually do it? Or even manually, there are dozens of ETL tools in the market. People are most used to them. They are very valid across all technologies. So why can I not use those ETL tools that I'm used to deploy and to basically migrate data in these low-code platforms? Well, the issue is intrinsically connected to what is low-code. So low-code is a platform, or no-code, these are platforms that allow you to develop your systems, to create your solutions based just usually on graphic interfaces. So you are not creating the underlying layers of high code. You are not coding, you are just dragging objects in the visual interface. And at least in most of the platforms, the maintainability, the persistence layer of the platform itself, this persistence layer is guaranteed by the platform. So you don't create manually the tables, you don't create manually the fields, the columns, the foreign keys, the data types. You create that in the platform's interface. This means that it is not easy to identify and manipulate that lower level because all that information is maintained and kept by the platform itself. What this brings into is those challenges that are the scope of this workshop. So you get a huge exponential effort if you try to do it manually or with regular ETL tools. Your probability of errors rises a lot, actually exponentially also. We are talking about low code, we are talking about agile development. This means continuous changes in the IT system you are developing. And as such, what you get is continuous changes also to the persistence layer. So you have to keep updating whatever scripting, whatever configuration in an ETL tool that you do. This means also the knowledge that you need to have is something you have to guarantee across your whole development cycle. So you always need people with specific knowledge in the platform, in the database, to be able to do the migration. There may be performance issues. I'm going to talk a lot about that also when I'm detailing this in terms of the OutSystems platform. And in resume, you have basically time to market, risks and costs that you don't want to when you go and you have this manual scripting or using standard ETL tools. So let's go into details. Now, the first part is this complex meta model that I was talking about. So for the low code or no code platforms to work, and namely OutSystems, it keeps the information of the entities and the fields and the data types and the foreign keys between them consistent in its own system or own platform meta model. So there are specific persistence layer that is not related to the business itself. So it's related to the platform, and the platform knows that when the business or your IT developer for the business creates an entity, it has to store that data somewhere. But the specification for that entity, where an entity could be, for example, an entity named car that has wheels, that has an engine, that has windows. Those could be like entity fields. So that information has to be stored someplace. So the creation of the physical part, the physical structure where that information will be stored is basically delegated to the platform, the low-code platform, and the low-code platform will automatically create the database structure. So a table with a column named engine, a column named Windows, a column named wheels, or whatever the fields defined for that entity, and it will keep this information, the platform itself. So you visually create the stuff, and the platform deals with everything below that. The issue here is when you are migrating data, that underlying structure that is persisted in the database, in SQL Server, in Oracle, in MySQL, whatever it is that the platform works on as its underlying persistent storage database, that specification is not visually accessible to you. You are not supposed to interact directly with that because it's the platform that is maintaining that. And if you break that in some way, the issue or the problem is that the platform, the low-code or no-code platform, may stop working correctly. And if you do something today that may break that, perhaps you'll notice that today, or you'll notice that 6 months from now. And so there is no way of knowing when that error, when that breaking will come up. And it can be in a good time, or it can be in a very, very bad time. So this is the issue with migrating data in OutSystems and other low-code and no-code platforms. It's this complex meta model where they store the information of where they are going to store the business information. And you have to look into this meta model to understand, okay, this business information I want to migrate from point A to point B is stored in point A in this place, is stored in point B in the other place. And the table, physical table names, they may be different. The number of columns on tables, they may actually be different, because in development environment, you may create like one table, and then because the developer created that entity, and then it added 4 or 5 fields in that entity, then it deleted one, then it added another one, it made some tests, added 2 more, deleted 1 more. So it's development environment. And the platform itself, it may keep changing the table, dropping and adding fields, or it may just mark in its meta model saying, like OutSystems does, oh, this field is no longer active. So a table in development may have 15 columns. In your quality environment, it may have 14 columns. And in production, it may have 13 columns. and it's the same entity, but two of the fields are inactive in development environment, and in the quality environment, one of the fields is inactive. In production, all of them are active, for example. And those inactive is, for the platform, is just like they don't exist, but they are physically there. And the names of the fields themselves, it's the platform that defined them. So a column may have one name in one environment, may have a different name in another environment. But in the meta model, it's saying, oh, this is the car entity. And so the car entity is stored, the information is stored in this specific table. And in the production data model, it points to the physical table. In the quality of the meta model for the car entity points to another physical table, and so forth in each entity, in each environment of your pipeline. And so you need to always read the low-code platform meta model to understand where the physical business information is, to then build your own scripting. Talking about when you're trying to do this manually. And by manually, again, I'm thinking about manual scripting or standard ETL tools. Well, one of the issues, or the main issue I would say, is related to our own minds, which is when you are thinking about, you are going to migrate like 5 tables, 5 entities, you go, you see where they are, and then somebody tells you, look, now I want you to migrate 50 tables. And you say, okay, for 5 tables, I took 8 hours. Well, for 50, I will take 80. You just multiply it. I mean, it makes sense. It's something that for us, it's the idea that we have when we are estimating. We think about linear progressions. We think about, okay, if I took this time to do 5, to do 10 more, I will take 3 times more because it's 15. If I do 10 times the value of 5, it's 50. Then I will multiply the time it took me for 5 by 10 also. And so you are used to linear progressions, not exponential growth when we are doing estimations. But exponential is what happens when you keep, in this case, when you keep adding new things, for one table, for example, in terms of number of connections, you add a new one, then you get an exponential growth in terms of the number of relationships that you probably have. Besides other things like different types of constraints, circular references, specific corner cases that suddenly, yes, perhaps it was the effort you were putting in each new table you were migrating was similar, but then there came one that had binary objects in it, and you say, oh, I have never migrated one of these. Now I have to switch procedures, do something different. This one has unique fields in the destination. If it already has data, how do I deal with this? It's a different situation. And in the middle of all of this, because we are talking agile, because we are talking about changes, fast development, you have to keep aware that if between migrations, things change. So you have to basically redo and review a lot of the work you are doing. So here I was asking for a thought experiment. You are migrating a single table. So think about, okay, I want to copy information from one table, from one source into one destination. What do I have to do? What kind of scripting? A select script, export that, the result of that select to some place, and then do an insert script. On the other side, perhaps my export script, the select script already builds the insert instructions, for example, and you build that and you have a number in your mind saying, okay, this is a single table, I'm copying that from one place and I want that data into my destination. But like I was saying, what if it has several foreign keys to other entities, to other tables? Think about what will happen in the destination if I insert in this single table yet, and those other tables don't have those foreign keys, the records to which those foreign keys point. What if some of the fields in the table this single table that I am migrating are mandatory or are unique? What if they, instead of pointing into other business tables, so instead of being a business connection, is a connection to a system table of the platform, of the low-code platform that I am using? Usually they have things like users, roles, modules, even connections to other types of information like emails that are sent by the platform itself and things like that. So how do I deal with that? How do I migrate all that information for this single table, just one table that I want to copy from one point into another? You have to analyze that, you have to build the script, you have to test that all for a single table. But you add more tables, and then suddenly you start seeing, okay, perhaps I have a circular dependency. Perhaps this table points to itself in another record. How do I do this? I have to do an insert, then I have to do an update of the record to update its self-reference. How can I, and when I have multiple tables, how can I do this in terms of which is the priority of the tables that are going to be imported, which are the first ones that have to be loaded, and what are the update instructions, so I guarantee the same foreign key and connections between all of them. So your time to market increases with the higher level of complexity. And you are doing this for a single table. Imagine when you start doing it for an increasing with more. Now, talking about something different and trying to speed up a bit. Errors. Thing here is, and here I'm approaching what I'm going to finish, which is saying, look at products already made. Like I mentioned before, low-code and no-code platforms are very sensitive in terms of the metadata and the specifications that they have. That's what they base themselves on to show you that low-code environment where you don't need to program at a high level and you just visually program. And so if you want to avoid situations, and this is something also, this expression, well, Murphy's Law, everybody knows what's Murphy's Law. If it's going to break, it most certainly will. But this one is something that I also hear a lot, which is people saying, well, I don't get it. It was working fine on my machine. It's like every time that a bug appears, I'm going to hear somebody talk about this. Yes, he doesn't have the data. He doesn't have the same situation that happened in the other environment happening on his, because the environments are not the same. So when we can get those environments, like I was saying in the beginning, even to improve your own DevOps, even to improve your development quality, you need to get those environments as common as possible to be able to do the best development possible. In terms of errors, the thing is, every code has errors, so your scripts will have errors. But the sensitivity that low-code platforms have for those errors is much higher. And here, pointing at the products, is what happens is that if a product has an error, because it's the product, by definition, the company that produces the solution will be able to understand that it had an error, correct it, and deploy a new version with those corrections. So what this means is that every client will benefit now from that correction, either the one that got the error or the future ones. So that passed through a similar situation. Perhaps they were already using the tool, but they didn't have the conditions to provoke that error. Perhaps because they didn't use those types of features in their low-code platform, or because they didn't do that type of entanglement in terms of dependencies or characteristics. So using products is a way basically to diminish the probability of errors. It will always happen, but the thing is, if somebody else already caught it, the product already evolved to avoid it. Talking about human resources, and because it is my firm belief that the low code and no code capabilities and the platforms and the exponential growth that they are currently having is also quite relevant in this regard, which is you don't need to have, well, it's a fast way to get people to do something. Obviously, you can do also very bad code using low code platforms. Automation is trying to help in that regard. That's my personal opinion and what I see, particularly in this platform that I know quite well. in terms of helping even junior low-code developers avoid mistakes, because the platform prevents things like security issues and things like that out of the box. Several things that are already being helped in that regard. But you always need to take this into account, resource allocation and expertise, when you are doing any type of project. And data migration should be looked at as similarly as a project in IT. And in that, and the reason why, like I'm mentioning here, is that it's not only the development of the scripts, you have to do corrections, you have to do changes, look at corner cases, performance testing, quality assurance. So all of that you are used to doing into your any type of IT project, and even the closure, be it a final sprint, stand-up or whatever, to the management meetings, the governance of the project itself. So everything you do in a standard IT project, you also do in data migration project or data migration task within a project. So this means that in terms of human resources, you also need to have the specialties, that the skills that are required for these specific tasks. This may be, and I actually don't know anybody that joins all three of them, but broadly, you basically have somebody that knows well your low-code platform in terms of architecture. So that metadata layer that I was saying, where the low-code is being stored, or the information is being stored for the low-code platform to be able to, in each environment, say where are the physical persistence layers, where the business keeps that information. You have to have the DBA, so the one that is able to understand scripting, and you have to have, and this is for enterprise level even more important, the performance consulting. Usually the DBA may also have this kind of skills, but if you are talking about a simple developer in terms of SQL, he may not be aware of all the specifics of a database, and performance can be a very big issue. And nowadays, low code is being used, mainly the biggest platforms themselves, for very large enterprise development, so even mission critical solutions. And so performance becomes a big issue when we are talking about terabyte sized databases and hundreds of millions of records. So using a tool, again, helps in this regard if the tool is well made. I was talking about enterprise level because all of that I'm talking about is just exacerbated or even more impactful when we are talking about the enterprise deployments of low code and no code solutions, because the complexity increases, means that you start to ask for things like the previous talk was mentioning GDPR and confidentiality. You probably don't want to migrate data from production into the lower environments. You want to migrate that data but scrambled, so you don't have confidentiality issues with that. Perhaps don't want to migrate a full terabyte of data. You say, okay, but my environment in the UAT is with a smaller infrastructure and I can do just performance testing with half that. So I want to do data filtering. I want to do unmanaged or programmed executions. I want to do copy of other parts or other features of your low-code platform. In the case of OutSystems, for example, they have workflows embedded into the low code, and so you may want to copy that also, and other features and other things. So adding into that, you may have things like you are building not in Java or C# or things like that. You are building in low code, which means that this is a platform on top of which you are building. The platform itself has upgrades, meaning that the metadata layer that your DBA was analyzing, building the scripting, or your low-code OutSystems architect or whatever architect was looking at to build the scripts, suddenly changed because the platform has a new version, and the work you had done previously, you have to redo it again because you have a new platform version that changes the way the platform itself keeps that information. And adding to this the part of performance. In enterprise level, performance is critical because sometimes it may even mean that you are not able to migrate unless you are using the right tool and the right procedures. Because I've seen migrations with clients that they were not able to do because if they were doing them manually, the way they were doing it, it would take them months to finish execution. So when you are talking hundreds of gigabytes, but it was literally over 1 month of execution if it was left to run with the current scripts and network that they had and so forth. So the solution, well, what I propose and what my experience tells me is that you should use a specific tool. I give here an example for specific for OutSystems, but independently of the no-code or low-code application that you are using, the platform that you are using, if the platform does not have a tool for data migration embedded into itself, as most of them don't, then you should search for a specific tool, supported tool that allows you to do that. This is not magic. This is something obvious. You don't want to reinvent the wheel, but sometimes people think, oh, but it's just one application. It just has 20 tables or 30 tables, and the tool costs $1,000. So I'm not going to do that. I'm just going to do them in-house scripting. Well, again, these challenges, you should be aware of them. Obviously, if you have a very simple data structure, perhaps it may be more in terms of return on investment, a direct financial return, it may be more easy to say, okay, we'll do it internally. But when you look at the risk, when you look at those other factors like time to market that we were talking before, probability of errors, looking at a specific product tool on the market already validated is always the way to go. What should you look at? Well, these are some of the vectors that I would like to stand out. So look for off-the-shelf products. So not things that you can just go on the marketplace of your low-code or no-code platform, read reviews about it, and install it directly. So instead of something that's what I say an accelerator that somebody says, yeah, I can do that, I have a tool, but then you have to buy my services for it. Look at demos. So things like, remember me talking about the part of the knowledge, the skills needed to use it. So being able to do something that you say, okay, even my grandmother would look at this, and I mean, it would, looking at the demos, it would take her 2 minutes to be able to execute and use this tool. So with a good user interface, a good UX, we are talking data migration. So in DevOps and in these situations, there will be many different configurations. I've seen clients saying, okay, I need this for one specific project, then the development team knows that the tool exists, and they say, oh, for this other project, I also need it. So be able to store configurations. We are talking about in Agile, in low-code and no-code, everything changes very fast, either by client requests or, well, changing definitions and everything. So be able to store the configurations, change them and load them back, very important. Look at all the features each tool has and see how they adapt and how they focus on you. I would say DevOps ready. So look at something that you can use to improve your DevOps. Lots of talks on this conference mentioned and went around DevOps, testing and everything. So this is something that I find relevant, and some look at performance, especially if you are a large enterprise, but expect always growth. And if you have something that works today and in 3 years will keep working, all the better. Compare the tool features and capabilities. I'm going to jump here just to talk about 2 of them that I think can be relevant in the low code and no code environments, which is the capability of doing incremental migrations or delta migrations. So think about the use case of you have production environment and you want to copy that data into a lower environment. And you do that today and you do that 1 month from now. And you want to update whatever happened in your origin, into production. If something was deleted there, you want to delete in the destination, in the quality environment. If something was created, you want to create. If something was updated, you want to update. So you want to keep that copy, that delta, that incremental migration of what was happening to improve your DevOps, to improve your testing capability. And so this is quite a nice feature, I think, relevant. Another one, more technical one, is be able to keep the primary keys. And this relates particularly to no-code and low-code platforms, because by default, when and specifically my experiences in OutSystems, these platforms create IDs with auto numbers, sequences in Oracle or auto number fields in SQL Server, for example, and so when you are migrating data and you do your insert instruction, you don't want suddenly you have a record with ID number 1000 in one place and ID number 10,000 in the other place. You want to keep the same ID in both. So having the ability to do this will, for example, if you are debugging an issue from a client, you can say, okay, in production, it was this record with this ID that was migrated into the other place. So it helps you in many different situations, and so I thought it was worth mentioning, particularly over here. Then look at other things, not only migration, but also import from other solutions, export into other solutions. Your low code is part of an ecosystem, so there are other things you want to bring data from out of it into it, and vice versa. Not only migrate between environments of low code. For your DevOps, perhaps there are other business cases. And when you are looking for a tool, I think because there will be a cost involved, and somebody has to pay for it, so a business has to be built. And around that, you should look at everything that such a tool can offer in terms of business value, and not only at the specific use case that you are looking at. So if you have a specific DevOps use case where you say, oh, I want to copy this data from production to the lower environments to improve my development quality, that's great. But if you can add into it saying, oh, but the risk analysis team in the bank would like to have this information in the data lake, and with this tool, I can export that directly into it. And there are these half a dozen VBA applications made that nobody even knows how they maintains that code anymore, and they are even a security risk internally in the institution. And I can build that in a couple of days in OutSystems, and with this tool I can import that data into the low-code platform. So look at other use cases, looking at the full feature set of each tool that it gives you, and try to imagine other potential use cases. So you can say, okay, I'm not going to do it manually. I'm going to buy a tool. These are the reasons, but this tool will allow me to do these extra things. So I will be able to have a bigger return than just the initial use case that I'm looking at. And look at references. I mean, if you are buying a product, look at what they say for it. Most of the tools also have a marketplace or something where third parties can add information. And so look into that, see what other developers are saying about them, validate them, so you can feel sure, okay, this works for my use case. If they have a trial or something that you can use, that's always a great option. Just ask for that trial, just implement it, see how it works, validate it prior to buying it, obviously. So we are 15 minutes from the end. So I had now 10 minutes where I would like just to specifically for the OutSystems platform, give you a quick demo of this tool, which is Data Migration Manager. So let me just share here the screen on that. You can post videos about I was looking at the video here. You can post questions if you have them for us to look into it. I'm going to share my whole screen. Yeah, you guys can see my whole screen here. So you're probably seeing my screen. I'm going to open up here this quick video. This is a 1-minute video just showing the migration of data made in 1 minute using this specific tool. So you see one app that has the data, the other app that has no data, and the developer here is just saying, okay, I'm going to use the tool, this tool called Data Migration Manager, and that we provide for OutSystems, and he's just selecting the things that he needs. Notice that he's not building scripts, so he's visually select, because this is people who use this will probably be local developers, and so we don't want them to create scripts. We want them to visually look into what is being done. They know the high-level entity names, for example. They know that there's a car. They don't know the physical table name where that car information is kept. And so he did the migration of data. He refreshed destination environment, and there's data over here, and he did that under 1 minute, all visually. The important part here is that everything is done visually. So because we are working in low code, and in low code, that's for all the reasons that I was mentioning. That's important. So in this case, in the case of OutSystems, you have a marketplace, which is called the Forge. And this is the tool. And the tool, you see inside the marketplace itself, there are reviews. You can see the reviews. You can look into the versions to see if it's maintained or not. This is also quite important because I was saying there are bugs. All software has bugs. So it's important for you to see how updated is, how supported is every product that you find and that you use. And I'm just going to jump right ahead. There's an online manual about the tool. You can install directly from the marketplace. So it's a product, no services connected to it. And when you want to do data migrations, similar to what I was showing in the previous 60-second videos, but now with me taking a bit more time to show it myself, you select the environments you want to migrate data between. I could go application level and just select application, but I could also go module level and then select the other the modules and entities level, what it is that I want to do. And I can filter automatically the application. Notice that here it says I have 55 applications. And this tool, the Data Migration Manager, is already accessing the metadata layer of both origin and destination to tell me there are 55 applications that match, that exist in both environments. These applications may even have different names in OutSystems in both environments, but in the metadata of the platform, it matches as being the same application. So I can filter it and say, okay, I have here a testing application and I want to migrate data from this application. And I can select the entities that I have here available, and I can pick and select them one by one. If the entity has dependencies, foreign keys, even if those foreign keys are not enforced at the database, we can have, through the tool, we can have it automatically detecting the dependencies and adding the dependent application, the dependent tools, dependent entities. I'm going to select here all, not only the one on this page. Notice that I have 75 applications in this module of this application, and he selected 76 because there's dependencies to entities that are not in this application that are in other applications. So the tool automatically detects that and tells me, okay, this is the dependency, and so if I want to keep data consistency in the destination, I have to guarantee this, and I have to also bring data from that other other entity that is not in this specific application. And we have other configurations here. Of note, the Delta migration I was mentioning, the migration of information that is connected, so foreign keys to system or platform, low-code platform system tables, also being synchronized between environments, the capability of in each entity apply filters or apply things like special actions, saying, for example, that I want to scramble information or anonymize or replace information by a specific value, or copy the record but put null in this specific information. Saving configurations, so I can use them again, I can save them, they are available over there later on, and I can just say, okay, execute this and start this migration. And then it will jump into a migration screen, show me a log, a running log, it will refresh, update the information in terms of what is being migrated, and I have here a history in this development environment of previous migrations that were done. And this is probably, I can go back here, not the dashboard, I wanted to go to the stats, go back into that screen. And yeah, this will probably take a while because it's 860 megabytes, so 500,000 records. Yeah, it will take a while to run. So I would just leave it here and say, are there any questions at this moment? Just Alec, I think you are talking, but you are muted.
Apologies, just I had my microphone on. Great. So we open up for questions. I think that was a fantastic workshop. Thank you very much. My colleagues and I were just saying in the background, there was just a huge amount of information and demo, useful advice, all packed into an hour. So that was fantastic. Thank you again. Excellent. So
okay, while we wait for it, for the questions, because I know they usually take a while, just to tell you who I am. So I'm part of InfoSistema, basically part of an IT group, and we are based in Portugal. Please come and visit us. We have a very sunny weather right now. We are very famous for our beaches and for our historic sites.
I'm booking my ticket now.
I'm going to say that I think this weekend I'm going to have it's going to reach 30 degrees Celsius, and I'm looking out of my window and I'm seeing that all the weather is fine. Come and visit Algarve, come and visit Lisboa and the wonderful region of the fairy tale castle of Sintra, and we are very, very welcome. You guys are very, very welcome. It's what I wanted to say.
Thank you.
This is where we are located. I don't know where you guys are, but we are over here. It's this small rectangle in the point of Europe.
Excellent.
Any questions for now?
No, it doesn't seem to be any questions coming in. I'm just looking, I think just somebody thank you for an insightful presentation. I say it was absolutely excellent, we thought.
Yeah, great. Well, you have my email, so if somebody, even if people afterwards are reviewing the presentation, I shared the invitation link with several people that were not able, they came with feedback for me saying, oh, I'm sorry, I will see it afterwards. But when it's available until end of July, I think, the presentation, right, Alec?
Yes, we'll send a link so people can view it afterwards.
I had several people that contacted me and told me, look, I'm sorry, I will not be able to attend at this time, but they would see the presentation afterwards. So if there is any question that everybody that is seeing this after, not live, but in the saving, you can use my email here and just ping me with any questions that you have. Feel free to do that. I think the email here is on the footer, so you can see into it. PPT. Yes, I can share, Alec. I can share it with you, and you guys distribute that afterwards. Is it possible?
Yes, sure. We can do that.
Okay.
Thanks, Bruno. You can see your email, bruno.costa at
infosystema.com.
Thank you.
Yeah.
Thank you very much indeed again, Bruno. And I just want to say a really big thank you to all our speakers today and participants. It's been a fabulous session. We had lots of questions and discussion. I just wanted to, again, Bruno, thank you for a great end to the day with the workshop. And I just wanted to take one moment just to thank the team at UNICOM who've put a huge amount of effort into the event, into organizing it, and I'll just share the screen so you can see who the people are and put some faces to the names. This is our team behind the event. They've worked for many months in terms of putting it together, organizing the event, and put a huge amount of effort. We actually do have another conference on Agile, DevOps and testing, people, process and technology, which is in a slightly different time zone. It's going to be for the Asia Pac time zone for Australia, New Zealand, Singapore, India, and that's taking place 20th and 21st of July. And we've actually got a big conference coming up in London on the 20th of October. We've got Test Expo combined with Agile and DevOps Expo and Low Code Expo. That's going to be on the 20th of October in London, and we'll also be streaming it live. So if you can't join in person in London, you can also come online on the 20th. And we'll be sending some more details too shortly on that. So again, thank you very much, Bruno, and thank you everybody for attending.
Thank you, and thank you all the organization. You guys are wonderful.
Thank you. Thanks for your kind words. Have a good evening, everybody. Thank you. Bye.
Bye-bye, guys.
Bye. Bye.